Welcome everyone to my channel Techify with Adil. Hope you are doing good. So from here we will be starting to discuss about Azure, especially the certifications for Azure Fundamental 8 AZ-900. So this, who requests this certification, who should be doing this exam? The answer for this is anyone who is interested to start their career as a cloud technician or cloud computing admin, and who wants to move into cloud, they all can do this certification. Why in specific Azure Fundamentals? Because the Azure Fundamentals will cover all the topics of Azure with the basic level as a fundamental level. So you will have an idea of every other certification in Azure, the basic structure, how the Azure works, and how the cloud computing has been designed. So all these things you will be able to learn from this certification. So this certification covers the architectural components like computing, networking, and storage. So the types of storage, because the cloud contains different storage types, so we will be learning about each storage types, and the networking, how to create subnets, how the network works, and all these things, and computing starting from virtual machines, how the things are created, how it's linked. All these things can be learned. Then when it goes to skills or working experience related knowledge, we will be learning about infrastructure management, database management, and software management. Also it will start from the basic, like what is cloud computing. That is the very first topic we'll be discussing here, what is cloud computing. Then it goes to types of clouds and Azure clouds, then their models, then how the scalability, how it gives you the availability, what is the purpose or what is the main reason of now enterprises moving towards cloud from their on-premise thing, and also a lot of companies from their hybrid they move fully cloud based. So we'll be seeing all these things in our video. Okay, so Azure Fundamentals. Okay, so the first topic we'll be discussing is the describe cloud computing. So here the details we'll be discussing, the topics we'll be discussing is introduction to Microsoft Azure Fundamentals. We'll have introduction about that, then introduction to cloud computing, then what is cloud computing, describe the shared responsibility model. So we will see what is shared responsibility model, what are the types. So then cloud models, then we will see the consumption based model. So in the exam point of view, like preparing for the exam AZ-900, the important thing you have to take note is the weightage on the topics. So like basic cloud portions, like basic cloud concepts, it will cover like 25 to 30% of your questions. Then your architecture and services will cover 35 to 40. Then your Azure management and governance, so identity and security portions all covered under this, will be 30 to 35. So it is almost like equally weighted, all the three portions. So you will have to concentrate on all the three portions. So here we will see a small video about cloud computing. So this is actually from the Microsoft Azure learning portal.
What is cloud computing? Just like when you shop for your own computer, cloud computing lets you choose the power and features you need to run your software. The difference is, with cloud computing, the PC is in a cloud provider's data center instead of physically with you. This lets you pay for only the services you use. Plus, someone else gets to manage the upkeep of the computer. Each cloud provider will have their own selection of services to choose from, but the basic services provided by all cloud providers are compute power and storage. Compute power is how much processing your computer can do. For example, when buying a home computer, you may choose a computer with 8 gigabytes of RAM and the latest processor to run the software you need today. But as the load on the computer grows, you find that it slows down. With cloud computing, you can add and remove compute power as you need it. This saves on costs, since you only pay for the resources you use. Storage is the volume of data you can store on your computer. A traditional computer has limited hard drive space. Over time, you may have to run out and buy another hard drive to store more data. With cloud computing, you can request more storage as you need it. Cloud providers manage the upkeep of the computer, so you don't have to. They will make sure that there are backups, that the operating system is up to date, as well as making sure that everything is up and running 24 hours a day. So as your business grows and your computing needs change, you can quickly bring on new computing resources in a cost-effective way.
Next, we will see the different type of structure in our IT. So it's like SaaS, PaaS, and infrastructure as a service. Then it's on-premise. The on-premise is one well known, that's been in use for a longer period. So you can see here. Okay, so here you can see the on-premise is all actually the dark color, dark blue represents is all managed by the customer. So if like I'm having a database, or I'm having some email server or some file server hosted, so all the responsibility is on the enterprise side, like from physical data, the network, the data center, the operating system, network, applications, identity, account, and the devices whatever been connected to, and the information need, everything is falls under the responsibility of the company, the enterprise, or the IT team. Then we have this infrastructure as a service. So for the infrastructure as a service, they provide the infrastructure. So the infrastructure, so the all the other things what comes over the infrastructure is all on the enterprise side. Say here the physical data center, the network, the host. So all these three will be covered by the cloud provider. The anything falls over that will be managed by the enterprise. Then we have this platform as a service. So here you can see data center, network, host, and operating system is completely handled by the cloud provider, that's Microsoft here. Then the network controls, applications, and identity and directory infrastructure, this will be in a shared basis. So it's a combined responsibility of the customer and also the Microsoft. Then information, devices, and account identity is on customer. Then the last one is software as a service. So till application level, so is all controlled by, or is all managed by Microsoft. Then identity and directory infrastructure is shared responsibility, and anything falls over that, like identity, accounts, devices, and information and data. So all these things will be on customer side. So in moving forward, we will see in detail about all the structures as well. So for at this point, you just have a basic idea, like software as a service, platform as a service, and infrastructure as a service, all the three different types of services provided by Microsoft. And this the basic differences are the who takes the responsibility, or whose responsibility is for either the customer's portions and the Microsoft portion. Okay, the shared responsibility model. When you're talking about the shared responsibility model, so as we seen in the previous slide, the SaaS, PaaS, and also infrastructure service, we see some shared responsibility. It's not fully on one side, like it's not on fully on customer, also not fully on the Microsoft, unlike the on-premises. So here we see, when using a cloud provider, any cloud provider actually, the information and data stored in the cloud we are responsible for. Then devices that are allowed to connect to your cloud, like mobile phones, like bring your own device, whatever it is, or company owned devices, or users devices, computers, whatever devices we are using to cloud to the connect to the cloud. The device which we are using to connect to the cloud, that's an important thing to take note of. Not the devices that are hosted in the cloud, only for the devices that we are using to connect to the cloud. Then the accounts and identity of the people, services, and devices within your organization. So all these three things is always the responsibility of the customer. Then cloud providers is always responsible for physical data center, network, and host. The service model will determine the responsibility for other things like operating system, network control, application identity, and infrastructure. So these four things will be decided based on which service you take. Are you taking software as a service, or platform as a service, or infrastructure as a service? Based on that, the responsibility will change. Then this is a cloud models. So this is a basic cloud models: public, private, and hybrid. So when we see public cloud, so no first thing is no capital expenditures to scale up. So because it's totally on the public it's a public hosted cloud, then applications can be quickly provisioned and deprovisioned. Then organizations pay only for what they use. This is a very important thing: pay only for what they use. Then organizations don't have to have complete control over resources and security, because this is handled by the cloud provider. Okay, then this is private cloud. Organizations have complete control over resources and security. Data is not collocated with other organization data. Hardware must be purchased for startup and maintenance. Organizations are responsible for hardware maintenance and updates. So this is a private cloud. So what is the basic difference, or what is the important difference, how we can understand the public and private cloud is: for the public cloud, everything is managed by the service provider, meaning we will not have any idea like which resources has been provided for which customer. Maybe another customer might be using the same hardware of what we are using. That may be partition secured, but still we may be sharing the same resources. That part will be totally blind for us. We will not have any idea about that, because the hardware is not managed by us. So it's just we pay for the service what we are using, and we use the service. That's the public one. Private is uniquely for our organization. So we have a cloud setup, but that hardware, everything is fully and was only utilized by our organization or our company. So it's not shared to the public, it's not shared with other enterprises. So that's the private cloud. So other techniques and other backend structures is all same, just the how we are going to, it's public and the other one is private. Then comes this hybrid cloud. Hybrid cloud, as the name says, is going to be the combination of both. So provides more flexibility, because when you go for cloud, there will be some kind of restrictions when you're moving some applications, or we're moving something. We will have some restrictions, which actually you will understand when moving forward. You go in very depth on this Azure. So in those cases, we will have to use the private, or we have to use the on-premise thing. So when you have a hybrid cloud structure, so those whatever need to be hosted in the on-premise can be hosted in the on-premise, and whatever to be moved to the public cloud can be moved to the public cloud. Then you can have a hybrid, which is more flexible for us. Then organizations determine where to run their application. So they are the one who's deciding, so to run in the on-premise or to run in the cloud. Then organizations control security, compliance, and legal requirements, since we have more control over the structure. Beyond the public, private, and the hybrid, here we have some more topics to understand. So this is multi-cloud. In a multi-cloud scenario, you use multiple public cloud providers. So in the earlier slide, when we are saying about public cloud, we are talking about one cloud provider, single cloud provider, like maybe Azure, or it's AWS, or it's Alibaba, or Google, like that. So when it's multi-cloud, we have multiple clouds. Maybe there's multiple scenarios. Maybe a company started with a cloud provider, then they need to for new applications, or in future they are just moving to another cloud provider, or they have their resources in two different cloud providers, they need to combinedly use it. So those kind of infra is called as multi-cloud infrastructure. Then Azure Arc is actually a set of technologies that helps manage your cloud environment. So the technology whatever is being used to manage our cloud environment, those comes under this Azure Arc is a technology actually to help manage your cloud environment, whether it's a public cloud or solely on Azure or private cloud in your data center, hybrid configuration, or even multi-cloud environment running on multiple cloud providers. In all these scenarios, Azure Arc can be used to manage. Then we have this Azure VMware solution. So generally we know there may be scenarios where your VMware, we have already data in our VMware, the setup. So when you are moving this VMware things to your Azure, there comes this Azure VMware solution. So when we have already established VMware structure in our company, the Azure VMware solution lets you to run your VMware workloads in Azure with seamless integration and scalability. With the same integration and scalability, we can run it in the Azure. Okay, next we see this difference between capex and opex. Actually it's a capital expenditure and operational expenditure. So what is this capital expenditure and operational expenditure? These are the two kind of expenditures we need to take note when you are going for cloud or migrating to the cloud. So capital expenditure typically is a one-time upfront expenditure, like to purchase or to secure resources, like it can be hardware resources or software resources or can be services, whatever it is we going to, it's like an investment. Then operation resources, spending money on services or on products over the time, like based on whatever we are being utilizing, we're going to pay it month-wise or yearly, right? So that's called your operational expenditure, the expense you spend on your operations. So here example is like new building, like parking lot, data center, then buying company vehicles or whatever investment you're going to do, that comes under your capital expenditure. Then your operation is like run operations like rentals, like leasing or services signed up for cloud. So all these things comes under your operational expenditure. Cloud computing falls under operational expenditure because cloud computing operates on a consumption based model. So if you're not consuming the resource, then you no need to pay for that. If you're consuming a resource, then you will have to pay for that. So that's why it comes under your cloud computing falls under operation expenditure, OPEX. With the cloud computing, you don't pay for physical infrastructure, electricity, security, or anything else associated with maintaining the data center. Instead, for the IT resources you use, that's all we pay. If you don't use any resource this month, you no need to pay for any IT resources. So then comes consumption based model. So this consumption based model has many benefits. So no upfront cost, no need to purchase and manage costly infrastructure that users might not use to its fullest potential, the ability to pay for more resources when they are needed, the ability to stop paying for resources that are no longer needed. So these are the benefits or advantages of using consumption based model. So cloud computing is the delivery of cloud computing services over internet by using a pay as you go servicing model. So plan and manage your operating costs, run an infrastructure more efficiently, scale as your business needs change. So you pay only as per your usage. So that's the consumption based model. So you don't need to upfront buy. You don't need to maybe we might once in a year, like New Year, say example, we have a e-commerce company. So in the e-commerce company, there might be hike in resources usages, like a hike in the sales. So there will be more resource usages particular months, maybe December, January, then mid or during some festivals only. So in normal cases, what we have to do is we have to purchase those required infrastructure. We have to invest and keep it unused for all the remaining months of the year. When it goes for your consumption based model in the cloud, what happens is we can only increase your resources for that particular month when your resources is much needed. There will be when there is a high sales, then you can increase your resources. Whenever there is no high sales, then you can reduce your resources, then you need to pay for those unused resources. That's the advantage of this consumption based model. This topic will be describe the benefits of using cloud services. So we will be seeing about the benefits of using the cloud services. So the first thing we will be covering is describe the benefits of high availability and scalability in cloud. Like availability and scalability in cloud, what's the things related to cloud. Then we will be seeing the reliability and predictability in using the cloud services, of benefits in using this. Then we will see the security and governance benefit in the cloud usage. Then we will see the manageability benefits in the cloud. So we will be seeing all this: availability, scalability, reliability, predictability, security, governance, and manageability. All these are the major benefits of using the cloud services. So high availability and scalability. So what's the high availability? What is availability in terms of cloud computing? So when you are deploying an application or a service or any IT resources, the resources are available when needed. It should be available. Like you are deploying some services and it's not available whenever you require, then doesn't make sense. So it should be always available. Then high availability focuses on ensuring maximum availability regardless of disruptions or events that may occur. So whatever the disruptions or whatever events or events refers to maybe updating or upgrading your things or moving the hardware, all these kinds of even planned events or unplanned disruptions, whatever it is, still your availability should be maximum. When you're architecting your solution, you'll need to account for service availability guarantees. Azure is highly available cloud environment with uptime guarantees depending on the service. These guarantees are part of the service level agreements like SLA. Scalability refers to the ability to adjust resources to meet demand. This is what we have seen in my the previous video. We have called consumption based model. So based on the consumption, you can utilize the resources. That is called the scalability. So the availability refers to your resource or your application or your service is available despite planned or unplanned disruptions. So it should maintain the SLA, it should guarantee the SLA. That's a high availability. Scalability is adjusting the resources to meet the demand. So you're having some service, having some e-commerce site, and only during if there is more traffic towards the site, then the resources should increase. If there is less demand, then your resources should go down so that you pay lesser, you don't pay for the unused resources. So even in this scalability, right, we have two varieties. One is vertical and the other one is horizontal. So the vertical refers to scale up, scale down, and this horizontal refers to scale in and scale out. So we will see what that is also. So before that, we will see this video on this is actually from Microsoft Azure Learning Portal as well.
A service level agreement, or SLA, is a standard industry term. It's the formal agreement between a service provider and customer that guarantees the customer a stated level of service. The service provider may be a commercial company providing the service, like Microsoft when you use Azure services. But SLAs are also used inside organizations in an agreement between the IT department and the business users. Let's look at what SLAs mean for Azure. Azure service level agreements are represented as a percentage related to the service or application's availability. This availability is also known as uptime. If the service was always available to use, you'd say it was 100% available, or it had 100% uptime. An SLA also commonly includes details like what is defined as downtime when the service is unavailable, and any credit you may be entitled to if the SLA is not met. In reality, 100% uptime is difficult and expensive to achieve because it allows no time for taking the service down for required maintenance or upgrades. It would also require duplicating every single component in case one component failed, and would require those backup components to pick up the service tasks with zero interruption to the customer. For these reasons, SLAs of 99%, 99.9%, and 99.95% are more common. 99.99% is also available in some services in Azure. Is there a big difference in a service that's 99% available versus one that's 99.9% available? Yes. A service with a 99% SLA percentage can be unavailable for up to 1.6 hours per week or 7.2 hours per month and still be 99% available. That time is cumulative, which means it can be added up over multiple incidents of the service being unavailable. A service with a 99.9 SLA percentage can be unavailable for only 10 minutes per week or 43.2 minutes per month. That's clearly a big difference. If the service is critical to your business, minutes versus hours of downtime can make a big difference. But highly available services do come at an extra cost. Each Azure service has its own SLA. Familiarize yourself with them prior to designing any application that runs on Azure to ensure you're optimizing availability against your business needs.
Okay, let's get back to our video here. So benefits of reliability and predictability in the cloud service. So reliability is the ability of a system to recover from failures and continue to function. It also one of the pillars of Microsoft Azure well architected framework. When decentralized design, the cloud enables you to have resources deployed in regions around the world. With this global scale, even if one region has a catastrophic event, other regions are still up and running. So actually the Azure cloud, they have data centers in different regions, and even different regions they have their centers at different locations as well. So even if there is going to be a very big catastrophic disaster, still your service can be running by moving it to another region. So this is the reliability the cloud service provides us. Then predictability. So predictability in the cloud lets you move forward with confidence, meaning like you can focus on the performance predictability or cost predictability. You can upfront predict how much is going to cost for you if you're going to take a service, with what load you're going to run it, and also you can predict the performances. So like what performance you can get from this kind of architecture we have. So this predictability is heavily influenced by Microsoft Azure well architected framework. Then performance predictability, as discussed here, the performance predictability focus on predicting the resources needed to deliver a positive experience. So auto scaling, load balancing, and high availability are some of the cloud concepts that support performance predictability. So all these things we'll be seeing in our future videos in detail. So the high availability we have already discussed. So auto scaling and also the load balancing we will see in our videos later. Then cost predictability is focusing on predicting or forecasting the cost of the cloud spend. So how much you're going to spend. So we will have a rough estimate of what will be spent if you're going to use this much of resources for this much of time, and we are going to have this much of load provided. So using that and data analytics, the cloud, we can have a data analytics used, and it will provide a trend, or it will provide an estimated cost that is going to be used on the resources we are looking forward. So next will be the benefits of security and governance. So the cloud feature supports governance and compliance. So things like setting templates help to ensure that all your deployment resources meet corporate standards and government regulatory requirements. So it means like we set up a template that is compliance with the government regulations and also corporate standards, so that we can use the templates and it going to be compliance with all these standards. So update all your deployment features to new standards as standards change. So we can easily update to our new standards. Then cloud-based auditing helps to flag any resources. There's a cloud-based auditing in our cloud resources. So anytime there's any incompliance issue, then this auditing will help to point it out so that we can resolve the issues, then we can make it compliance. Since the cloud is intended as an over-the-internet delivery of its resources, cloud providers are typically well suited to handle the things like distributed denial of service attack, then making your network more robust and more secure. So anything that's open to the internet there's much risk of getting attacked. Like one of the common is DDoS attack. So all these kinds can be handled by our cloud service. Then benefits of, so here we see management of the cloud. So management of the cloud speaks to managing your cloud resources in the cloud. So automatically scale resources deployment based on need, like deploy resources based on pre-configured template, then monitor the health of the resources, receive automatic alerts based on configured metrics, so you are aware of the performance in real time. This is management of the cloud. So managing of the cloud, so these are the benefits. Then manageability benefits of cloud, using the cloud resources. Then management in the cloud. What are the benefits in managing in the cloud is how we can manage it is through web portal. Like we go for Azure portal through browser, then we can go manage things. You can use command line interface, same like how you use our command line in Windows. Then we can use APIs. Then we can use PowerShell also. PowerShell is like one of the powerful management in cloud. Even in Windows, that's like one of the most powerful tool we will have to be using if you're in your desktop engineering or in your infra team. So PowerShell is one of the powerful to describe the cloud service types. So as we have seen in our previous video, in the video first video for Azure Fundamentals, these are the three types of three types of cloud services: infrastructure as a service, then platform as a service, and software as a service. So basic differences between them will be the responsibility of the services in it. So like which portion is responsible for taken responsibility by the customer, or which part is taken responsibility by the cloud provider. In Azure we say it's a Microsoft. So as we seen, we just go for here. So the responsibility, so here SaaS and platform service, then infra as a service. So we see all these three things. So infrastructure as a service is the cloud provider just provides us only the infrastructure, data center, network, host. The rest all on top is all on the customer side. So that's the infrastructure as a service. Then platform as a service is information, devices and accounts is fully on customer. The identity, application and network is shared responsibility. Then operating system, host, network, data center. So they provide the platform for things to be hosted and running. So this will be on the Microsoft side. Then it's a software as a service. So they provide the complete software setup for the clients to use, for the customers to use. So till the application level, it's all on the cloud provider. That's a Microsoft here. Then identity and direct infrastructure is a shared responsibility. Account, device and information is on software, is on the customer. So in general, if you see here, in all the three models, the physical portions, all the physical portions is fully on the Microsoft side. That's on the cloud provider. So whatever model you take. And also here on top, information, device and account and identity, all these three is fully on the customer side, irrespective of whatever model you take. So we will see some more in detail about these three things. Okay, so this is infrastructure as a service, platform and software. So in general definition is like provides virtualized computing resources over the internet, provides you the basic infrastructure services only. The physical thing, it will be covered by the cloud provider. Then platform provides hardware and software tools over the internet, typically for application development. Then software as a service provides you software application over the internet. Here only the software tools is provided. Here the entire software is provided to run over the application. This is on the subscription basis. That's important thing to note down. Then components includes virtual machines, storage and network, as we seen just now. This includes operating system, database and developing tools, plus the infrastructure tools. Then here includes the application itself. The entire application itself is provided by the cloud provider. Then this follows the rest of the things. Then for management related, users can manage the operating system, application and data, while the provider manages the infrastructure. So here the infrastructure and platform. And for software as a service, we manage only the data and also the identities things. The rest all is managed by the provider manages everything, including the application, data, runtime, middleware infrastructure. We just don't need to worry about anything. So the examples is Azure, AWS and all these cloud services. They provide infrastructure that comes under infrastructure as service. Then for platform as service, Azure app services. So we use the applications app services in Azure. There will be app services to be utilized. So those are comes under the platform. Then software as a service like M365, like this Dropbox, all these are software as a service. We just install and just we are ready to go. We don't need to do any setup. We don't need to worry about anything. Everything is managed and update things all handled by the cloud provider. So that is the software as a service. So it's very important to know the difference between all these three and how these things functions, because when you are an enterprise, it's very important which service are you going to take. So only if you know very clearly in depth the differences and advantages of using which service at what point. So it's if we are like an enterprise architect or so application owner, it's our responsibility to decide which application or which service we will need to take for a particular application. So we should have a detailed knowledge on it. And moving forward in other videos, in future videos also, we will be seeing on each topic. Then I will be touching on all these things, because it's going to be continuing for at all the stages when you're discussing about the Azure. Here we'll be seeing the core architecture components of Azure. Let me change. Okay, so first we'll be covering what is Microsoft Azure. Then we will explore about Azure accounts. Then we see what is this sandboxing and how it's been used in the learning path for Azure. Then physical infrastructure, then management infrastructure, then we see a lab session, Azure resource, to how to create a resource. Okay, so here Azure is continually expanding cloud service. So it's like they are expanding in all the IT segments to help more on the enterprise part. So Azure gives you a freedom to build, manage and deploy applications on a massive global network using your favorite tools and frameworks. So it's like more flexible in general, like you can build and manage or deploy and can use our favorite tools and frameworks. So it's very flexible to use. That's the main reason for continually expanding service. So build intelligent apps and solutions with advanced technology tools and services to take the business to the next level, so which the business people are more interested in. Seamlessly unify your technology to simplify platform management. Deliver innovation efficiently and securely on a trusted cloud. Azure provides more than 100 services that enable you to do everything from running your existing application on virtual machine to exploring new software paradigms such as intelligent bots or mixed reality. So in general, The Azure provides more than 100 services, so it can be like already you are running a service in your on premises that can be moved to cloud by running it in a VM, or you can just use their software as a service support, or any app services. You can just use it and develop your intelligent bot or reality mixed reality thing, or you need any other services you can just use. So we have both possibilities. Already you have a running application, just can run it in the cloud, or if you want to develop an application or you can want to use a app service available in Microsoft, you can use it as well. Teams start exploring the cloud by moving their existing applications to virtual machines, VMs, that run in Azure. So this is how most of the companies will start using. Just they would like to move their current running application to the cloud and see how compatible it is and how comfortable our users are, in what ways it's benefiting the enterprise and the infra team. Migrating your existing apps to VMs is a good start, but the cloud is much more than a different place to run your VMs. So it's not like the old days, like when this cloud came into existence just for running your things in the cloud, running your application in the cloud, or storing the things in the cloud. Now it has been expanded to a different level of support. Like you can have their own direct applications, like we in the previous video I discussed about this software as a service. Like they create everything for us, we just need to maintain the identity, data and user account. The rest all is on the cloud service provider. Azure provides artificial intelligence and machine learning services that can actually communicate with your users through vision, hearing and speech. So Azure also provides AI and machine learning services as well. It also provides storage solutions that dynamically grow to accommodate massive amount of data. So the storage services is like one of the important topic in Azure to discuss. So we will see it in a separate video in the later videos. We'll discuss in depth about the storage solutions. So one of the important thing to take note in the certification point of view, there will be a lot of questions with relation to the storage services, and it's very important to know that, because every time when you're using application or moving something, when you're creating a cloud storage account, you must know which account is suitable for your current application or current usage. So that's very important to know it. Azure services enable solutions that aren't feasible without the power of the cloud. Like extremely powerful and extremely very useful applications are being solutions has been provided by the Azure, which can only be made easy or only made easy by the power of the cloud. If there is no this solutions through cloud, then we would have not been able to achieve this. So those kind of solutions are also being provided by Azure services. So here we will be seeing a small video about what is Azure.
What is Azure? Azure is Microsoft's cloud computing platform with an ever-expanding set of services to help you build solutions to meet your business goals. Azure supports infrastructure, platform, and software as a service computing with services such as virtual machines running in the cloud, website and database hosting, and advanced computing services like artificial intelligence, machine learning, and IoT. Most of Azure's services are pay-as-you-go. You only pay for the computing time that you use. If your business needs complete control over your computing environment, Azure allows you to host virtual machines in the cloud. You can create virtual machines from scratch, upload your own virtual hard drive, or choose from an array of templates that Azure provides. Azure also provides cloud-based storage, which allows you to store your application or backup data safely and securely. Azure's app services provide a scalable hosting platform where developers can create web-based applications using popular development frameworks. You can easily deploy, operate, and scale your apps in a fully managed environment. With Azure Functions, you can create event-driven, serverless applications with no coding required. Azure Container Instances and Azure Kubernetes Service allow you to deploy containerized applications with fully managed services. Azure offers a choice of fully managed relational and in-memory databases, spanning proprietary and open-source engines, and Microsoft's Cosmos DB provides support for several popular NoSQL APIs. Azure's artificial intelligence and machine learning services empower developers and data scientists with a wide range of productive experiences for building, training, and deploying machine learning models faster. Azure's regional data centers allow you to distribute your applications globally, so you can locate your data and apps where they're needed most, thereby improving your application performance for your customers. The Azure portal lets you create, configure, and control all your services and resources from a single, easy-to-use web-based interface. Microsoft Azure offers a wide array of cloud computing services where infrastructure management, scalability, availability, and security are handled for you, saving you time and money.
Okay, so here we will see a different the management part of Azure infrastructure. So here you see first is noted as Azure account, then you see something called subscription, then resource group and resources. So you will see in detail of what all these things. This is like a hierarchy, the top level hierarchy to the bottom, the lower level hierarchy. So to create and use Azure services, you need an Azure subscription. So only if you have a subscription, you can create a resource group or resources or any kind of Azure services you want to use it. So you need a subscription. That's one of the important thing to take note. So when you are working with your own application and business needs, you need to create an Azure account, and a subscription will be created for will be created. So after you have created an Azure account, you are free to create additional subscriptions. So like under each account you can create multiple subscriptions. It's not necessary that you should have only one subscriptions. You can create multiple subscriptions as well. So this all will be more useful in management infrastructure. In the next videos I will tell you how is being useful in the management infrastructure having multiple subscriptions. So for example, a company might use a single account for your business and separate subscriptions for development, marketing, sales and sales department. So usually Azure account you can imagine to a company. So if you have a company like this, Techify Adil is a company, so we create an account Techify Adil. So under the Techify Adil's company, there's a sales department, there's a IT department, there's different marketing and so on, different departments. So for each departments I can create subscriptions. So what is the purpose of creating this multiple subscriptions? I said we'll see in the next slides. So after you have created an Azure subscription, you can start creating Azure resources within each subscription. So like say example, this is one of the department linked to a subscription like sales. Then I can create required resource groups under that and resources under that. So here we will see about the accounts. Azure free account. There's Azure free accounts for us to use to get more familiarized with the services provided. So Azure provides this kind of service as well, so that we can create a free account. So normal free account is free access to Azure products for 12 months. That's a popular Azure products, not all the products. That's a popular Azure product for 12 months. It's like 1 year. Then the credit to use for first 30 days. For 30 days they will provide you a credit. So within that you can utilize the resources. Then access to more than 25 products that are always free. So you don't need to use the credit. So you can still use the 25 products that's always free. The Azure free account is an excellent way for new users to get started and explore. So to sign up, you need a phone number, credit card and Microsoft or GitHub account. So you just need a phone number, so it will give you OTP. Then the credit card is just for your verification. So it will just just for the verification purpose, it will just charge like $1. Then it will be refunded back just to verify the person is original, it's not a computer or something. So they will it will do a verification using a credit card. Then you should need a Microsoft or GitHub account, like normal Hotmail or Outlook account. That's a free account will do. Then the Azure free student account offer, there's something called Azure free student account. So this also has Azure services or an Azure service for 12 months, a credit to use in the first 12 months. So here you will have a credit to use for first 12 months. Then free access to certain software developer tools as well for a student from point of view to learn. The Azure free student account is an offer for students that gives $100 worth credit and free developer tools. Also you can sign up without a credit card. So these are the two types of free accounts Azure provides. So if you are a normal user, can go for free account, or you can go for a free student account. So here we will be seeing a video on Azure account.
In order to start taking advantage of the wide array of Azure services, you'll need to first sign up for an account. If you are completely new to using Azure, you can begin exploring what Azure has to offer by signing up for an Azure free account. An Azure free account includes access to 20 Azure products free for 12 months, access to additional products that are always free, and a $200 credit to spend during your first 30 days. For more information on signing up for an Azure free account, head here. If you work for a large organization, you may be able to purchase access through a Microsoft representative or through a Microsoft partner. Finally, you can purchase access directly through Azure.com. With pay-as-you-go pricing, you pay only for what you use each month, with no upfront commitment, and you can cancel at any time. Once you have an active Azure account, you may want to create additional subscriptions for resource or billing management purposes. If you have multiple subscriptions, you can organize them into invoice sections. Each invoice section is a line item on the invoice that shows the charges incurred that month. You can also set up multiple invoices within the same billing account by using billing profiles. Each billing profile has its own monthly invoice and payment method. Once your account is active and billing is set up, you're ready to start using Azure. As a part of your subscription, you have 24/7 access to online documentation, community support, and new Azure Capabilities demo videos created by Azure engineers. For more information on the support resources available to you, head here.
Okay, so here we see what's Azure region, then availability zones and data centers. What's all these terms refers to. So first we see Microsoft data center. So Microsoft data center is generally similar to what our enterprise data center is. So it's just the Microsoft data center infrastructure designed to use for the Microsoft cloud. So currently there are like 60 plus Azure regions with 300 plus data centers and 280k plus kilometers of network connecting the centers and Azure regions, and 190 plus network connections. So this is current details about the Microsoft data center. So what's this Azure region? So Azure region will have different availability zones. So Azure regions will be divided into availability zones, so that if like one of the availability zone is down for some reason, like a power failure or some kind of issues, you still have other availability zones that's running, so that you have data recovery very faster and still your services keep running. So the physical infrastructure, as mentioned in the previous slide, it starts with the data centers. A region is a geographical area on the planet that contains at least one but potentially multiple data centers that are nearby and networked together with a low latency network. So a region is a term used in Azure. So that refers to a geographical area, like it is not North America or Southeast. It refers to some region. So it's a geographical location that can have multiple data centers in it. So Azure intelligently assigns and controls the resources within each region to ensure workloads are appropriately balanced. So availability zones are physically separate data centers within a Azure region. Each availability zone is made up of one or more data centers equipped with independent power, cooling, and networking. So this availability zones, what we see in the previous slide. So these availability zones are physically separate data centers within a Azure region. So we have Azure region, say it's a North American Azure region. So we have different availability zones. So each availability zones are physically separated data centers with power supply, networking, and cooling systems. And these data centers are connected. So an availability zone is set up to be an isolation boundary. If one zone goes down, the other continues working. Availability zones are connected through high speed private fiber optic network. That's very important, so that your connection still continues to be same with the same speed. So like one of the availability zone is down, then still we have another availability zone in the same region. Availability zones are primarily for VMs, managed disk, load balancers, and SQL databases. Azure services that support availability zones fall into three categories: zonal service, zone redundant service, and non-regional service. So what is this zonal service? So you pin the resource to a specific zone. So example, I'm having a VM, so I pin it to a specifically a particular zone where it has to be. So that's a zonal service. Then zone redundant service, the platform replicates automatically across zones. So that's a storage or database storage. So the based on the service you subscribe, it will be automatically replicated to different across the zones, so that if any of the storage is failed or down, then you still have your backup running in another place, so that it can be used. So that's a zone redundant service. Non-regional service, so services are always available from Azure geographies and are resilient to zone-wide outages and as well as region-wide outages. So this is like storing it in a different geographies, different locations. So if the entire zone is down or the entire region is down, still you have your data or your service up and running. So this is all based on what kind of service you take during creating your services or your resources. So most Azure regions are paired. That's one of the important things. Most of the Azure regions will be paired region within the same geography as earlier mentioned. So Azure regions are connected with high speed fiber optic network. This approach allows for the replication of resources across a geography that helps to reduce likelihood of interruptions because of the events such as natural disaster or civil unrest, power outage, or physical network outage that affect the entire region. So if the entire region is down for some reason, like we have some kind of civil issues or some power outage or a very big natural disaster, so something happens to our entire region, then still we can keep it running, but if the Azure regions are paired and we have our data running in another region. A resource is the basic building block of the Azure. Anything you create, provision, deploy is a resource. So like virtual machine, virtual network, database, services, all these are considered as a resources within the Azure. So resources groups are simply groupings of resources. So what resource group contains It just contains the resources. We group the resources into a bag or into a set called resource group. When you create a resource, you are required to place it into a resource group. When you're creating a resource, it will ask you to take a resource group, to choose a resource group to which this resource belongs to. While a resource group can contain many resources, a single resource can only be in a resource group at a time. Some resources may be moved between resource groups, but when you move a resource to a new group, it will no longer be associated with the former group. So a resource can be associated only with one of the resources at a time. It cannot be shared between two resource groups. So whenever you apply some policies to a resource group, it will be inherited by the resource. Like if you're deleting the resource group, the resources under the resource group will be deleted. So whatever policies or whatever conditions you apply on the resource group will be inherited to the resources. So subscriptions allow you to locate your resource groups and facilitate building. Is able to logically separate our resource groups and facilitate building. So using Azure requires an Azure subscription. So an Azure subscription links to an Azure account, which is an identity in Microsoft Entra ID. Entra ID is like a cloud active directory. So in normal on-premises we have AD, right, active directory. So this Entra ID is nothing but the cloud active directory. Previously it was called Azure AD, AAD. Now they have retermed it as Entra ID. So it's just Azure AD, or in a directory that Microsoft Entra ID trusts. So an account can have multiple subscriptions, which I have mentioned in the slide before. So there are two types of subscription boundaries that can be used. So one is billing boundary, the other one is access control boundary. So the billing boundaries, Azure generates separate billing reports and invoices for each subscription so that you can organize and manage the cost. So this is what I mentioned as the advantage of having multiple subscriptions based on some grouping like department or buildings or locations. You create a subscription so that the billing reports and invoices for each subscription will be generated, so that we know what each department is billed to. So each department we can bill in separately. So that's about the billing boundary. What's this access control boundary? So this billing model allows you to manage and control access to the resources that users provision with specific subscription. So under subscription, say we say like subscription A. So under subscription A, you are creating resources. So that resources will be manage and control access for the user's provision with that subscription only. So we can have a access control boundary. That's one type of subscription boundary. The other type is the billing boundary. So similar to using resource groups to separate resources by function or access, you might want to create additional subscriptions for resources or billing management purposes. So you might choose to create additional subscriptions to separate organization structure, building and environment. So based on environment or based on billing or based on the organization structure, we can create additional subscriptions so that we can keep them separate, easy to manage. Okay, so we see what is the sandbox, how it is being used, learning sandbox. So this a sandbox gives you an access to free resources. Your personal subscription will not be charged. So the sandbox may only be used to complete training on Microsoft Learning. So you can just practice. It's like a practicing place. So use for any other reason is prohibited and may result in permanent loss of access to the sandbox. Microsoft provides this lab experience and related content for educational purposes. So it's just a lab that runs in the cloud. So you need to set up anything, just everything will be pre-set up. Just you need to practice the activities. So this is like one of the first learning activity in Azure Fundamentals learning path. So first we need to sign in to activate the sandbox. So let me sign in. Yeah, so I have signed in already. So while signing in, first you need to have a Microsoft account. Then once you're signing in, it asks you to have a multi-factor authentication, since you're signing into the sandbox. So you should set up your MFA first using the authenticator app. After you set up, then you should be able to sign in. So here I need to verify my account. So match the number of the rocks. Okay. So yeah, a different kind of verification. Okay. So here we see the exercise. So in this exercise, you explore the sandboxing. Oh, sorry. Okay, so you can interact with the learn sandbox in 3 ways. During the exercise, you'll be provided for instructions for at least one of the methods below. You should start by activating the sandbox, which we have done already. So this is how, if you haven't already done, so you should activate it, so which we done. So here you see task 1 is use the PowerShell CLI command line interface. The second task is use bash command line interface, and the third task will be using Azure command line interface. So here is just accessing to the Azure using the PowerShell, then bash, then by Azure CLI. So then use the Azure portal. So sign into Azure portal, check out the Azure web interface. Once in the portal, you can see the services, Azure and everything. So this is how you're going to do. So here the sandboxing is about to launch. Yeah. So you can see here you have used one of 10 sandboxes for today. So there's a limit for every day. So just use it resourcefully so that you can you have enough attempts for each day. So this is Azure Cloud Shell. So we see what is the Azure Cloud Shell referring to the PowerShell CLI. So here first we try the commands like so it's still building. Okay, now it's in. So we type get date. So it gives us the date, then it gives you all the details. Then we are switching to bash. Switch to bash shell. It will set up. So here we do the same to make sure okay. So here the command will be date. This is the PowerShell command and this is the bash command. So just make sure you're familiar with at least one of the things. So here we do upgrade. So your current Azure CLI version is 2.6 and the latest available is 63. So it's asking if you want to upgrade. So for now I don't do it. So first I showed you the option to switch, right? So here still you can use with the command line as well. sh. So you see it's already into the PowerShell. So here you can type as bash, then it goes back to your bash command line. So use Azure CLI interactive mode. So you type, so you must go to the Azure cloud. So here we type PowerShell. We go to the PowerShell mode first. Then in the PowerShell mode we type Azure interactive to go into the Azure CLI interactive mode. Azure interactive. So it's installing the interactive extension. So it's just loading now. So what this interactive mode gives you an additional to the normal PowerShell mode is, so this will look like an interaction. So normally with chatbots all we interact, right? So it will be very similar to an interaction instead of just one point of commanding. So PowerShell is usually like no interactions. So you type something, then it gives you the out or give you the error. So there is no kind of interaction. So this will give you a more interactive kind of mode, so easy for us to type the commands and get the out. Then the last part will be the Azure portal. So this is the GUI. So all the three so far what we have seen is all command line interface, and this is the only graphical user interface. So we just log in. So actually I have already logged in, so it just goes in. If not, it also will ask you go to the Microsoft login page, then you log in with your username, password, then authenticate, then it just go to your thing. So this will be your dashboard. So this is a plain account, doesn't have anything. So your dashboard will be like empty here. Then you see your resource groups, so it will be empty, no resource groups was created. And you see your app functions and everything will be just empty. You not have anything created. So Azure machine enter ID, so I don't have access because of the licensing. So this is the first our sandboxing lab. So here we saw how we can access to PowerShell, then how it works, then we saw the bash CLI, then interactive, then the Azure portal. So Azure portal, you just can explore everything here. Then slowly once we are doing the certain topics, then we will see what are each things, like what app services, SQL database, and load balancers. We will see each one after the other. So for now you just know how you're going to access this. What is the home is just our normal page home, then create things, all the shortcuts will be here. Shortcut for the services, then your dashboard, then the favorites you added here. So cost management, billing, help support, then you have your defender, advisor for monitoring. All these things we will see in specific in our future videos. Okay, Here we will see the sandboxing lab, how to create an Azure resource. So as usual, we need to sign in to activate the sandbox. So we have to verify. So once verified, we are signing in to sandbox already. Okay, so here the task one is to create a virtual machine. So first go to the Azure portal. So after we go to the Azure portal, we need to select create a resource, compute, virtual machine, then create. So we are in already. So create a resource. So these are the popular Azure services. Already we have a virtual machine here, but as per the normal, we need to search from here. Then we have a virtual machine to be. So we're creating a virtual machine. Create a virtual machine opens a basic tab. Verify the other. Enter the following values to set up these settings. So we just follow the settings here. So let me bring it over. So the Congress subscription. So this is the learning resource group was already default created. So I'm just using the default one. Virtual machine name. We use take if with then underscore VM 01. So we use as dash. Okay. Next region, we just leave it at default, West US. Then availability zone, we just leave it default. Then security type, we just leave it as default. The rest all we leave it as default. The OS, if you want, we can change the OS. Say we use Windows 10, Windows 11 Pro. Then size we just leave as default. So everything we just leave it as default. Size also we just leave it as default. You can actually see all sizes and what are each size contains. Based on that, it will be priced as well. The virtual machine pricing also will be based on the pricing, the sizing. Then the authentication type, we go for password. Username is just we follow the default Azure user. Then password we just make it as so it's Azure. So it's none, then review and create. So we are just creating the virtual machines only. So next, if you go for disk, then you can add additional disk and settings one by one. So here just we see how we are creating a virtual machines only, very basic step. So we go for review and create. You don't need to save it. So we are confirming and creating it. So we see here it's charged 0.11 USD per hour. So usually if it's a real account, in the real account, if you're creating this, then you'll be charged as per that. So that's why when say example, if you want to practice, you can create your own account and you can subscribe, have a free subscription. But after you use your lab or use your virtual machine, you have to shut down it. Don't leave it running. If you leave it running, then all your credits will be gone with just one of the VM itself. Yeah, so your resource has been created. So we go to home, then we find resource groups. So we click the resource, then here we see the virtual machine. So just click on the virtual machine. So this is the virtual machine currently the running state. So these are the status and the features of the machine we created. So next is we clean up. When you are finished this module, so it's auto cleanup. So usually if it doesn't, in normal cases we need to make sure we have stop and shut down the virtual machine, so we are not being charged. So you go back to your resources, then select the resources, then you can clear the resource. But here since it's a sandboxing, it will auto clear once you're done. So we just close this. Yeah, so this is how we can create a resource. Similarly, we just created a virtual machine, so similar case goes to all the other resources, and we can also choose the OS versions, whatever we need to create. Just since it's a sandbox, we have a lot of restrictions. If it's your free account, then you can create account or create the resources as per your requirement. So here in this video today we'll be covering what the Azure virtual machine is about and what is the Azure virtual desktop is. So in general it both looks very similar, but actually there's a difference of running a virtual desktop and also as running a virtual machine. So let me cover here let me tell you the basic and very very important differences. So Azure Virtual Machine, we will go for Azure Virtual Machine when we need the full control over the platform. Like I need control over the OS, like which OS I need to use, like Linux or Linux versions, or CentOS or Windows and Windows which versions, and I need to have a host environment customization or software application customization. I if I want to have full control and customizations, then we will be going to Azure Virtual Machine. When it goes to virtual desktop, Azure Virtual Desktop, it's Microsoft service that runs a virtual desktop with Windows OS. So it's already a service. So the management of the service is managed by Microsoft, and we just have the experience of Windows. We will just do have an experience of using a Windows notebook in cloud. That's the basic difference. So when you want to have more control, like when you want to have more customizations things, like then you go for Azure Virtual Machine. The other way, you just need a remote desktop access for your employees, then we go for virtual desktop. So there are a lot of other advantages and differences in both the services. Let us see one by one by this video. So if you haven't subscribed to my channel, please subscribe, like and share my channel, so that everyone is also learn some knowledge on Azure fundamentals. Okay, Azure virtual machines. So this will be the first topic. Let me change pointer. Okay, so Azure virtual machines, we already in the previous video I have shown in the under the topic of resource creation. So we saw how we creating Azure virtual machine. So that's the basic machine creation. So here we will be seeing in detail about Azure virtual machine and users, and what are the additional things we can do it, like template creating and so on. Okay, so with Azure virtual machines, you can create and use VMs in cloud. So like usually we know in VMware workstations are commonly used VMware. So it's a virtual machine we use in on-premise. So with using the Azure virtual machines, we can host the same VMs in the cloud. So we no need to buy the hardware. Instead, we just host it in the cloud. VMs provide infrastructure as a service. So it's an infrastructure is the one we are using only the infrastructure. So in the form of virtualized server, and can be used in many ways. So just like a physical computer, you can customize all the software running on your VM. So VMs are an ideal choice when you need like total control of all operating system, then ability to run custom software, to use custom hosting configurations. So in general, like who have been using this VM for server for hosting applications will know this. Like we can have full control of the OS, then we can customize, ability to customize whatever changes we can, we will be able to do it, and hosting configurations also we will be able to do this. They are very similar to that. We can also do all this in the Azure virtual machine, the virtual machine that's hosted in the cloud as well. So it's very similar to that. So as an infrastructure as a service offering, you still need to configure, update and maintain the software that runs on the VM. So this is known. It's just because they just provide the infrastructure only. So anything above the infrastructure we will have to maintain. You can create and provision a VM in minutes when you select a pre-configured VM image. So this one we can compare to our PC setup. Say example, I have a new notebook procured by the company, so I have to set up for a user. So the steps will be like I have to install the OS, then install, if it comes with the pre-installed OS, then I have to update it to the latest patches or latest OS versions, whatever the company standard is. Then I have to install all the basic applications and additional applications whatever the user requires, and there might be some settings to be applied with respect to the companies. So we need to apply all the settings. So this is a normal way. The other way is usually what in enterprise and companies we do is, so as a desktop engineer we usually prepare all these basic settings which is common for all the user, like patches and everything, then we take the backup. So all these things we have also covered in my previous videos, like using Acronis, then using DASM, how to back up the image, and all those things you can refer back to my previous videos. So what we do is we back up everything and we use that for as a template for new notebook. So when the new notebook arrives, we just use that to clone, or we just re-image the notebook with that template image. So we no need to reinstall the applications, or we no need to do patching and no need to do the settings. We can just avoid all this times we spending on all these steps. Similar to that, in the Azure VM also there's an option called template. An image is a template used to create a VM and may already include an OS and other software like development tools or web hosting environment. So once you have created an image for first time, then you can add it as a template. Then on moving forward, any images any notebook you are any VMs you are creating, you can use that template OS, so that already the settings and all the applications whatever you have included is installed directly to the VM. So we no need to do this again one round. So scale VMs in Azure. You can run single VMs for testing, development, or minor tasks, or you can group VMs together to provide high availability, scalability, and redundancy. So this high availability, scalability, and redundancy we have already covered in the initial Azure videos. You can refer back to my basic starting videos for this topics. Azure can also manage the grouping of VMs for you with features such as scale sets and availability sets. So virtual machine scale set. So virtual machine scale set lets you create and manage a group of identical load balanced VMs. So if you simply created multiple VMs with the same purpose, you need to ensure they were all configured identically and then set up network routing parameters to ensure efficiency. You would also have to monitor the utilization to determine if you need to increase or decrease the number of VMs. So we can create a set of VMs or a group of identical VMs, so that based on the traffic or requirement, your VMs will share the load. So it's called the scale set. So having a group of identical load balanced VMs, so doing similar or same job, so that it can route the things based on the network traffic, so the efficiency is ensured. Instead, the virtual machine scale sets, Azure automates most of that work. So generally, so when we are having the scale set setup, so we will have to monitor the utilization to determine if you need to increase or decrease the number of VMs. That's in the normal scale set way how it's been done. So we have to, based on the utilization, we will have to do it. So with virtual machine scale set, so Azure automates. So if you are having a virtual machine scale set setup done, then the Azure will take care of that monitoring the utilization and determining whether the resources has to be increased or number of VMs has to be decreased. So that part will be totally handled by the Azure. So that's the advantage of using virtual machine scale set. Scale set allows you to centrally manage, configure, and update a large number of VMs in minutes. The number of VM instances can automatically increase and decrease in response to demand, or you can set it to scale based on defined schedule. So we can schedule, so like I need every Friday I need this much of VMs to be on, and every Monday I need it to be reduced to lesser. So based on that also schedule, you can also do it, or based on the requirement, the scale set, virtual machine scale set will automatically increase and decrease based on the demand. Virtual machine scale sets also automatically deploy a load balancer to make sure that your resources are being used efficiently. So when you have a virtual machine scale set, automatically deploys a load balancer. So must take note of this part. So we have virtual machine skill set assigned, then we know there is a load balancer between between the virtual machines in the skill set. With virtual machine skill set, you can build a large scale services for areas such as compute, big data, and container workloads. This is then availability set. So virtual machine availability set are another tool to help you build a more resilient, high available environment. So availability set are designed to ensure that VMs stagger updates and have varied power and network connectivity, preventing you from losing all your VMs with a single network or power failure. So availability accomplish these objectives by grouping VMs in two ways. One is update domain, the other one is fault domain. So the update domain is group of VMs that can be rebooted at the same time. Fault domain is group of VMs by common power source and network switch. So this, when you're creating the VMs, you group it to availability, you create a availability set, so it can be of update domain and it can be of fault domain. So what this update domain is, so update domain covers any known or predefined or scheduled downtime. So you are going to update the VM, so you need to reboot it. So this will be covered by your update domain. So this set allows you to apply updates while knowingly the offline at a time. So it will cover that. The fault domain is unexpected down. So sudden power failure or a network switch is down. So in those kind of cases, the availability set you assign with the fault domain will handle it. So we need to have update domain and also fault domain for known or scheduled downtime and for unexpected downtime. So the best of all is there's no additional cost for configuring any availability set. You only pay for the VM instances you create. So you don't need to pay additional cost for the availability set. So availability set is also one of the important topic. So okay, so when to use VMs? So usually is the physical computer is the one we use. So there's another option, VM. So we have a question like when to use VM. So during testing and development, so you don't need to set a physical thing, so you just can use a, for testing and for development you just can use a VM. When running application in cloud, when extending your data center to cloud from on-premise is already existing one, so you're extending it to the cloud part. During disaster recovery. Okay, move to the clouds with VM. So this is already you have a VM in on-prem and you are moving to the cloud. So VMs are also an excellent choice when you move from physical server to the cloud. So you can create an image of the physical server and host it within the VM with little or no changes. Just like a physical on-premise server, you must maintain the VM. So you are responsible for maintaining the installed OS and software as well. So just keep in mind, you have to remember this part. Your VM in cloud, Azure VMs is just infrastructure as a service, just provides you the infrastructure. Everything above this infrastructure is managed by the vendor. I mean, like the enterprise, whoever's handling, they will have to handle it. When you provision a VM, you will also have the chance to pick the resources that are associated with that VM. So including the size, storage, disk and networking, like public IP, port configurations, hard disk, you need a hard disk or you need SSD, like size of that, then processors you need, amount of RAM you need. So everything is resources you based on what you pick. So you will be actually picking all this when you create the VM. Actually, in the video of resource creation, I have mentioned, I have showed you model is a default. In that video, I actually would have shown you a default design to choose, like D2, D3, A2, A3. So each design will have its configurations, like what is the number of processor, what is the RAM, like that. And storage also, you would have this option to choose. Maybe if you go through that, you will understand the creation of Azure, how these options have been chosen. So the next topic will be Azure Virtual Desktop. So Azure VM is what we have been discussing so far. So next is Azure Virtual Desktop. There is a minor difference between them. Another type of virtual machine is the Azure Virtual Desktop. So Azure Virtual Desktop is a desktop and application virtualization service that runs on the cloud. So this is the whole entire desktop running on the cloud itself is offered as a service by Microsoft. So the first part as Azure Virtual Machine is they just provide us infrastructure based on the design we chose. Then we have to install the OS and we do all those things. So here a virtual desktop itself is provided as a Azure service. So it enables to use a cloud hosted version of Windows from any location. So Azure Virtual Desktop works across devices and operating systems and works with apps that you can use to access remote desktops or most modern browsers. So here we will see a short video about Azure Virtual Desktop.
Welcome to Windows Virtual Desktop Essentials. If your organization is looking for a more efficient, productive, and secure approach to desktop virtualization, in the next few minutes I'm going to walk you through Microsoft's Windows Virtual Desktop solution on Microsoft Azure. It offers a fully managed desktop virtualization solution in the cloud. And the good news is it works with all your apps and devices. As you can expect, we have full featured native client support for Windows, Mac, iOS, and Android, as well as new HTML5 support so that you can access remote desktops and apps from almost any modern browser. So why desktop virtualization? Well, for a while it's been looked upon as a solution for enabling central management and security of your users' desktops and also with less IT management overhead. Now this approach separates your operating systems, data, and apps from local hardware, running them instead separately on a remote server. Now the main appeal is that you can separate the compute environment from user devices so that the risk of confidential information being left on a personal device is greatly reduced. You can also make sure that your virtual machines run in close proximity to apps and services that connect to your data center or the cloud. End users have the freedom to connect with any device over the internet, and for IT, you don't have to worry as much about the device that's connecting so long as the network connection is secure. That said, standing up a desktop virtualization environment has traditionally been expensive and also complex. Users have often lacked the productivity experience of a locally provisioned desktop, and it can take weeks and sometimes months to get a successful implementation up and running. Now, with Windows Virtual Desktop, all of this complexity goes away. We give you a remote desktop infrastructure that contains the roles that you would have had to manage at scale. Things like your gateway, broker, diagnostics, load balancing, and more as a fully managed service on Azure. All your VMs in the Windows Virtual Desktop service communicate over a secure outbound connection, and you benefit from unlimited capacity. And you can also choose any size VM in Azure and vary the density of users based on the workload. We also give you more choice in how you distribute users across those VMs. For example, you're not limited to a Windows Server OS in cases where you want to assign more than one user per virtual machine. With Windows 10 Enterprise Multi-Session, for example, you can gain efficiencies by having multiple users on a single VM, and unlike multi-session Windows Server implementations, it has the support for modern apps like OneNote and Office 365 apps, and we're going to talk more about that in a minute. You can deploy a full desktop, remote apps, or both, and of course, you can scale up or scale down as needed while paying only for what you use. Now, for users, things get even better. Now there's no compromise between their virtual desktop productivity experience and what they would experience if they had a locally hosted desktop running on their PC. It's the same. Now in Windows 10, for example, your full collection of apps, whether they're Win32 line of business apps or UWP apps, those will run. Apps are fully integrated with the Start menu. You can pin them to your taskbar, and the only indication the app is virtual is through the glyph. You can copy, paste, or snap apps side to side. They look and feel like local apps. And you don't even need to be on a PC. You can also be on a Mac, iPad, iPhone, your Android phone, or even the browser the experience is going to be the same. So next, please continue to watch our series for hands-on guidance on the steps to prepare, deploy, and optimize Windows Virtual Desktop for your organization. Thanks for watching.
Okay, the Azure Virtual Desktop provides you enhanced security. So you'll see how that is being achieved. So Azure Virtual Desktop provides centralized security management for users desktops with Microsoft Entra ID. So you know what is Microsoft Entra ID is. So Microsoft Entra ID is nothing but is Azure AD. So they have changed name of Azure AD as Entra ID. So you can enable multi-factor authentication to secure user sign-ins. You can also secure access to data by assigning granular role-based access controls. So they call this RBAC. So it's a role-based access control. So with Azure Virtual Desktop, the data and apps are separated from the local hardware because the data is not stored in your local. So the entire machine is in the cloud. The actual desktop and apps are running in the cloud, meaning the risk of confidential data being left on a personal device is reduced. Additionally, user sessions are isolated in both single and multi-session environments. So multi-session Windows 10 or Windows 11 deployment. So multi-session Windows deployment. So Azure Virtual Desktop lets you use Windows 10 or Windows 11 Enterprise multi-session, the only Windows client-based operating system that enables multiple concurrent users on a single VM. So it's like multiple users can access to a same VM from different locations, from different devices at the same time. So it's a multiple concurrent users on a same VM. So this is one of the biggest advantage in using the Azure Virtual Desktop. So Azure Virtual Desktop also provides a more consistent experience with the broader application support compared to Windows Server based operating system. Okay, so here as discussed, we'll be seeing about the actual Azure Virtual Machine creation. So this is the sandbox, learn sandbox. So in this, the Azure Virtual Machine creation will be through Azure Cloud Shell. That's the command line interface, and we'll be creating a Ubuntu image virtual machine. After we create the virtual machine, then we will be installing a web server to it. So these two exercises we'll be doing in this video. Then once we have completed this, then I will show you also how the same thing is done, or how the virtual machine is created when using the Azure portal. So there the options, everything I will just go through after the first exercise. Okay, let us first. Okay, so here I need to verifying my account. So once verified, the sandbox will be activated. So let us wait for the sandbox to be completed. So while creating the Azure virtual machine, so virtual machine you can the detailed thing I will show you when showing the exercise under the by Azure portal. So there you can see we will be able to choose every single detail, like disk and what kind of hard disk you need to use, or SSD or normal hard disk, and that disk is newly to be created one, or you want to attach an existing disk, you want to use the secondary hard disk. So you can very similar to how we will be customizing a laptop or desktop, you can also customize your virtual machine, which will look very nice for our operations. Like when we need a customized setup, we can customize as we need it. Okay, it's started already. So let us go to the exercise. So the commands are already here. Just I will explain you what these commands are. So Azure VM create is the command for VM creation in Azure Cloud Shell. So these are the details for that VM to be created with. So resource group, so we'll be using this default resource group created for the Learn Sandbox account. Then name, then public IP standard IP, then image will be Ubuntu 22.04 version. Admin username will be Azure user. Then we are getting SSH keys to be generated out and saved in the local PC. So we copy this and we paste. So here I will change my VM to Takify with Adel VM1. The name I have updated to this. The rest we just keep it as it is. Then yeah, just enter. Okay, so you can see here SSH key has been generated, then it's saved to this location. So in case if this location is not the permanent storage, then it just advising us to save it in somewhere in the permanent storage so that it's not lost. So now the VM creation is under process. Usually VM creation just takes few minutes. Like you need just imagine like you need a desktop, so we have to purchase the hardware, then we have to assemble it. It's going to take like even few days for the equipments to come in, then start. So in cloud, just you choose the things, you select the options, like select the configurations you need and click create it. Just boom, in few minutes your PC, your VM will be up, which is very nice for our testing, all this kind of functions. Just you don't need to wait for something to come in, or you don't need to wait for someone to come do the configuration. Just anybody can just do it. You have a basic knowledge about what configuration you need, what are the settings or what are the applications you need. You just go to the Azure portal, you just can set up it, very easy. So yeah, our VM is ready. So you can see here it's been created, the West US, that's a default location actually. MAC address, then the state is VM is running, so it's created correctly. Then we have a private IP, then we have a public IP, then the resource group is the one which we have assigned to. Okay, so we have created the VM. Next we will be configuring the web server. So just copy this and paste here. Just we need to update. If you're changing the VM name, just remember to update at every exercise. So here VM name will be Takify with other VM1. The rest all will be same. Yes, yeah, till it gets created, let us see what is the command we have configured. So we are getting the extension, we are setting up an extension, we are installing, or we are setting up an extension to this belongs to this resource group. Under this resource group, to which VM we are doing it for. VM name is the one which we created earlier. Then the name will be the custom script. Then publisher, from which publisher is Microsoft Azure extensions, the version, then the setting. Okay, the setting of the extension we are installing, right? It will be following this file. This file is from GitHub user content.com Microsoft Docs MS Learn Well. So it belongs to here. So let us see what this is actually a bash file. So we will see what that bash file contains. Then next command is protected settings, command to execute. So yes, such. So this one is a bash file. This location contains a bash file. Let us see what this bash file is. Okay, here you can see. So once we are executing that script, it will run this bash file. So this bash file contains get the update. So it's going to get the latest update of the web and it's going to next step is it will be installing it. So after installing, then it will set up the home page with welcome to Azure, my name is, and it will be the host name, which it should be here in this case will be Techify with that's TWA hyphen VM1. So we should see this when we are accessing to the server. It should show us because it's going to be a web server, so it should show this web page has the home page. So let us see if the thing is ready. Yeah, the thing is ready. So here we have completed the exercise of creating the VM and installing the web server. So now I will show you the similar how to do a setup in Azure cloud. Actually, to verify the web server and to troubleshoot, this thing will be shown in the next video. So let me go to our web portal. So I'm going to Azure portal, login, portal.azure.com. Here with my ID. Actually, to do practicing like this, so you want to do some practice, you can create your own account for test account, then you can just do it. So this is a Microsoft Learn Sandbox account. So when you go to the virtual machine, you will see the VM is already up and running. See, this is the VM we just now created. So when you want to create in the Azure portal, we just go to create, then you see the subscription, we just leave it as the learning subscription, and this is also learn group. Then virtual machine name, so Techify with Adil, VM2. Just we leave the region, then the rest all we just leave it as default. So this one, we will just go for Windows 11. Size, just we leave it as a default size. We can see, change the sizes based on the size whatever is applicable. So we just leave it the default one. So here we need to choose a username. We just use the same username, Azure user. Then we need to choose a password. Then okay, matches, good. Then inbound port rules, so public inbound ports, just leave allow selected ports only. Then select inbound ports is 3389 only. RDP port is open for the public access. Then this one we can select because just this is our Learn Sandbox account, so it should be okay. Next, if you're going to use review and create here, then the rest all the settings will be it will choose the default settings. In case you want to have more customization, just you can do everything like one by one, all the portions you can customize, like network management, monitoring, tag, everything you can customize. So here they have a OS disk size of 110 GB. This is the default one. OS disk type is SSD, premium disk type. So here we got standard, then we have hard disk also. So it's just about us which we want to choose, but the charges will vary based on the customization we do. Then here you can have a create and attach a new disk. Like you have a secondary disk, Then you can attach an existing disk. Just you have an already existing disk, you are recreating this new VM, or you want to move that disk from one VM to another VM. Just you need to detach from the existing VM, then move it to the new VM. Then we go for networking. The networking, because when you create a VM, it needs a networking connection. If not, then it will not be able to connect to the, it will become a standalone, so it will not be able to have any connections. So either you can choose an existing virtual network, or the network will be created by default with the similar name of your VM. This one will be auto created. If you don't choose your VM, if you have any customization, then you can choose, or you can previously create a VM, then you can attach the you can already create a virtual network, then you can attach that virtual network to this VM. Then also the subnet under the virtual network, public IP. The next security group is just none, or you can go for basic and advanced security groups based on the subscriptions we have and based on necessity. Then load balancing option, also Azure load balancer. Then application gateway is all based on your architecture. Then we go for management portion. Generally will be like enable the system assigned management identity, like a system assigned like Azure key vault, like the things to be saved in the Azure key vault. We have discussed about this in the previous videos as well. You can just refer to that for have more detail on Azure key vault. Then log into Microsoft Entra ID, that is Azure Active Directory. It will have a role based assignment for information. Then auto shutdowning, then disaster recovery is all you can enable it. Then enable hot patching, like guest OS patching. Then for monitoring, it will usually do the boot diagnostics or enable OS guest diagnostics. Then application health monitoring, so it will get for the application health monitoring, it will set up a scale set, then record for managing the infrastructure and OSs. Then for example in the OS guest diagnostic, right, you can see here it gets the metrics every minute for your virtual machine. Then it will send alert. Based on that you can set up your alert system, so it will give you the diagnostics for every minute. So it will gather the data for every minute, then it will send to the monitoring part. So it's just your advanced settings, like you need to install an extension, or if you need to install a VM application, then you can choose here. So it will be auto installed to the VM when VM being created. So when the VM being created, it's already will have the extensions installed and will have the applications installed in the VM already. You don't need to install after the login. So here if you have a tag, if you want to tag your VM, then you can use this. So now we go for review and create. Most of the options whatever we chose is all the default one. So here you can see the pricing. So if you're okay with the pricing, then we can go here. Now this is our learn account, so we no need to pay actually. It's just a exercise part. Usually in your when you're creating your test account, like you can create just Outlook or Hotmail account, then you can create a VM, create a Azure account, then you can do all these exercises in it. Then you will also, when you're creating for the first time, you have a credit for I think it's 200 USD for per month some. So you can use that credit for your practicing. So just once after you create your account, you make sure you after create your resources, make sure you shut down it or you delete them, so that you're not being charged when you're not using it. So by that you can utilize the free credits what you get from Microsoft. Then you can have a lot of practicing. So you can see the status already here. So the VM IP, the VM is all under creation. IP is already created. So this is a Microsoft network is being under creation, network interfaces. Then here this is our virtual machine is under creation as well, created. So we also can see the notification here. deployment is under process. So we go back to virtual machine. Then we can see here VM1 is running, VM2 is under creating status, so it will be created. So this also is going to have the public IP, operating systems here, the size, and this is the thing. So this is how we can create a VM using Azure portal and also using the CLI, that's a cloud Azure cloud shell. So in the next video it will be a continuation of the Azure cloud shell exercise. So how we can troubleshoot and how we can connect to the web server what we have created. Here in this video we will see how to configure the network access for the web server which we have created in our previous video. So you can refer back to the previous video how to create a VM through Azure Cloud Shell and also through Azure portal. Okay, let us first activate the sandbox. Okay, yes. Okay, submit. Yes, so I have the sandbox is being signing in. Okay, the first thing is we will get the list of VMs we have created under this sandbox account. Then we have to get the IP address. Then we have to access to that web server. So once we access to the web server, we should get the home page what we have set up, what we set up previously. So say example, we should be getting the home page as so we should be getting the home page as welcome to Azure, my name is the host name. You should get this home page if everything is working correctly. Okay, so now okay, so this is going to give you the list of VMs. So in the previous video itself we would have done two creation. The one is Takeify with Adil VM2. This is we created through accessing the Azure portal, and another VM we created is VM1. That the VM1 we created here. This VM1 we created using Cloud Shell, so through the command line. So these are the two VMs we have created. So we have these two VMs up running already. So we just go to get the IP details to access the web server. So here we should make sure we give the correct name of the VM, because we changed the name from the default name. So make sure we are giving the correct name. So this will get our VM's IP address and store the result as a bash variable. So once it stores as a bash variable, then we should be able to access it through this command line. So it is just connecting to this the IP address which we have obtained from the previous command here. So we are trying to connect. Actually it will not connect, it will give us an error. Yes, so it's timed out, meaning it's not able to connect to the server within the time period. Even after the 5002 milliseconds waiting, it's not able to connect to the server here. So there could be many reasons for this. So we will start with the basic troubleshooting. If our port is open, if the IP address is able to reach, so we will see all this kind of troubleshootings first. Let us run the IP address in the console. So this is the IP address. So let us copy, and I'm just running it here. Okay, we are running it here. By already we can see here it's not able to reach. So we go back. So now we need to check the network security groups. So we copy the command, we paste here. So this command is nothing, we are getting network security group from this resource group. So particular, because we don't need the security groups of all the groups, so we just need from the particular resource group which we have created the VM. So just we extending out. So we have a resource NSG, network security group, TWA VM1 NSG. So this is the NSG, it was created default. So now we have to check the rules in this security group. So we just paste and TWA VM1. So this is the NSG name. So we are getting the NSG rules from the security group. Okay, so this is the NSG rule we got from our security group. So we need to format the output. We have to get the formatted output. So because this one it's very hard for everyone to understand. So but actually you can see here the destination port 22 for the inbound traffic, and the priority is 1000 here, and TCP. So this is the actually port. So for having more clear understanding, we just change the output table format here, output as a table. Oh yeah, we missed to change the NSG name. Supposed to be TWA VM1. Yeah, so we can see here the default allow SSH 1000 port 22 only. So the default available NSG rule is to allow port 22 with the priority of 1000. There is no rules of allowing port number 80, which usually is the one we use when accessing web servers, because it's a HTTP so is the one we use it for so next, now our aim is to create a rules so that it allows port 80. So we have to create a security rule. So we copy this command and we just paste it over here, and we need to update the security rule TWA and VM1 NSG. Yes, so here we are creating. So what does this do is, under the resource group, NSG name, allow HTTP TCP protocol, priority is 100, port number is 80. So we are going to allow this particular port protocol. Okay, so now we are going to check with the rule is created. So we're going to verify with the output table. we need to update, we need to change the NSG name, TWA VM1 NSG. Yeah, the output, see, is already created. So why we give the lower priority is the number lower means the higher the priority. So when your number goes lower, like 99, 80, 70, 60, then the priority goes higher. So always, if you want a rule to be applied to all the first, or should be given more priority, the priority number should be lesser. Okay, so we have already. Now we can test our web server. So now it's very fast, we can get the output already. So we can see it in the web also. Just do a refresh. Yes, boom, welcome to Azure. My name is TWA VM1. So by this we have made the connection. So this exercise is like how to create a new rule in network security group. Then by creating that, then we will be able to establish the connections. So these are the very basic troubleshooting. Even we will be doing in our desktop support, like normal laptops. The only difference is this thing we are doing it in other cloud. So just for the first time might look very vague, and if you understand the concept, or you understand what we are exactly trying to do here, will be very easy for you to move on. So these are very important topics also for exam point of view, for the certifications, for you to understand the concepts. When you create VM, when you're going to be an admin, creating VMs or giving connections, all these concepts whatever we discussed in my previous video and this video are very important. Here we will be discussing about Azure containers. So Azure containers are virtual environment. So much like running multiple virtual machines on a single physical host, you can run multiple containers on a single physical or virtual host. So unlike the virtual machines, you don't manage the operating system for a container. So the virtual machines appear to be an instance of an operating system that you can connect and manage. So containers are lightweight and designed to be created, scaled out, and topped dynamically. So it's possible to create and deploy a virtual machine as application demand increases, but containers are lightweight, more agile method. So containers are designed to allow you to respond changes on demand. With containers, you can quickly restart if there's a crash or hardware interruption. One of the most popular container engines is Docker, and Azure supports Docker. Okay, let us see a small video on this Azure container.
In this video, we'll discuss the difference between virtual machines and containers. So let's begin. Deploying server applications has always been complicated. That complexity drove system admins to start looking at virtualization techniques like virtual machines and containers. Virtual machines, or VMs, provide an abstraction layer for CPU, memory, and storage. They can be changed without having to invest in new hardware, while still allowing the environment to be flexible and secure. With VMs, you're in control. You decide the operating system, install tools and packages, and your app runs either in isolation or with the other apps you install into the VM. But there are downsides. VMs can only run one operating system at a time. So if you have multiple server apps that all require different runtime environments, they may also require multiple virtual machines to execute properly. And because the VM is emulating a full computer, tasks like starting one up or taking a snapshot are pretty slow, often taking several minutes. But there's a lighter weight solution that solves some of these issues: containers. A container bundles a single app and its dependencies, referred to as containerizing the app, then deploys it as a unit to a container host. The container host provides a standardized runtime environment which abstracts away the operating system and infrastructure requirements, allowing the containerized application to run side by side with other containerized apps. An easy way to differentiate between VMs and containers is virtual machines virtualize the hardware, while containers virtualize the operating system. The operating system level virtualization of containers is one reason why the container approach is more efficient than a full virtual machine. It allows you to run multiple lightweight containers on a single host without sacrificing the isolation that the virtual machine originally offered. Azure supports several container variations, the most popular being Docker. Unlike VMs, you can spin up containers quickly. You're just waiting for the app to launch instead of both the operating system and the app. Also, containerized apps tend to be much smaller in size, and the development process is simplified because your development runtime environment can look exactly like the production environment. Another advantage to containers is that they can be orchestrated with container cluster orchestration. You can easily deploy and manage multiple containerized applications without worrying about which server will host each container. The decision of whether to use a VM or container depends on how much flexibility you need. If you need to completely control the environment, then you might choose a VM. If not, then the portability, performance characteristics, and management capabilities of containers might be the better choice.
So Azure Container Instances. Azure Container Instances offer the fastest and simplest way to run a container on Azure. So without having to manage any virtual machine or adapt any additional services. So Azure Container Instances are a platform as a service as a PaaS offering. So Azure Container Instances allow you to upload your containers and then service runs the containers for you. So next is Azure Container Apps. So Azure Container Apps are similar in many ways to a container instance. They allow you to get up and run right away. They move the container management piece and they are PaaS offering. Container apps have extra benefits such as ability to incorporate load balancing and scaling. These other functions allow you to be more elastic in your design. So Azure next service will be the Azure Kubernetes service. So Azure Kubernetes service in short AKS is a container orchestration service. So an orchestration service manages the life cycle of containers. When you are deploying a fleet of containers, AKS can make the fleet management simpler and more efficient. So use containers in solutions, like what solutions we can use the container. So you might split a website into container hosting your front end, another hosting your back end, and the third for your storage. So this split allows you to separate portions of your app into logical sections that can be maintained, scaled, or updated independently. So imagine your website backend reaches capacity, but the front end and the storage aren't stressed. So with containers, you could scale up the backend separately to improve performance. If something necessitated such a change, you could also choose to change the storage service or modify the front end without impacting any of the other components. So say this is an important difference between a VM, using a VM and using the containers. So you can have this logical split of your applications running, so that you can scale up or scale down only the particular portion which is having high traffic or low traffic. So in short, the containers are very lightweight, portable, and self-sufficient way to run the applications. When we are talking about VMs, so VMs are like workloads on virtualized hardware. So your VMs are stronger isolation since the VM has its own operating system, but the other way, the containers share the host OS. So this makes the VM more secure but heavier in terms of resource usage, because it doesn't share the host, like it has an individual, or it has a separate operating system hardwares and separate as an isolated atmosphere. So it makes it heavy and more resource usaging thing. Then in case of resource efficiency, containers are more lightweight and efficient in terms of resource usage compared to VMs, as explained in the previous point. Then for portability part, right, containers are more portable and can be easily moved between the environments, while VMs are more tied to the underlying infrastructure. Moving a VM is not that easy as and simple as the moving the containers. Then for scaling part, containers can be scaled more quickly and efficiently than VMs, especially the context of microservices architecture. So the one which we explained here. So because you are going to just scale up the microservices architecture, only the portion of the application which needs more resources only. So you're not going to scale up the entire whole machine. So that makes it very easier and simpler for scaling up. So these are the comparisons between Azure VM and Azure containers. And also it just depends on the situations, and it just depends on our requirement. Okay, we see the creation of container here. So this is my account with free subscription. So when you have an Azure account, you can have a free 1 year free subscription with the $200 USD of equivalent credit. You can use that to do your practices. Just make sure any resources you create, you shut down them before your closing, so that you are not charged for it to running backend. So you can search for the Azure containers here, then click on create. So resource group, I just create a resource group. G1. Then container name, Techify with Adil. Sorry, Techify with Adil. Container 1. Okay, then availability zone. So okay, just we leave it as standard, and SKU as a standard one. So here you can for image, you just leave it as quick start image. There's a default one, or you can just choose. So this is so here I'm using other registry, meaning under the Docker. So here you can see I have added Nginx. This is actually a web server. So in my previous video for Azure virtual machine creation, under the video we would have done the same creation of web server, but for that we would have created the base as virtual machine. So we have to first create a virtual machine, then do the all connections for the virtual machine. Once that's all done, then we install the web server on it to run. So in this container exercise, we no need to do all those setup. We just use the image, and we are just going to make it up and run. So this is a very basic differences how the container is more helpful, but the thing is it's just based on your requirement. So in general your Azure virtual machine is going to be heavy, like it has more control over the OS and the structures and everything, which the container doesn't have. So it just depend on our requirement. So we have validated everything and we are just ready to go. So once you click on the create, so it is going to create your Azure container for NGX web server setup. So this is going to be more easier and more easy to set up and also to create when compared to your virtual machine, because it's going to be a platform as a service thing. So your infra, everything is managed by your Microsoft here. So it's going to be very easy for the creation purposes. That's why it's called as a lightweight Azure instance. In this video we will be discussing about Azure Functions. So Azure Function is an event-driven serverless compute option that doesn't require maintaining a virtual machine or containers, as we have discussed already about virtual machine and also the container in our previous videos in detail. So if you build an app using VMs or container, those resources have to be running in order for your app to function. With Azure Functions, an event wakes the function, alleviating the need to keep the resources provisioned when there are no events. So the thing is, when we are hosting an application or some functions in Azure VM or in containers, the containers or Azure VM should be kept running. So we cannot turn it down or stop it. So because it's a manual work, there is nothing like something to trigger the VM to start, or to VM for the containers to start when there is a request. But the other side, for Azure Functions, it only works when there is a requirement. If there is no requirement, it doesn't run. Benefits of Azure Functions. So using Azure Functions is ideal when you are concerned about code running your service and not about the underlying platform or infrastructure. Functions are commonly used when you need to perform work in response to an event, timer, or message from another Azure service, and when that work can be completed quickly within seconds or less. So functions scale automatically based on demand, so they may be a good choice when demand is variable. So Azure Function runs your code when it triggers and automatically deallocates the resources when the function is finished. So that's the thing we explained here. So when the function runs your code, when it triggers and automatically deallocates the resource, so it's not being run when it is not required. This is done automatically. That's the important thing. In this model, Azure only charges you for the CPU time used while your function runs. Functions can be either stateless or stateful. So when they are stateless, the default is stateless. They behave as if they restart every time they respond to an event. When they are stateful, called durable function, a context is passed through the function to track prior activity. Functions are a key component of serverless computing. They are also general compute platform for running any type of code. If the needs of the developer's app change, you can develop the project in an environment that isn't serverless. This flexibility allows you to manage scaling, run on virtual network, and even completely isolate the function. So application hosting options. So to host your application on Azure, you might initially turn on virtual machine or containers. So both VMs and containers provide excellent hosting solutions. So VM give you maximum control of the hosting environment and allow you to configure it exactly how you want. VMs also may be the most familiar hosting method if you are new to the cloud. Containers with the ability to isolate and individually manage different aspects of the hosting solution can also be a robust and compelling option. So yeah, the VM and also the container part, you can refer back to our previous videos to have a detailed knowledge on how VM can be created and where it can be used and how containers are created and so on. There are other hosting options that you can use with Azure, including Azure App Service. So deployments from GitHub, Azure DevOps, or any other Git report to support a continuous deployment model. Azure App Service is a robust hosting option that you can use to host your apps in Azure. Azure App Service lets you focus on building and maintaining your app, and Azure focus on keeping the environment up and running. So the app hosting, it's being divided into two portions. The one is building and maintaining the app. The one is maintained by us. The other part, environment and running, will be managed by the Azure. Whereas the Azure VM and so on, we have to maintain both the portions. So Azure App Service is an HTTP based service for hosting web applications, REST APIs, and mobile backends. So it supports multiple languages including .NET, .NET Core, Java, Ruby, Node.js, PHP, or Python as well. It also supports both Windows and Linux environments, so it's very broadly supportable. App Service enables you to build and host web apps, background jobs, mobile backends, and RESTful APIs in the programming language of your choice without managing the infrastructure. Just you will have to build and manage the apps and jobs in that. The backend infrastructure is not our concern and is managed by the Azure. So it offers automatically scaling and high availability. App Service supports Windows and Linux. It enables automated. So types of app services: web app, API, web job, and mobile apps. So app service handles most of the infrastructure decisions you deal with in hosting web app accessible apps. Deployment and management are integrated into platform. Endpoint can be secured. Sites can be scaled quickly to handle high traffic loads. The built-in load balancing and traffic manager providing high availability. All of these app styles are hosted in the same infrastructure and share the benefits. This flexibility makes app service the ideal choice to host web-oriented applications, because when you have our web-oriented applications, the important thing we will look for is high traffic, which is solved by scaling, and this scaling is managed in app service. Then the load balancing and traffic managing part for high availability is another key thing we will be considering when having our web applications, and which is also is inbuilt in the app services. So this all makes it a better choice for web oriented applications. So web apps. So app service includes full support for hosting web apps by using ASP.NET, ASP.NET Core, Java, Ruby, Node.js, PHP, or Python. So you can choose either Windows and Linux as the hosting operating system. For API apps, much like hosting a website, you can build REST-based web APIs by using your choice of language and framework. So you get full Swagger support and the ability to package and publish your API in Azure Marketplace. The produced apps can be consumed from any HTTP or HTTP based clients. So you can create an API app with any language of your choice and also framework, and it can be published in your API in Azure Marketplace and easily accessed from any HTTP or HTTP based client. You can use the web jobs feature to run a program in the same context as the web app, API app, or mobile app. They can be scheduled or run by a trigger. Web jobs are often used to run background tasks as part of your application logics. So any background tasks for your application logic, so based on any logic you set up in application, there needs to be a background task to be run. So if like equal to 1, then you need something to run, then equal to 2 or something you need to run, s something you have to run. So all these things can be programmed and run and kept running using the web jobs. Mobile apps. Use the mobile apps feature of app service to quickly build backend for iOS and Android apps. With just few actions in Azure portal you can. So usually we have this mobile app developers, all we will have to do a lot of coding and lot of structure, a lot of creations, and spend a lot of time in mobile app creations. So which makes the Azure mobile apps makes it easier for all those people. So store mobile app data in a cloud-based SQL database. Authenticate customers against common social providers such as MSA or Google or Twitter and Facebook. Send push notification. Execute custom backend logic in C# or Node.js. So all these things can be achieved with mobile apps. So these are the app functions for hosting, app services for hosting the apps. We will see a comparison of all these three, because in general when you look at first time, all these three will look very similar, like used for same functions, but what could be the differences? So each has their own advantages and strength. So let us see the comparison between other three. So first here, Azure virtual machines. So best for scenarios like we need full control over the operating system and environment, such as custom applications. You want to run a custom application and legacy systems. Then Azure Container Instances is ideal for running isolated containers without managing the underlying infrastructure, suitable for burst workloads and task automations. Then Azure Functions, so perfect for event-driven applications and microservices, offering automatic scaling and serverless experiences. Okay, so Azure virtual machine. So generally who will be dealing or acting with this is system administrators and developers. So like use cases will be deploying custom application, then managing the OS and infrastructure, scale manually and automatically. This has both the options. So to know what is about scaling, because we have been talking scaling at every point, because it's one of the important function in Azure. So scaling also we have explained in our previous video how the scaling is, what is the manual and what is the automatic. You can refer back to the video. Then Azure Container Instances. So here usually the DevOps engineers and developers will be the one who acting with this. So use cases will be run isolated containers, automate tasks and scale containers. Then Azure Functions, so developers event sources like HTTP requests, timers and all these things will be using this Azure Functions. So use cases like execute event driven code, handle background process, scale automatically. So here it's both manual and automatic scaling. Here scale containers, then here it is automatic scaling. You can see here execute event driven code, meaning based on some event occurring it will execute the code. So based on the request it runs the code. So all these things backend process is all mostly we go for Azure Functions. We will see a table comparing these three. So for the purpose, full control over OS environment. If this is your purpose, then you should go for Azure Virtual Machine. Run containers without managing VMs. You don't want to run manage VM, but you want to run containers, then Azure Container is the best option. Serverless compute for event-driven applications. You want to run a serverless compute for event-driven related applications, then Azure Function is your best choice. For use cases like custom application, legacy apps and complex setups, because we will have full control, so we can do any kind of customization. So we go for Azure virtual machine. Burst workloads, task automation, isolated containers. You want to set isolated containers, you want to automate a task, or you have like burst workloads, then container is the best option. Event driven tasks, microservices, and background process, Azure functions again. So in the management requires managing OS updates and patch. You will be managing everything as you have the full control over the OS and that environment. So no VM management is involved, just focusing on containerized apps only. So in Azure functions, no infrastructure management, just focus on the code that's going to be run or going to be triggered by some event. Scalability, as we see in previous slide, manual and automation here manual scaling, limited auto scaling, that's Azure scaling container. Then here automatic scaling based on the demand. So here it's fully automated based on the demand or based on traffic. Startup time will be minutes for VM, then seconds for containers, and milliseconds for Azure functions. In case of cost, pay for VM uptime. So once your VM is up running, you will have to pay for the time it's running. Then for container case, pay per second for container runtime. The same like the VM, it's the runtime of the container you will have to pay. And for the Azure functions, pay per execution and resource consumption only, because in the Azure function, the previous video for Azure function, you can, if you look at that, you will understand that Azure functions will only be active when it's required or when it's being triggered. If it is not triggered, it will go automatically to deallocated state. So only during the execution or resource consumption you will have to pay. Complexity is high because of high management and all setup is all on us, so it is high management. This is medium level, and the Azure functions is low level managed complexity. Then integrated with all Azure services. Containers integrated with Azure services, supports Kubernetes. So we have explained in the container video. Integrates with Azure services, supports various triggers. Security, full control over security settings, hypervisor level isolation managed by Azure, focus on app level security. So the rest of the things is managed by Azure, so just we have to focus on the app level security only. The thing which we are going to trigger or the application, just focus on that will do. So this is a comparison between those three. So I think you'll have a clear vision on those three, Azure VM, then container, and Azure functions. So based on that, you can choose which you would like to use it. As we have mentioned before, you can have a free account in Microsoft Azure, then you can do some practices so that you get more familiarized with creating, deleting, or doing functions. You will get more familiarized with that. So here Azure virtual networking. So Azure virtual networks and virtual subnets enable Azure resources such as VMs, web apps, and databases to communicate with each other, with users on the internet, and with your on-premises client computers. So in general, Azure virtual network is a network that helps to connect to our on-premises network and connection within the Azure resources, a secure connection to connect to other Azure resources and to our on-prem network with the users through the internet as well. So an Azure network line like an extension of your on-premises network with resources that link other Azure resources. So Azure virtual network provide the following the key networking capabilities like isolation and segmentation, internet communication, communicate between Azure resources, communicate with on-prem resources, route network traffic, filter network traffic, connect virtual network. So we will discuss about each of this separately. So Azure virtual networking supports both public and private endpoints to enable communication between external or internal resources with other internal resources. Public endpoint have public IP address and can be accessed from anywhere in the world through the internet. Then private endpoints exist within a virtual network and have private IP address from within the address space of that virtual network. So first network capability topic we'll be seeing is isolation and segmentation. So Azure Virtual Network allows you to create multiple isolated virtual networks. When you set up a virtual network, you define a private IP address range space by using either public or private IP address ranges. So the IP range only exists within the virtual network and isn't internet routable. So this is one of the important thing to take note. You can divide that IP address space into subnets and allocate part of the defined address space to each named subnet. For name resolution, you can use the name resolution service built into Azure. You also can configure the virtual network to use either an internal or an external DNS server also. So Azure also has an inbuilt name resolution service. You can use that, or you can just use your DNS server. It can be an internal or external as well. So next, internet communication. So you can enable incoming connections from internet by assigning a public IP address to an Azure resource or putting the resource behind a public load balancer. So communicate between Azure resources. So to establish communication between Azure resources, we have two secure ways. The one is virtual network, the other one is service endpoints. So this virtual network can connect only VMs, but it does not only connect the VMs but also the Azure resources such as app service environment for Power Apps, Azure Kubernetes services, and Azure virtual machine scale sets. But the service endpoint can connect to other Azure resource types such as Azure SQL database and storage accounts. So this approach enables you to link multiple Azure resources to virtual networks to improve security and provide optimal routing between resources. So communicate with on-premises resources. So will be the next thing. Azure Virtual Network enable you to link resources together in your on-premises environment and within your Azure subscription. So it enables you to link the resources together in your on-premises environment and also within your Azure subscription. In effect, you can create a network that spans both your local and cloud environments. There are three mechanisms for you to achieve this connectivity. So communication to the on-premise resources, we have three methods to do it. So one is point-to-site virtual private network, the other is site-to-site virtual private network, and the other one is Azure Express Route. So this point-to-site connections are from computer outside your organization back into the corporate network. In this case, the client computer initiates an encrypted VPN connection to connect to the Azure virtual network. The next is site-to-site. So link your on-premises VPN device or gateway to the Azure VPN gateway in a virtual network. In effect, the devices in the Azure can appear as being in the local network. The connection is encrypted and works over the internet. So in simple words, point to site we can compare like it's our like a work from home. So we are working from home, then we are using a secure VPN connection that runs over the internet to access our data in our office. So that's site, that is from point to site. The site to site is like the companies in two different locations, maybe the second unit or second branch. So from one unit to another unit we are connecting through a secure connection that runs over the internet. So this is going to be site to site virtual private network. And the third type is Azure Express Route. So this provides a dedicated private connectivity to Azure that doesn't travel over the internet. Express Route is useful for environments where you need greater bandwidth and even higher levels of security. So this is very similar to the to the other virtual private networks, what we discussed. But the difference is it's not going to run through the internet. It will have a dedicated line, so you're going to have your special line connecting to the site and to the user. So from the user side, they will be connecting to the office or to the Azure resources with a dedicated line, so it doesn't share with the internet, so it's more secure and can have higher bandwidth since it's going to be your dedicated line. So these are the three methods we can have connectivity from the on-premise to the on-premise resources from Azure resources. Then route network traffic. So by default, Azure resources, Azure traffic routes between subnets on any connected virtual networks, on-premise networks, and to the internet. You also can control routing and override those settings as follows. So one is routing table, the other one is border gateway protocol. So using the route table, this allows you to define rules about how the traffic should be directed. So you can create custom route tables that control how packets are routed between subnets. So this routing tables are very basic. Whoever has from networking or who has done the basic learnings on like CCNA or networking concepts, you have learned about the routing tables. So it's very simple, just you have to learn about this routing table to understand this. So our routing table is like a predefined route. So if the data reaches a particular node, then where it should be directed to, so it will be predefined. So that's the routing table. The second one is border gateway protocol. So this is a protocol used for data trafficking also. This works with Azure VPN gateways, Azure route server, or Azure Express route to propagate on-premises BGP routes to Azure virtual networks. So these are the two ways that we can use it to override the default settings available in Azure that controls the routing of network traffic. Then filter network traffic. So Azure Virtual Network enable you to filter traffic between subnets by using the following approaches. The one is network security group. The other one is network virtual appliances. So the network security groups, NSG, we call shortly as NSG, are Azure resources that can contain multiple inbound and outbound security rules. So you can define these rules to allow or block traffic based on factors such as source and destination IP addresses, port, and protocol. So this energy we have used in one of our previous video, where we will be establishing connection after we creating a VM. After we create a virtual Azure virtual machine, then we would have established a connection. So there I have explained about this network security group. You can just refer back to that video. The link will be posted here, so you can just refer back to that video here. So network security groups are the Azure resources that just we create some rules like inbound, like when any network traffic comes inbound with this particular protocol, port number, or with this IP address, what it should be done. Or any data is trying to go out with this particular port number, protocol, and with this IP address, what it should be done. It should be blocked or it should be allowed. So all these can be derived in a group called network security group. So next is network virtual appliances. These are specialist VMs that can be compared to hardened network appliances. Okay, a network virtual appliance carries out a particular network function such as running firewall, performing WAN optimization, or such things. So network virtual appliances is a VM that runs the network functioning like firewall and WAN optimization, such things. So this network security group is a Azure resource. It's not a VM, it's Azure resource, whereas the network virtual appliance is a VM that runs functions of controlling the network. Next is connect virtual network. So you can link virtual networks together by using virtual network peering. Next, the peering allows two virtual networks to connect directly to each other. So network traffic between peered networks is private and travels on Microsoft backbone network, never entering the public internet. Peering enables resources in each virtual network to communicate with each other. These virtual networks can be in the separate regions. This feature allows you to create a global interconnected network through Azure. So user-defined routes allow you to control the routing tables between subnets within the virtual network or between the virtual networks. This allows for greater control over the network traffic flow. So one thing here we need to understand about is peering. So when you are doing peering between two virtual networks, though that is like a Azure's private network, so it doesn't go to the public internet, and it's being communicated only within the Azure's backbone network. So this is an important thing we need to remember with the exam point of view. So peering, and also the user defined routes allow you to control the routing tables between the subnets within a virtual network. So Azure via VPN uses encrypted tunnel within another network. So VPNs are okay. In general, we know what the VPNs are. So if you are connecting to resources in our office from the outside the office network, then we usually use VPN to have a secure connection. So the same thing is also done using the Azure virtual private networks. So in virtual private network, we will be seeing a few technical terms which is being implemented in the architecture of the Azure VPNs. So in VPN gateways, so a VPN gateway is a type of virtual network gateway. So Azure VPN gateway instances are deployed in a dedicated subnet of the virtual network and enable the following connectivity. So we should have a virtual network, and this VPN gateway are deployed in that virtual network. And also you should make note, it is deployed in a dedicated subnet of the virtual network. So if you are going to create a VPN gateway, then you should already have a virtual network subnet. Okay, so the following should be enabled for the connectivity. So connect on-premises data centers to virtual networks through a site-to-site connection. Then connect individual devices to virtual networks through a point-to-site connection. Connect a virtual network to other virtual networks through a network-to-network connection. So these are the three scenarios we need to enable we'll be using the VPN. So all data transfer is encrypted inside a private tunnel as it crosses the internet. You can deploy only one VPN gateway in each virtual network. That's why we mentioned it is as deployed in a dedicated subnet. So you can have only one VPN gateway in each virtual network. So however, you can use one gateway to connect multiple locations, which includes other virtual network or on-premises data centers. So when setting up a VPN gateway, you must specify the type of VPN. So either policy based or route based. So the primary distinctions between these two types is how they determine whether the traffic needs encryption in Azure. Regardless of the VPN type, the method of authentication employed is a pre-shared key. So policy based VPN gateways specify statistically the IP address of packets that should be encrypted through each tunnel. This type of device evaluates every data packet against those sets of IP addresses to choose the tunnel where that packet is going to be sent through. The route-based gateways, IPsec tunnels are modeled as a network interface or virtual tunnel interface. IP routing decides which one of the tunnels interfaces to use when sending each packet. So we know usually the route based thing how it works. So we have routing tables which we have discussed in my previous video how the routing table thing is. So for the route based gateways, it is going to be, as the name says, it will work as the predefined instructions. So it will decide based on the route based, it will choose the tunnels to interfaces to go on. With the policy based is, it will decide based on the policy that applies to the data packet. So these are the two ways of setting up the VPN gateway. So it should work either with the route based or with the based on the policy. So route based VPNs are the preferred connection method on premises devices. They are more resilient to topology changes such as creation of new subnets, because the routes are predefined, so it's easy to work in on premises devices. So use a route based VPN gateway if you need any of the below connectivities, like connections between virtual networks. So if you're connecting to virtual networks, then point to site connection, then multi-site connections, coexistence with an Azure Express gateway. So if you're going to your goal is to achieve any of the below, then route based VPN gateway is preferable. So high availability scenarios, if you are configuring a VPN to keep your information safe, you always want to be sure that it's highly available and fault tolerant VPN configuration. There are few ways to maximize the resilience of your VPN gateway. So active standby. Okay, by default VPN gateways are deployed as two instances in an active standby configuration. So even if you only see one VPN gateway resources in Azure, when planned maintenance or unplanned disruption affects the active instance, the standby instance automatically assumes responsibility for connections without any user intervention. So the connections are interrupted during this failover, but they typically restore within few seconds for planned maintenance and within 90 seconds for unplanned interruptions. That's the active standby configuration. The other way is active configuration. So with the introduction of support for BGP routing protocol, you can also deploy VPN gateways in an active configuration. In this configuration, you assign a unique public IP address to each instances. So each instance will have a separate IP address. So you then create a separate tunnels from the on-premises device to each IP address. You can extend the high availability by deploying an additional VPN device on premises. So it's like having two different connections. So it will have a two different IP address and two different unique tunnel. So the first active standby is, it's like a backup. Second connections is a backup connection. So once the first one failed, the second gateway gets activated. So express route failover. So another high availability option is to configure a VPN gateway as a secure failover path for a express route connections. So we have seen what's this express route connection in our previous video. So express route connections is like setting up a dedicated tunnel for in the Azure to connect in through the public network, but through a dedicated connection. So express route circuits have resiliency built in. So however, they aren't immune to physical problems that affect the cables delivering connectivity or outages that affect the complete express route location. So in high availability scenarios where there's risk associated with an outage of an express route circuit, you can also provision a VPN gateway that uses the internet as an alternative method of connectivity. So in this way, you can ensure there's always a connection to the virtual networks. So in a high availability scenario where there's a risk of associated with an outage of an express route circuit, you can also provision a VPN gateway that uses the internet as an alternative method. So this doesn't fulfill the express routes dedicated line, but still your connection is going to be available with an secured VPN connection. So we are using VPN connection as an failover for express route. The zoned redundant gateway. So in regions that support availability zones, VPN gateways and express route gateways can be deployed in a zone redundant configuration. This configuration brings resiliency, scalability, and high availability to virtual network gateways. So deploying gateways in a Azure availability zones physically and logically separates gateways within a region while protecting your on-premises network connectivity to Azure from zone level failures. These gateways require different gateway stock keeping units and use standard public IP addresses instead of basic public IP addresses. Azure Express Route. Okay. So Azure Express Route lets you extend your on-premises network into Microsoft Cloud over private connection with the help of a connectivity provider. This connection is called an Express Route Circuit. So features of benefit of Express Route. So there are several benefits using this Express Route Circuit. So connectivity to Microsoft Cloud resources across all regions in the geopolitical region. Global connectivity to Microsoft services across all regions with the Express Route global reach. Then dynamic routing between your network and Microsoft via border gateway protocol. So built-in redundancy in every peering location for high reliability. So these are the benefits of using Express Route. Then connectivity to Microsoft Cloud services. Express Route enables direct access to the following services in region. So direct access to Microsoft 365, Microsoft Dynamics 365, then Azure Compute services such as Azure Virtual Machines, then Azure Cloud services such as Azure Cosmos DB database and Azure Storage. So these Express Route connectivity enables a direct access to all these services. So global connectivity. So you can enable Express Route global reach to expense the sites by connecting your Express Route circuits. For example, you have an office in Asia and the data center Europe, both the Express Route circuit connecting them to the Microsoft network. You could use the Express Route global reach to connect through two facilities, allowing them communicate without transferring data over the public internet. Then dynamic routing. So Express Route uses the BGP, that is Border Gateway Protocol, is used to exchange routes between on-premises network and resources running in Azure. So this protocol enables dynamic routing between your on-premises network and services running in the Microsoft Cloud. So this dynamic routing, most of us who already been working with the basic networking portions would have known. So dynamic routing is like based on the availabilities, there will be multiple routes to reach point. So say example, we have point A, B and C. So B there's three nodes A, B and C. So to reach the point endpoint, so we can either use B or C. So if it is a static routing, it will always follow the static route. So we are asking A to reach the endpoint, say D. So it will all, if the routing table says A to go B and B to reach C, it will always follow that. Even if B is down, then it will be unreachable. It won't reach D. It won't take the alternative path. When it goes for the dynamic routing, if B fails, it automatically switches to C, an alternative path to reach D. So it's more efficient when compared to the automatic routing. So this dynamic routing is being used in the Border Gateway Protocol. Then built-in redundancy. So each connectivity provider uses redundant devices to ensure that connections established with Microsoft are highly available. You can configure multiple circuits to complement this feature. So Express Route connectivity models. So Express Route supports the four models that you can connect your on-premises network to Microsoft Cloud. So Cloud Exchange, co-location, point-to-point Ethernet connection, any-to-any connection, and directly from express route site. So what is this co-location at a cloud exchange? So co-location refers to your data center, office, or other facility being physically located at a cloud exchange such as an ISP. If your facility is co-located at a cloud exchange, you can request a virtual cross connect to the Microsoft cloud. That is co-location at a cloud exchange. So point-to-point Ethernet connection is point-to-point Ethernet connection refers to using a point-to-point connection to connect your facility to the Microsoft cloud. It's a direct one-to-one connection kind. Then any-to-any with you can integrate your wide area networking, that's WAN, with Azure by providing connections to your offices and data centers. Azure integrates with your WAN connection to provide a connection like you'd have between your data center and any other branches. Like your Azure will be like one of the other unit or other branch you are connecting to from your office. Then direct connection from express route sites. So you can connect directly into the Microsoft global networks at a peering location strategically distributed across the world. So express route direct provides dual 100 Gbps or 10 Gbps connectivity, which supports active connectivity at scale. So these are the connectivity models, express route connectivity models we can use. The Azure DNS is a hosting service for DNS domain that provides a name resolution by using Microsoft Azure infrastructure. So usually we would have come across the DNS server in our on-prem. So Azure has a service called Azure DNS. So this service helps you do the same task of what your on-prem DNS server will be doing. Just this is a Microsoft Azure infrastructure providing service. So what are the benefits of using Azure DNS? So it provides you good reliability and performance, then good security, ease of use, then customizable virtual networks and Alias records. It supports Alias records. So we will see one by one the benefits of Azure DNS. So reliability and performance. So DNS domain in Azure DNS are hosted on Azure global network of DNS name servers, providing latency and high availability. So Azure DNS uses anycast networking. So the closest available DNS server answers each DNS query, providing fast performance and high availability for your domain. So how it's able to attain this reliability and performance is, once you have your records added to your Azure DNS, so those details are hosted on Azure global network of DNS name servers. So it provides high availability. So all globally available DNS name servers will have your record. So Azure DNS uses anycast networking. So we know what's anycasting. So anycast means like when your client is requesting for some details or requesting for some name or location of IP address, then it goes to any of the nearest available server to obtain the data. So there's another networking cast called unicast. Unicast means it's mostly we can compare to our office and our home network, especially because all our client requests will just go to a single point server, usually our home router. Then the router provides you the information. If there is a high traffic of queries going to your router, it takes delay in your reply, and if the server doesn't have data, then it takes more because it has to go back check to your universal DNS. So that is unicasting. So here in Azure case it uses anycast. So we have globally deployed multiple DNS name servers. So your request will go to any of the closest available servers so that you get your answer very fast. The performance is high. Then for the security part, Azure DNS is based on Azure Resource Manager, which provides features like role based access control. So with Azure, this is very common. Role based access control, we are being looking at it at every point of Azure topic. So Azure role based control can be used in Azure DNS. Then activity logs to monitor how a user in your organization modified a resource or to find an error when troubleshooting. So like any admins or whoever has access to uh, the connections resources, so anybody making any modifications, it will be recorded in the activity logs. Then we have lock function, so which means we can lock a subscription, resource group or resources from preventing it from accidental deletion or modifying the critical resources. Then for ease of use, Azure DNS can manage DNS records for your Azure services and provide DNS for your external resources as well. So Azure DNS is integrated in the Azure portal and uses the same credentials, support contract and billing as your other Azure services, which makes it very easy for managing and billing. Because Azure DNS is running on Azure, it means you can manage your domains and records with the Azure portal, Azure PowerShell commandlets, and the cross-platform Azure CLI. So the same way how you will be accessing your normal Azure resources, the same way you can access to the Azure DNS as well. You don't need some special tool or special portals to access it. Applications that require automated DNS management can integrate with the service by using the REST API and SDKs. Then customizable virtual network with private domain. So Azure DNS also supports private DNS domains. So this feature allows you to use own custom domain name in the private virtual network rather than being stuck with Azure provided names. Usually when we are creating the Azure accounts, then your domain name will be like, for example, here we can say techify with Adil at dot on Microsoft.com, something like this. So which always will have your Azure provided name. So these are all the example of Azure provided name. So you can have your own customized private DNS names also. Say techify with Adil.com, like techify with Adil.in or .sg, something like that. So once you have this kind of private DNS domains, you just need to add your records, and Azure DNS also supports this. So it's not only since it's an Azure service, doesn't matter, it only is going to support your Azure provided names, it's going to support also your private DNS names. Then alias records. So Azure DNS also supports alias record set. So like you have an alias name for your public IP address or for your traffic manager or for CDN endpoint, then that can also be supported using the DNS, Azure DNS. So yeah, this is about the alias record support as well. So we see Azure DNS is like having very good benefits of like using alias record, can use private DNS, and it's very globally deployed, and it's using any cast, so that your performance will be higher. So just beyond all this, to just have more clarity, so we will just I have made a comparison between Azure DNS with on-prem DNS, what we usually or our infra people usually have dealt with. So the Azure DNS, right, so it's a managed service. So as mentioned before, it's a service from Azure, it's a managed service. So Azure DNS is fully managed service, meaning Microsoft handles all maintenance, updates and security patches for you, just you are using the service. Scalability, it offers high scalability and can handle large volumes of DNS queries without requiring additional infrastructure. Then high availability, Azure DNS has built-in high availability and redundancy features, ensuring reliable DNS resolution. Then cost efficiency is more cost efficient as it eliminates the need for physical hardware and reduces the operational cost. Integration with Azure services. Seamless integration with Azure service, making it easy to manage the DNS for resources hosted in Azure. DevOps friendly. So supports automation and integration with DevOps workflow through Azure Resource Manager ARM templates. So this ARM we will discuss in a separate video. Then on-prem DNS server. So this, as we know in general, when we are having on-prem, then it's going to have a full control over that. So we have also seen the advantage of having our on-prem server in my previous video of Azure virtual machine, and also the on-prem. What's the difference of having the machine in our on-prem? Then including software, hardware, and configuration, everything, we have a full control over the on-prem DNS server. So it allows for extensive customization, because everything we have in control, so we can do any kind of customization policies. Whatever we need, we can make customization in the DNS server. Then existing investments, like utilizes existing investment in the DNS structure, which can be beneficial for organization with established system. Then latency may offer lower latency for on-prem resources, as DNS query do not need to transfer the internet, like your DNS service in your office. This is the case only when your data center and you working in the same network. If your data center is going to be at a different data center is in a different location, and you're working from a different location your office is, then obviously it has to travel through the internet. Then we don't achieve this lower latency. So it's attained only when everything is located within the same network. Security can be configured to meet specific security requirements and compliance standards. Also we have a third model, like hybrid approach. So this hybrid DNS resolution is defined here as enabling Azure Resource to resolve your on-prem domains and on-prem DNS to resolve your Azure private DNS zones. So it's like both works interrelated. Your on-prem domains will help to resolve, Azure resources will help to resolve your on-prem domains, and the other way, your on-prem DNS will also resolve your Azure private DNS zones. Like for organization needing both the on-prem and cloud resources, they go for this kind of approach. So this involves using Azure DNS private resolver along with on-prem DNS servers to ensure seamless name resolution across both environments. So here the key point is Azure DNS private resolver. So this one we will be discussing in our next playlist of Azure administration. So we will see in deep into this, what this private DNS resolver is, how it's being used. So for now, you just make note that when you're using hybrid approach, the Azure DNS private resolver is the key thing used for name resolution. Then Azure DNS Private Resolver is a service that can resolve on-premise DNS queries for Azure DNS private zones. Storage account provides a unique namespace for your Azure storage data that is accessible from anywhere in the world over HTTP and HTTPS. So your storage account will have a unique name that you can access through your browser. Through internet, you can access directly to your storage account. So data in this account is secure, highly available, durable, and massively scalable. So when you create your storage account, you will start by picking the storage account type. So the type of account determines the storage services and redundancy options and has an impact on the use cases. So below is the list of redundancy options. So we will see in detail about the redundancy options in the following slides. So now here let us see what are the types. So locally redundant storage, LRS, geo redundant storage, GRS, read access, geo redundant storage, RAGRS, zone redundant storage, ZRS, geo zone redundant storage, read access, geo zone redundant storage. So these are the 6 types of redundancy options available. So here we will see a video explaining about Azure storage account.
Azure Storage is Microsoft's cloud storage solution for modern data storage scenarios. Core storage services offer a massively scalable object store for data objects, disk storage for Azure virtual machines, a file system service for the cloud, a messaging store for reliable messaging, and a NoSQL store. Azure Blob Storage is an object storage solution that you can use to store massive amounts of unstructured data, such as text or binary data. Blob storage is ideal for serving images or documents directly to a browser, storing data for archives or distributed access, streaming video and audio, and disaster recovery scenarios. Azure File Storage offers fully managed file shares in the cloud, and shares are accessible using industry-standard network protocols. Mounting Azure file shares is just like connecting to shares on your local network. Azure Disk Storage provides disks for virtual machines and applications to access and use as they need, similar to how they would access disks that were on premises. Azure offers both solid-state drives for higher performance workloads and conventional hard drives for your less critical business scenarios. Azure Table Storage offers a NoSQL data store for key value pairs using large-scale datasets. You can use Azure Table Storage to store petabytes of semi-structured data and keep your costs down. Azure Queue Storage provides asynchronous message queuing for communication between application components, whether they are running in the cloud, on the desktop, on premises, or on mobile devices. There are 3 Azure storage tiers that you can use to balance your costs: Hot, Cool, and Archive. The Hot storage tier is optimized for storing data that is accessed frequently, such as images for your website. The Cool storage tier is optimized for data that is infrequently accessed and stored for at least 30 days, such as customer invoices. And the Archive storage tier is appropriate for data that is rarely accessed and stored for at least 180 days, such as long-term backups. Regardless of your business scenario, Azure has a solution to help you manage your storage needs.
Okay, so next we will see the type of storage. So the first one is standard general purpose v2, that's version 2. Then what services it supports, like blob storage, including the data lake storage, then queue storage, table storage, and Azure files. So redundant options are LRS, GRS, RAGRS, ZRS, GZRS, GZRS. So it supports all the available redundancy options. Then the usage of this type is standard storage account type for blob, file shares, queue, and tables. So recommended for most scenarios using Azure storage. So if you want to support NFS in Azure file, use the premium file share account type. Then premium block blobs. So this supports blob storage. So LRS and ZRS only the redundancy options. So premium storage account type for block blobs and append blobs, recommended for scenarios with high transaction rates and or that are smaller objects or require consistently low storage latency. Next is premium file shares. So used for Azure files. Then LRS and ZRS are the redundancy options. So this is recommended for enterprise or high performance scale applications. So use this account type if you want a storage account that supports both server message block SMB and NFS file share. Then premium page blobs. So it supports page blob only, and it support only LRS redundancy options. So this account type for page blob only, as the type says. So this tabular column is very important for exams. Again, at least you will have like minimum 2 to 3 questions running around relating to this type and what redundancy options available, or which type of data can use what type of storage accounts and so on. So make sure you understand well on these topics, and you know every detail of the storage types and accounts. One of the benefits of using an Azure storage account is having a unique namespace in Azure for your data. So to do this, every storage account in Azure must have a unique in Azure account name. The combination of the account name and the Azure storage service endpoints forms the endpoints for your storage account. So when naming your storage account, we should make sure we follow these rules. So storage account name must be between 3 to 24 characters in length and may contain numbers and lowercase letters only, no special characters. Your storage account name must be unique within Azure. No two storage account can have the same name. So this supports the ability to have a unique accessible namespace in Azure. So at the beginning we said like we can access to the data storage directly through the browser. So in order to achieve that, we need accessible namespace, that is a unique namespace should be created within Azure. So this is the storage service and the endpoint, like how you can access it, how the URL is done for the storage service. So for the blob storage, it's HTTPS, then storage account name .blob.core.windows.net. Then for data lake storage Gen 2, it is storage account name, then dfs.core.windows.net. For Azure files, it will be storage account name .file.core.windows.net. Then queue storage account name, then .q.core.windows.net. Then table storage is also same. So in general, if you see, it will be all HTTPS, then the storage account name, then ending with core.windows.net. So just the type here, blob, DFS, then Azure files, then we say files, then queue, then table. So this is also important. You might have questions from here, like in the question they'll be providing a storage account name, and the question will be like what will be the endpoint or URL you can use it to access the storage account, and you will have the option. So you must have the correct format. This Azure storage redundancy is the important factor in deciding the availability with lower cost. So let us see the topic on Azure redundancy here. So Azure storage always stores multiple copies of your data so that it's protected from planned and unplanned events such as transient hardware failure, network or power outages, and natural disasters. So redundancy ensures that your storage account meets its availability and durability targets even in the face of failures. So when deciding which redundancy option is best for your scenario, consider the trade-offs between lower cost and higher availability. So the factors that help determine which redundancy option you should choose include how your data is replicated in the primary region. This is one of the important factor. The next factor is whether your data is replicated to a secondary region, that is geographically distant to the primary region to protect against regional disaster. Whether your application requires read access to the replicated data in the secondary region if the primary region becomes unavailable. So these are the important factors to take note when we are deciding on the redundancy option. Okay, so the redundancy in the primary region. So data in the Azure storage account is always replicated 3 times in the primary region. So Azure storage offers 2 options for how your data is replicated in the primary region. The first is local redundant storage, LRS, and the second is ZRS, zone redundant storage. So we have a primary region, the data center. So the 2 options will be, so locally redundant storage replicates your data 3 times within a single data center in the primary region. LRS provides at least 11 nines of durability, that is 99.999, like 11 nines percentage of durability of objects over a given year. So LRS is the lowest cost redundancy option and offers the least durability compared to other options. So this 99.119 itself is going to be your least durability compared to other options. So that durable is Azure storage accounts. LRS protects your data against server rack and drive failures. So however, if a disaster such as fire and flooding occurs within a data center, all the replicas of the storage account using LRS may be lost or unrecoverable. So to mitigate this, Microsoft recommends using zone redundant storage or zero redundant storage or zero zone redundant storage. So here zone redundant storage. So in the zone redundant storage we already know. So the zone is we have multiple data centers in a single region, so it's called as a zone. So for availability, zone enabled regions, zone redundant storage replicates your Azure storage data synchronously across 3 availability zones in the primary region. So ZRS offers 12 nines, 99.129% over a given year. So with ZRS, your data is still accessible for both read and write operations even if a zone becomes unavailable. If your availability zone 1 is unavailable, like the entire data center is down with some flood or some natural disaster, like your entire data center is down, then still you can access your data, read and write through other availability zones, either zone 2 or zone 3. So no remounting of Azure files shared from the connected clients is required. If a zone becomes unavailable, Azure undertakes networking updates such as DNS repointing. These updates may affect your application if you access data before the updates have completed. So Microsoft recommends using ZRS in the primary region for scenarios that require high availability. So ZRS is also recommended for restricting replication of data within a country or region to meet data governance requirements. So here you're going to have a multiple copy of data in different data centers but within a region, so it's not going outside the country. Like it also helps with data governance requirements and also with the high availability scenarios as well. So next is redundancy in secondary region. So far we discussed this redundancy in the primary region itself. So this is the redundancy in secondary region. So for applications requiring high durability, you can choose to additionally copy the data in your storage account to a secondary region that is hundreds of miles away from the primary region. So if the data in your storage account is copied to a secondary region, then your data is durable even in the event of a catastrophic failure that prevents the data in a primary region from being recovered. When you create a storage account, you select the primary region for an account. The paired secondary region is based on Azure region pairs and can't be changed. So based on your primary region, there is a predefined paired Azure region. So based on that, the secondary region will be chosen. So Azure Storage offers 2 options for copying your data to a secondary region. So one is GRS, Geo Redundant Storage. The other one is Zero Zone Redundant Storage. So GRS is like running the LRS in 2 regions, and GZRS is like running ZRS in primary region and LRS in the secondary region. So by default, the data in the secondary region isn't available for read or write access unless there's a failover to the secondary region. So if the primary region becomes unavailable, you can choose to failover to the secondary region. After the failover has completed, the secondary region becomes primary region and you can again read and write data. So it will be like the secondary region will be like a standby region. It will not be an active, so you can access to both the regions. So only when your primary region becomes unavailable, then the secondary region becomes the primary, so then you can read and write in the secondary region. Next will be geo redundant storage, GRS. So this GRS copies your data synchronously 3 times within a single physical location in the primary region using LRS. It then copies your data synchronously to a single physical location in the secondary region using LRS. GRS offer durability of Azure storage data objects offer at least 16 nines over a given year. So this is like from the image we can explain. We have a primary region, we have a data here. So the data will have a 3 local copy, meaning it will have a copy within a single physical location in the primary region, and that will be copied over to a secondary region. So it will have totally like 6 copies of your data, 3 in the primary and 3 in the secondary region. So it has a high durability. Then Geo Zone Redundant Storage. So GZRS combines the high availability provided by redundancy across availability zones with protection from regional outages provided by geo replication. So data in the GZRS storage account is copied across 3 availability zones in the primary region similar to ZRS, and is also replicated to a secondary geographic region using LRS for protection from regional disasters. So you have your data copy here. So data copy is distributed to 3 availability zones, meaning 3 data centers. So even a data center is down, you will be still able to access the data. And there is also a copy of the data into a second region. There's a 3 copy of data into a second region as LRS. So even if all the data center is down, still you can get data from your second region. And even in the second region, if there is a network server rack failure or network to the rack has failed, then you can still access your data. So it's like a combination of zone redundant storage and LRS together in 2 different regions. So read access to data in the secondary region. So geo redundant storage replicates your data to another physical location in the secondary region to protect against regional outages. However, the data is available to be read only if the customer or Microsoft initiates a failover from primary to secondary region. As mentioned before, the secondary region will be like a standby region only. It will not be active for you to read or write the data. However, if you enable read access to a secondary region, your data is always available even when the primary region is running optimally. So for read access to the secondary region, enable read access geo redundant storage or read access geo zone redundant storage. So if you still require your secondary secondary region data to be having read access only, still you cannot have write access in both the regions. You can still have only read access. Then you should manually it should be enabled by for read to having read access. You should have either RAGRS, that is read access geo redundant storage, or RA read access geo zone redundant storage. So you should have either of this storage type. So Azure Blobs, this is a massively scalable object store for text and binary data. It also includes support for big data analytics through Data Lake Storage Gen 2. Next will be Azure Files. So managed file shares for cloud or on-premise deployments. Azure Queue, a messaging store for reliable messaging between application components. Then Azure Disk, so block level storage volumes for Azure VMs. Then Azure Tables, no SQL table option for structured non-relational data. So these are the Azure storage services. So we see benefits of Azure storage. So durable, highly available. Redundancy ensures that your data is safe if transient hardware failure occur. So you can also opt to replicate data across data centers or geographic regions for additional protection from local catastrophic or natural disasters. Data replicated in this way remains highly available if an unexpected outage occur. Next is the secure. So our data will be secure in Azure storage account as it's encrypted. It has an encryption option. So Azure Storage provides you with a fine-grained control over who has access to your data. Next is scalability. So Azure Storage is designed to be massively scalable to meet the data storage and performance needs of today's applications. Then it's managed. So Azure handles hardware maintenance, updates, and critical issues for your the data store services. So we just going to maintain the data only. Accessibility. Data in Azure storage is accessible from anywhere in the world over the internet, that's HTTP or HTTPS. Microsoft provides client libraries for Azure storage in a variety of languages including .NET, Java, Node, JS, Python, PHP, Ruby, Go, and others, as well as mature REST API. Azure Storage supports scripting in Azure PowerShell or Azure CLI, and the Azure Portal and Azure Storage Explorer offer easy visual solutions for working with your data. So these are the benefits of using Azure Storage services. So here we will see detail about Azure Blobs. So Azure Blob Storage is an object storage solution for cloud. So it can store massive amount of data such as text and binary. So Azure Blob Storage is unstructured, meaning that there are no restrictions on the kind of data it can hold. So Blob Storage can manage thousands of simultaneous uploads, massive amounts of video data, constantly growing log files, and can be reached from anywhere with an internet connection. So blobs aren't limited to common file formats. A blob could contain gigabytes of binary data streamed from scientific instrument, an encrypted message from another application, or data from custom format for any app you are developing. So in general, like Azure Blob doesn't have any restriction with the kind of data or how the data is being uploaded or what format it's being uploaded. So it doesn't have any limitations. So you can upload any data formats with any kind of data as well. So like videos, like binary data, or it's going to be very big log files, like having continuous uploading. And also if you are going to have simultaneous uploads, like from multiple sources, the data is being uploaded to the storage service simultaneously, also it can support. So the one advantage of blob storage over disk storage is that it doesn't require developers to think about or manage disk. Data is uploaded as blobs and Azure takes care of the physical storage needs, as we see in the previous slide. So all the physical related things the Azure takes care of. We just have to manage the front end only. Blob storage is ideal for serving images or documents directly to the browser, storing files for distributed access, streaming video and audio, storing data for backup and restore, disaster recovery and archiving, storing data for analysis by an on-premises or Azure hosted service. Accessing the blob storage. So objects in the blob storage can be accessed from anywhere in the world, like from HTTP and using HTTP or HTTPS. Users or client applications can access blob via URLs, the Azure Storage REST API, Azure PowerShell or CLI, or Azure Storage Client Library. The storage client libraries are available for multiple languages including .NET, Java, Node.js, Python, PHP and Ruby. So you can access from anywhere. You can access with multiple ways, like use URL, can use storage, REST API, use Azure PowerShell, Azure CLI, Azure Storage Client Library, and can use multiple available programming languages as well. So blob storage tiers. So data stored in the cloud can grow at an exponential pace. To manage costs of your expanding storage needs, it's helpful to organize your data based on attributes like frequency of access and planned retention period. Data stored in the cloud can be handled differently from based on how it's generated, processed, and accessed over its lifetime. Some data is actively accessed and modified throughout its lifetime. Some data is accessed frequently earlier in its lifetime, with access dropping drastically at the data ages. Some data remains idle in the cloud and is rarely, if ever, accessed after it's stored. To accommodate these different access needs, Azure provides several access tiers which you can use to balance your storage costs with your access needs. So even in our generally in our local storage, when we saving in our laptop and our external hard disk, not every data we access every day. Like there will be some folders which we'll be accessing every day. There will be some folders and files which we will be accessing only like particular periods, and there will be some folders and files which we will be never, very rarely or seldom we access. So just we put into the disk, just keep it there. We very seldom access. So these are the different kinds of timingly accessing to the data. So even based on this, the tier has been derived. The tier storage, blob storage tiers has been derived based on this access frequency. So we see here hot access tier, cool access tier, cold access tier, and archive access tier. So hot access tier is optimized for storing data that is accessed frequently, like very often is being accessed. So example like images on your website. Then cool access tier is optimized for data that is infrequently accessed and stored for at least 30 days. So like invoices of your customers, like once in a month accessing or such things. So storing data that is infrequently accessed and stored for at least 90 days is cold access tier. Then the last one is archive access tier. So appropriate for data that is rarely accessed and stored for at least 180 days with flexible latency requirement. It's something similar to our email archive, we say, like because email archive usually we don't access very often, but we still need it, something like that. The following considerations apply to the different access tiers. So hot and cool access tiers can be set at the account level. The cold and archive access tiers aren't available at the account level. So hot, cool, cold, and archive tiers can be set at the blob level during or after upload. So data in the cool and cold access tiers can tolerate slightly lower availability but still requires high durability, retrieval latency, and throughput characteristics like hot data. For cool and cold data, a lower availability, service level agreement SLA, and higher access costs compared to hot data are acceptable trade-offs for lower storage costs. So archive storage data offline and offers the lowest storage cost but also the highest cost to rehydrate and access the data. So it's like when you are using archive storage access, so it's going to be the lowest storage cost because we very seldom accessing it. But when you are going to access it, the cost for rehydrating and accessing the data is higher. Whereas the hot access tier, the storage cost itself is going to be higher as it should be available every time for users to access to the data. Azure File Storage offers fully managed file shares in the cloud that are accessible via industry standard server message block SMB or NFS protocols. So this you can compare very similar to our file server, Azure Files. So Azure Files file shares can be mounted concurrently by cloud or on-premises deployments. SMB Azure file shares are accessible from Windows, Linux, and Mac OS clients. NFS Azure files share are accessible from Linux or Mac OS clients. Additionally, SMB Azure file shares can be cached on Windows Server with Azure File Sync for fast access near where the data is being used. So here by we can see it's very similar to our like file server, and also you can get a similar of experience as if we are accessing to the file server by using the Azure file sync. So it will be syncing, it will create a cache to the Windows server so that you will be able to fast access the data. Azure Files key benefit. So first is shared access. So Azure File Share support the industry standard SMB and MFS protocols. You can meaning you can have a seamless replace your on-premises file share with Azure files without worrying about application compatibility. Next is fully managed. So Azure file shares can be created without the need for managed hardware or an OS, because it's a service provided by Azure, and the backend is going to be like server OS and updates, patching, and all these things is going to be managed by Azure. Scripting and tooling. So PowerShell, commandlets, and Azure CLI can be used to create, mount, and manage files, Azure file shares as part of the administration of Azure applications. You can create and manage Azure file shares using Azure Portal and Azure Storage Explorer. Resiliency. Azure File Shares has been built from ground up to always be available. So replacing on-premises file shares with Azure files means you don't have to wake up in the middle of the night to deal with low power outages or network issues. So generally, any hardware related issues or backend related issues is not. We no need to do any support on that part. Fully will be managed by Azure. So familiar programmability. So applications running in Azure can access data in the share via system IO APIs. Developers can therefore use their existing code and skills to migrate existing applications. In addition to system IO API, you can use Azure Storage Client libraries or the Azure Storage REST API. So this is all about the Azure file storage. So next service we'll be seeing is about Azure Queues. So Azure Queue Storage is a service for storing large number of messages. So once stored, you can access the message from anywhere in the world, like same as the other Azure services. So a queue can contain as many messages as storage account has room for, like potentially millions. So each individual message can be up to 64 KB in size. So queues are commonly used to create backlog of work to process asynchronously. Queue storage can be combined with compute functions like Azure functions to take an action when a message is received. For example, you want to perform an action after a customer uploads a form to your website. You could have a submit button on the website trigger a message to the queue storage. Then you could use the Azure functions to trigger an action once the message is received. So this part we have already discussed in our previous video about Azure functions. You can refer back to that video to learn more about Azure functions. So you can combine this Azure function with the Azure queue. So all messages will be stored to our Azure queue. Then based on the messages, once you have a particular message, you can use that to trigger the Azure function to do an action, like send you a notification or move the file or update the file or up the server, or some kind of actions can be connected using this Azure queue and Azure functions together. Next we'll see is Azure Disk. So Azure Disk Storage or Azure Managed Disk are block level storage volumes managed by Azure for use with Azure VMs. So conceptually they are same as the physical disk, and they are virtualized, offering greater resiliency and availability than a physical disk. With a managed disk, all you have to do is provision the disk and Azure will take care of the rest. Then Azure Tables. So Azure Table Storage stores large amount of structured data. So Azure tables are no SQL data storage that accepts authenticated calls from inside and outside from the Azure cloud. This enables you to use Azure tables to build your hybrid and multi-cloud solution that have your data always available. So Azure tables are ideal for storing structured non-relational data. So these are the Azure storage services, and each has their own specific use. So based on your requirement, you can select the Azure storage service and can use it over. Okay, here we're seeing a small comparison chart between the storage services we discussed just before. So Azure Blob storage. So this is object storage for unstructured data. So use cases is like for backup, for disaster recovery, big data analytics, and media storage. Then file storage, Azure file storage. This is managed file shares accessible via SMB and NFS protocols. So use cases are like file sharing, lift and shift applications, shared storage for applications. Then Azure queue storage. So message queuing for large workloads. So decoupling application components, task scheduling, asynchronous processing. Then Azure table storage. So this is like no SQL key value store for semi-structured data. And use cases are storing structured non-relational data, web applications, and user data. Then the last one is Azure disk storage. So persistent high performance block storage for Azure VMs. So use cases is like virtual machine storage, databases, and enterprise applications. We will start with the migrating options. So Azure supports both real-time migration of infrastructure of applications and data using Azure Migrate, as well as asynchronous migration of data using Azure Data Box. So if you need synchronously updating migrating the data, so we have an option called Azure Migrate, and if it's okay to do asynchronous migration, then we can use Azure Data Box. So first we will discuss about Azure Migrate. For Azure Migrate is a service that helps to migrate from an on-premises environment to the cloud. So Azure Migrate functions as a hub to help you manage the assessment and migration of your on-premises data center to Azure. It provides the following. So they can help you with the assessment and migrate the data. So it provides unified migration platform. So it's a single portal to start, run, track your migration to Azure. Then range of tools is it has a range of tools for assessment and migration as well. So Azure Migrate tools include Azure Migrate Discovery and Assessment and Azure Migrate Server Migration. So Azure Migrate also integrates with other Azure services and tools, and with independent software vendor offerings as well. So assessment and migration. So in the Azure Migrate Hub, you can assess and migrate your on-premises infrastructure to Azure. So in addition to working with tools from ISVs, the Azure Migrate Hub also includes the following tools to help with the migration. So Azure Migrate Discovery and Assessment, Azure Migrate Server Migration, then Data Migrate Assistant, Azure Database Migration Service, Azure App Service Migration Assistant, and Azure Data Box. Okay, so what the tools includes in the discovery and assessment is, so discovery and assessment on premises server running on VMware, Hyper-V, and physical servers in preparation for migration of Azure. So that's a discovery and assessment tool. Then for Azure Migrate Server Migration, migrate VMs, Hyper VMs, then physical servers and other virtualization servers and public cloud VMs to Azure. So it can be done in these two parts. Then Data Migrate Assistant is a standalone tool to access SQL servers. So it helps pinpoint potential problems blocking migration. It identifies unsupported features, new features that can benefit you after migration, and the right path for database migration. So because SQL is a database server, so usually we'll have trouble in migrating a database. So because we might have a lot of connections and a lot of settings over it, so features and some features may not be feasible with Azure. So all this can be pre-accessed, and any new feature that can be implemented so that to make our data run or analytics run more efficiently, can all this be assessed before the migration. So Azure Database Migration Service migrate on-premises database to Azure VMs running SQL Server, Azure SQL Database, or SQL managed instances. Then Azure App Service Migrate Assistant. So this one is a standalone tool to access on-premises websites for migration to Azure App Services. Use Migration Assistant to migrate .NET and PHP web apps to Azure. Same like the Data Migration Assistant, this App Service Migration Assistant is mostly used for on-premises website to migrate to Azure App Service. So next is Azure Database. So use Azure Database Azure Databox products to move large amounts of offline data to Azure, which is an asynchronous data transfer. So Azure Databox is a physical migration service that helps transfer large amounts of data in a quick, inexpensive, and reliable way. The secure data transfer is accelerated by shipping you a proprietary data box storage device that has a maximum usable storage capacity of 80 terabytes. So this is an important thing to remember, 80 terabytes. The data box is transported to and from the data center via regional carrier. A rugged case protects and secures the data from damage during the transit. You can order the data box device via Azure portal to import and export data from the Azure. Once the device is received, you can quickly set it up using the local web UI and connect it to your network. Once you are finished transferring the data either into or out of Azure, like either importing or exporting the data, simply return the data box. So if you are transferring the data into Azure, the data is automatically uploaded once the Microsoft receives the data box back. The entire process is tracked end to end by Databox service in the Azure portal. So we can consider this as very similar to our external hard disk. So the data box is received, then we connect the data box and import all the data to it. Once imported, then again the carrier helps to take the data box to the data center, then it's being uploaded to the cloud. So use cases. So database is ideally to transfer the data sizes larger than 40 TBs in scenarios with no limited network connectivity. The data movement can be one-time, periodic, or an initial bulk data transfer followed by periodical transfers. So now we see where is the scenarios where the data box can be used to import data to Azure. So it's a one-time migration when a large amount of data is in on-premise and you're just one time you're migrating to Azure. So moving a media library from offline tapes into Azure to create an online media library. So migrating your VM farm, SQL Server and applications to Azure. Moving historical data to Azure for in-depth analysis and reporting using HD Insight. Initial bulk transfer and periodical uploads. When large amount of data is generated periodically and needs to be moved to Azure. So when it is like more than 40 TB, so you can have a periodical uploads using the Azure data box. So next we will see the scenarios where data box can be used to export the data from Azure. So like disaster recovery, when you have a copy of data in the Azure restored to an on-premise network. So in a typical disaster recovery scenario, we will be using the export option. Then security requirements, when you need to be able to export data out of your Azure due to government or security requirements. Then migrate back to on-premises or to another cloud service provider. Once the data from your import order is uploaded to Azure, the disks on the device are wiped clean in accordance with NIST 888R1 standards. For an export order, the disks are erased once the device reaches the Azure data center. So because we are copying the data to the Azure data box, so it's your data is outside your environment. So once the task has been completed, so it's going to be wiped clean with no recovery option from that data box. So here because here for the disaster recovery scenario, usually many companies will have a setup they will have their on-premises file server or other servers, then their backup will be onto the Azure. So it will have like daily backup, periodical backup of the data to the Azure. So whenever there needs to be a recovery, like not only just disaster recovery, even when you want to move it to another location which you cannot do the physical server moving or some other purposes, then you can use this Azure data box export data from the Azure. So the data box will provide you the data, it will be brought to the on premises, then you can copy it over, then send your data box back. Very similar to holding your external hard disk everywhere. So next will be the identity options. So here, in addition to the large scale migration using the services Azure Migrate and Azure Data Box, Azure also has tools to help you move and interact with individual files and small file groups. So the Azure Migrate and Azure Data Box, we were dealing about like full set of data, like large amount of data. So if you're going to use a small file groups or small individual files, we no need to go for a big service that supports very like 40 TB of data and more. So here we have other tools like Azure Copy, Azure Storage Explorer, and Azure File Sync. So Azure Copy is a command line utility that can use to copy blobs or files to or from the storage account. With Azure Copy, you can upload files, download files, copy files between storage accounts, and even synchronize files. Azure Copy can even be configured to work with other cloud providers to help move files back and forth between the clouds. So it's like a command line interface like robocopy. Usually we use the command prompt to do the robocopy to copy the data from one location to another location. Similarly, this AZ copy is your Azure command line utility that can be used to copy the blobs and files. Then Azure Storage Explorer. So Azure Storage Explorer is a standalone app that provides a graphical interface to manage files and blobs in your Azure storage account. So it works on Windows, Mac, and Linux as well, operating systems, and uses Azure Copy on the backend to perform all the file and blob management tasks. With Storage Explorer, you can upload to Azure, download from Azure, and move between storage accounts. So it's Azure Storage Explorer is an app. Azure File Sync is a tool that lets you centralize your files, shares in Azure files, and keep the flexibility, performance, and compatibility of a Windows file server. So it's almost like turning your Windows file server into a miniature content delivery network. So once you install Azure File Sync on your local Windows server, it will automatically stay bidirectional sync with your files in the Azure. So first is Azure Copy, it's a command line utility. Then the Azure Storage Explorer is an app. Then Azure File Sync is a tool that keeps bidirectional sync with the files in the Azure. With Azure File Sync, what all the other things you can do is, so use any protocols that available on Windows Server to access your data locally, including SMB, NFS, FTPS, and all. We can use all these protocols to access the data. Then have many caches as you need across the world. Replace a failed local server by installing Azure File Sync on a new server in the same data center. So configure cloud tiering so the most frequent accessed files are replicated locally while infrequently accessed files are kept in the cloud until requested. So it helps to configure the cloud tiering. Cloud tiering is like another important topic with your exam point of view, and also with the normal as an admin of Azure admin, we need to know detail about the Azure configuring cloud tiering. So Azure Active Directories. So usually we the desktop engineers or the infra support team people, we have a very familiar term called Active Directory. So the same directory service were used in the cloud is called as Azure Active Directory. So now recently the Azure Microsoft has retermed it as Microsoft Entra ID. So you'll be seeing about Microsoft Entra in this video. So Microsoft Entra ID is a directory service that enables you to sign in and access both Microsoft cloud applications and cloud applications that you develop. Microsoft Entra ID can also help you maintain your on-premises Active Directory deployment. For on-premises environment, Active Directory running on Windows Server provides an identity and access management service that's managed by your organization. Microsoft Entra ID is a Microsoft cloud-based identity and access management service. So with Microsoft Entra ID, you control the identity control accounts, but Microsoft ensures that service is available globally. If you have worked with Active Directory, Microsoft Entra ID will be familiar. So it's similar, just it's in the cloud service. So when you secure identities on premises with Active Directory, Microsoft doesn't monitor sign-in attempts. When you connect Active Directory with Microsoft Entra ID, Microsoft can help protect you by detecting suspicious sign-in attempts at no extra cost. For example, Microsoft Entra ID can detect sign-in attempts from unexpected location or unknown devices. So we can have conditions like this. So if it's from an unknown, if it's a suspicious sign-in attempt, then it will help to detect that. So what Microsoft Entra ID is used for? So for usually the IT administrators will be using it. So IT administrators will be using it to control access to applications and resources based on their business requirement. Then for app developers, so developers can use Microsoft Entra ID to provide a standard-based approach for adding functionality to applications that they build, such as adding SSO like single sign-on functionality to an app, or enabling an app to work with users' existing credentials. Then for normal users can manage their identities and take maintenance actions like self-service, password reset. So online service subscribers, for my M365 Office, Azure and Microsoft Dynamics CRM online subscribers are already using the Microsoft Entra ID to authenticate into their account. So it has a very drastical wide range of users are using this Microsoft Entra ID. So Microsoft Entra ID provides services such as authentication, SSO, then application management and device management. So we will see each of them. So this includes verifying identity to applications and resources. It also includes providing functionality such as self-service, password reset, multi-factor authentication, we call it MFA, a custom list of banned passwords. So custom list of banned passwords meaning like when you set up a list of banned passwords, so the user will not be able to use it. So like very simple passwords like 123 password, all this kind of simple passwords, we can restrict the users from using those kind of easy passwords. And smart lockout services. Single sign-on enables you to remember only one username and one password to access multiple applications. A single identity is tied to a user, which simplifies the security model. As users change role or leave an organization, access modifications are tied to that identity, which greatly reduces the effort needed to change or disable the accounts. So application management. You can manage your cloud and on-premises apps by using the Entra ID. So features like application proxy, SaaS applications and My Apps portal and single sign-on provide a better user experience. Then device management. So along with accounts for individual people, Microsoft Entra ID supports the registration of devices as well. So registration enables devices to be managed through tools like Microsoft Intune. So when you want to use Microsoft Intune, so that will be tied to your Microsoft Entra ID. This is the directory we will be using in the Microsoft Intune as well. So it also allows for device based conditional access policies to restrict access attempts to only those coming from known devices, regardless of the requesting user account. Even though known user is requesting for an access, but it's from an unknown device, the access can be restricted using a conditional access policy that's made possible by using Microsoft Entra ID. Next, connecting the on-premise AD with Microsoft Entra ID. So if you had an on-premises environment running Active Directory and cloud deployment used Microsoft Entra ID, you would need to maintain two identity sets, like for on-premises one and for the cloud one. So you can connect Active Directory with Microsoft Entra ID, so enabling a consistent identity experience between cloud and on-premises. So one method of connecting the Microsoft Entra ID with your on-premises AD is using a Microsoft Entra Connect. So Microsoft Entra Connect synchronizes user identities between on-premises Active Directory and Microsoft Entra ID. So Microsoft Entra ID synchronizes changes between both identity systems. So you can use features like SSO, MFA and self-service password reset under both systems. So Microsoft Entra Domain Services. Microsoft Entra Domain Services is a service that provides managed domain services such as domain joining, group policies, then LDAP and Kerberos NTLM authentication. So all these topics will be very familiar for whoever been worked with AD before. So normal our on-prem AD, we will be creating we'll be joining the laptops, desktops to the domain, then we create the group policies, then we have this directory access protocol, then Kerberos, all these things the same we can use on the cloud by using this service called Microsoft Entra Domain Service. So just like Microsoft Entra ID lets you use directory services without having to maintain the infrastructure supporting it. With Microsoft Entra Domain Services, you get the benefit of domain services without need to deploy, manage and patch domain controllers in the cloud, because all these options, all this services we get in the on-premises from the domain controller. So have a domain controller, we need to maintain the server, patch, and we have to do all the physical device maintenance. So when it comes from the cloud as a service, we no need to do all the physical maintenance. So the physical maintenance is all managed by the Azure. So we just we will be just utilizing the service. So Microsoft Entra Domain Services Managed Domain lets you run a legacy applications in the cloud that can't be modern authentication methods, or where you don't want Active Directory lookups to always go back to an on-premises ADDS environment. So Microsoft Entra Domain Service not only allows you to use the applications that suppose the SSO kind of modern authentication, it also lets you use legacy applications as well. So you can lift and shift those legacy applications from your on-premises environment into managed domain without needing to manage the ADDS environment in the cloud. So Microsoft Entra Domain Services integrates with your existing Microsoft Entra tenant. This integration lets users sign into services and applications connected to the managed domain using their existing credentials. So that's very important. We already been using a credential, so it will help you to integrate with the existing credentials. There will be no separate credentials created for this. You can also use existing groups and user accounts to secure access to the resources. These features provide a smooth lift and shift of the on-premises resources to the Azure. So we can use the existing credential, we can use the existing groups and user accounts for the resources, which will give a similar experience from the user's point of view. When you create a Microsoft Entra Domain Services managed domain, you define a unique namespace. This namespace is the domain name. So 2 Windows Server domain controllers are then deployed into your selected Azure region. This deployment of DCs is known as replica set. So you don't need to manage, configure and update these DCs. The Azure platform handles the DCs as a part of the managed domain, including backups and encryption at rest using Azure Disk Encryption. Okay, a managed domain is configured to perform a one-way synchronization from Microsoft Entra ID to Microsoft Entra Domain Services. So you can create a resource directly in the managed domain, but they aren't synchronized back to the Microsoft Entra ID. In a hybrid environment, when an on-premises ADDS environment, Microsoft Entra Connect synchronizes identity information with the Microsoft Entra ID, which is then synchronized to the managed domain. Applications, services, and VMs in Azure that connect to the managed domain can then use common Microsoft Entra Domain Services features such as domain join, group policy LDAP, and Kerberos NTLM authentication. So it's like you have your Azure AD tenant. So Azure AD tenant with on-premises Microsoft is going to be two-way sync. So Azure AD connects the synchronization to the on-premises one. But when you go for this managed domain services, it will be a background. It's going to be a one-way sync. Like is Azure AD tenant is going to sync to your managed domain. So that's why he say you can create the resources directly in the managed domain, but they aren't synced back to the Entra ID. So it's the reverse syncing is not happening. It's a one-way synchronization from Microsoft Entra ID to the Microsoft Entra Domain Services. Start with authentication. Authentication is the process of establishing the identity of a person, service, or device. So it requires the person, service, or device to provide some type of credential to prove who they are. So authentication is like presenting ID when you are traveling. So it doesn't confirm that you are ticketed, it just proves that you are who you say you are. Azure supports multiple authentication methods including standard password, single sign-on, multi-factor authentication, and passwordless. For the longest time, security and convenience seem to be at odds with each other. So new authentication solution provide both security and convenience. So notice passwordless authentication is high security and high convenience, while passwords on their own are low security but high convenience. So here in the diagram we can see the chart between conveniency and security. So initially we all be using passwords which is low security but on the convenient side. Then we had password plus two-factor authentication. So that's inconvenient but with the high factor side. So we have this new technology, passwordless authenticating. So that's high security and also on the convenient side. So single sign-on enables a user to sign in one time and use that credential to access multiple resources and applications from different providers. For SSO to work, the different application and providers must trust the initial authenticator. So most identities mean more passwords to remember and change. Password policies can vary among applications. As complexity requirements increase, it becomes increasingly difficult for users to remember them. The more passwords a user has to manage, the greater the risk of credential related security incident. Consider the process of managing all those identities. More strain is placed on the help desk as they deal with account lockouts and password reset requests. If a user leaves an organization, tracking down all those identities and ensuring they are disabled can be challenging. If an identity is overlooked, this might allow access when it should have been eliminated. With SSO, you remember only one ID and one password. Access across applications granted to single identity that's tied to the user, which simplifies the security model. As users change roles or leave organization, access is tied to single identity. This change greatly reduces the effort needed to change or disable the accounts. Using SSO for accounts make it easier for users to manage their identity and IT to manage users. So when using SSO, normally you would have experience when you're logging into some kind of some site or online application in the browser with your username password, and you're going to access another application or another portal, it will auto login to that application which is based on the previous logged in. So this, it means the site is supported with SSO. Say example, you have been set up SSO with your Windows ID, which is if it is in domain, it's going to be the Active Directories authentication. So if that is tied to your application and your application trusts this username and password, then the Windows ID can be used to log into the application. So you do not maintain a separate username password for the application. So by having this, we can easily log into the applications without no need to keep multiple username passwords, because when starting to have multiple username passwords, the security on the passwords is going to reduce, because we cannot have complexity of passwords for every site. And as the last point says, like when there is a change of user, like if user leaving the organization, we need to delete the IDs. It's easy if you have lesser number of accounts, so easy to we don't miss out any ID. And also when the user changing to another department or another branch of the company, then it's just tied to your ID, so it's easy to manage as well. Next is multi-factor authentication. So we say MFA. Multi-factor authentication is the process of prompting a user for an extra form or factor of identification during the sign-in process. So MFA helps the protect against the password compromise in situations where password was compromised but the second factor wasn't. So after entering your username password, have you ever needed to enter a code that was sent to your phone? Yes, then that's a multi-factor authentication. So normally when you are signing into your Gmail, you can set up multi-factor authentication there. When you're signing into your Outlook, or when you're signing into your Microsoft accounts, you can set up multi-factor authentication using a Microsoft Authenticator app. So when you try to sign in, your authenticator will give you a code to key in. Then that code, once keyed in, then you will be able to log in. So in this part, even if your password is compromised, still you will be using your authenticator app, which is not compromised. Then other people cannot use your account to log in with just the password. Multi-factor authentication provides additional security for your identities by requiring two or more elements to fully authenticate. These elements falls into three categories. So something the user knows, that might be a question. Something the user has, that might be a code that's sent to user's phone. So something the user is, this typically some sort of biometric property such as fingerprint or face scan, etc. So multi-factor authentication increases identity security by limiting the impact of credential exposure. With MFA enabled, an attacker who has the user's password would also need to have possession of their phone or their fingerprint to fully authenticate, which makes it tough for the other person to hack it. Compare multi-factor authentication with single-factor authentication. Under single-factor authentication, an attacker would need only the username and password to authenticate. Multi-factor authentication should be enabled wherever possible because it adds enormous benefits to security. So next is Microsoft Entra Multi-Factor Authentication. So Microsoft Entra Multi-Factor Authentication is a Microsoft service that provides multi-factor authentication capabilities. So this Microsoft Entra Multi-Factor Authentication enables users to choose an additional form of authentication during the sign-in, such as phone call or mobile app notification. Passwordless authentication, the modern authentication method. Features like MFA are a great way to secure your organization, but users often get frustrated with the additional security layer on top of having to remember their passwords. So people are more likely to comply when it's easy and convenient to do so. Passwordless authentication methods are more convenient because the password is removed and replaced with something you have plus something you are or something you know, which is very close, because password, maybe the password can be easily compromised because it's just we are creating something out of our owningness. But the passwordless authentication is mostly based on what we have or what we are or with something we know. So passwordless authentication needs to be set up on a device before it can work. For example, your computer is something you have. So once it's being registered or enrolled, Azure now knows that it's associated with you. Now that computer is known, once you provide something, you are like a pin, fingerprint, like Face ID or your voice recognition, something like that. So each organization has different needs when it comes to authentication. Microsoft Global, Azure and Azure Government offer the following 3 passwordless authentication options that integrate with Microsoft Entra ID: Windows Hello for Business, Microsoft Authenticator app, and FIDO2 security keys. So the Windows Hello for Business. So Windows Hello for Business is ideal for information workers that have their own designated Windows PC. So the biometric and PIN credentials are directly tied to the user's PC, which prevents access from anyone other than the owner. With public key infrastructure (PKI) integration and built-in support for SSO, Windows Hello for Business provides a convenient method for seamlessly accessing corporate resources on premises and in the cloud also. So next is the Authenticator app. So you can also allow your employee's phone to become the passwordless authentication method. You may already be using the Microsoft Authenticator app as a convenient multi-factor authentication option in addition to password. You can also use the Authenticator app as a passwordless option. The Authenticator app turns any iOS or Android phone into a strong passwordless credential. Users can sign into any platform or browser by getting a notification to their phone matching the number displayed on the screen to the one on their phone, and then using their biometric or PIN to confirm. Then FIDO security keys. So fast identity online, that's FIDO. Alliance helps to promote open authentication standards and reduce the use of passwords as a form of authentication. So FIDO 2 is the latest standard and that incorporates the web authentication standard. FIDO 2 security keys are an unphishable standards based passwordless authentication method and can come in any form factor. Fast identity online, that's FIDO, is an open standard for passwordless authentication. So FIDO allows users and organizations to leverage the standard to sign into their resources without username or password by using external security key or a platform built into a device. So users can register and then select FIDO 2 security key at the sign-in interface at their main means of authentication. These FIDO 2 security keys are typically USB devices but could also be Bluetooth or NFC. With a hardware device that handles the authentication, the security of an account is increased as there's no password that could be exposed to or guessed. That's very important thing, like even some users password just can guess and log into. So all these kinds can be avoided when we are going for this passwordless authentication. Let's move on to the video. So here first we need to activate the sandbox account. So I have done it already. So in my previous videos of exercises also I have shown the activations, so I will just skip the step here. So we will go with the account creation step straight away. So we have to log in to the Azure portal account. So once you are able to log in, since it's sandboxing, we will have it's like a learning account, so we no need any subscriptions. In normal cases we will need subscription to create the account. So we are creating a storage account. So hope you have followed the create the resource, then under the category go to storage, then under storage account create. So here we will leave the subscription and resource group default. Storage account name, we name it as Techify with Adil Blob. Okay, hopefully this name is then the region we leave it default, and performance as standard, and redundancy we go for LRS. So also about redundancy we have discussed in my previous video. I will just tag the video on the top, you can view that. Then next, under advanced we just need to enable this, allowing enabling anonymous access to individual containers. So then we just review and create. So it just validating the settings we have provided, and yes, it's been validated already. So we're going to create the storage account. So the storage account is under creation now. It's going to take just quite some little time to complete. So once it's completed, we can go to the data storage and select the container to see. So deployment is in progress. So blob storage, as we have discussed in the previous video, so it's used for very large size of data and unstructured data to store, like logs, like videos, pictures and everything we can just store to this blob storage. So we have already completed. We go to the resources. So here's our storage account. So in general, like you can just go and you can see here the resources. Under resources you can see the resource. You can see the details all here. So now we go to here we will go to our storage account. Then we need to create a container. Actually we can go to click upload, then last to choose the container which we haven't created. So we use this create new option, then TWA blob container 1, it's private. So we are creating a container. So once we have created the container, we need to select the container we created and upload some files for. So here we have created the container. So we will be selecting a file to upload. So I just use my channel logo, has been and uploading it. So we have uploaded. So here we can so here now we just expand this. Okay, we will see storage browser here, blob container, and we go to our container, and under the container, so this is the file we uploaded. So here we can see you got an URL. So we just paste the URL in. So in our previous video discussing about the storage accounts, we have already mentioned, so the storage account, the backend is all managed by the Azure, and storage account can be directly accessed from the browser, HTTP or HTTPS. So we are trying to access to the file that we have uploaded. So we have an issue in accessing to the uploaded file. So now let us see what's the issue is and resolve that first. So here we go back to our container, blob containers, then we just choose our container. We see here change access, so it was the default one which while we created. So here we are giving containers and blobs for anonymous access. So now again we go back to the container. So we can see the file. So we are accessing to the file we have stored in the blob storage in Azure. So this is how we can create an blob storage account and access to the storage data in the account. So similarly, as we have done for blob storage, we can also create other storage accounts. Say, so the same steps, we just go create resource under storage. So here we can just create any other accounts we need, then we can do the same steps to access to the account as well. So an external identity is a person, a device or service, etc., that is outside your organization. So Microsoft Entra external ID refers to all the ways you can securely interact with users outside your organization. Want to collaborate with partners, distributors, suppliers or vendors, you can share your resources and define how your internal users can access external organizations. So if developer creating consumer facing apps, you can manage your customers' identity experiences. So external identities may sound similar to single sign-on. So with external identity, external users can bring their own identities. So whether they have a corporate or government issued digital identity or an unmanaged social identity like Google or Facebook, they can use their own credentials to sign in. So the external user's identity provider manages their identity and you manage access to your apps with Microsoft Entra ID or Azure AD B2C, so business to customer, to keep your resources protected. So in general, like when we are having a collaboration with an external organization or external person, then they obviously will not be having any ID in our organization, like digital ID or any account in our organization. So the one existing way is like we have to create an account for that user, give access. But creating an account for an external person who is not related to our, who is not in our organization is a security issue. So we still leave the user to have their own ID, which is being managed by their own organization with the security terms, and they are allowed to access the groups or the resources that is only required for them. So maybe they are a developer, or maybe they are a user who want to test something, so they can use their own identity to access to that particular resources to use. So in general, this is about the external identities. So here you can see it's a business to business collaboration. Like this is our Azure tenant. So we have our Azure AD, so which will contain all our organization peoples here. So we are For the self sign-in, we are having our partners or vendors. So they may have Facebook ID, they may have their own tenant or their cloud, other cloud, or they may have the Google account. So we are letting them sign in to our resources using the self sign-in sign up by B2B collaboration. The other one is B2C, business to customer collaboration. So we have our Azure AD B2C tenant. So here we have consumers of our publishing app or whatever the system we are publishing out. So the consumers will be using their services. So example, we would have seen a lot of applications and sites that will be asking you to sign up, or it will give you option, can use Google, can use Facebook ID, or can use Apple ID to sign up. So same app is allowing you can use your Gmail to log in, you can use your Facebook ID to log in, and you can use your Apple ID to log in. So it's like business to customer. For the customer, the business which we are signing into is allowing the customers to use their own self sign in to use the application or website. So that's the business to customer model. So here, business to business collaborations, like external users, by letting them use their preferred identity to sign into your Microsoft application or other enterprises applications like SaaS, custom developed apps, etc. So B2B collaboration users are represented in your directory typically as guest users. So usually we will invite them, we'll send an invite to the users for them to accept and start using the resources. So they will be termed as a guest users in our directory. Establish a mutual two-way trust with another Microsoft Entra organization for seamless collaboration. So B2B Direct Connect currently supports Teams shared channels, enabling external users to access your resources from within their home instances of Teams. So usually it become very common to use Teams channel nowadays for the project related things and all. So we can have a two-way trusted relationship with other organizations, so whose we are working together. Then we can add all them together in the Teams channel, so everybody can have a connection, so we can save files there, so chat, and we can have a resources shared. So B2B Direct Connect users aren't represented in your directory, but they are visible from within the Teams shared channel and can be monitored in Teams admin center reports. So next is B2C. So publish modern SaaS app or custom developed apps to consumers or customers while using Azure AD B2C for identity and access management. So here, so we can see the difference between B2B and B2C. So B2C is, as I mentioned, it's going to be some application or some sites, whatever we are providing to the customers or the consumers who will be accessing it, but they will be using their own sign-in for identity and access management. So B2B collaboration is like a two-way trust with another organization. So depending on how you want to interact with external organization and type of resources you need to share, you can use a combination of these capabilities. So with Microsoft Entra ID, you can easily enable collaboration across organizational boundaries by using the B2B feature. So guest users from other tenants can be invited by administrators or by other users. So this capability also applies to social identities such as Microsoft accounts. You also can easily ensure that guest users have appropriate access. So you can ask the guests themselves or a decision maker to participate in an access review and rectify to the guest access. So the reviewers can give their input on each user's need for continued access based on suggestions from Microsoft Entra ID. When access review is finished, you can then make changes and remove access for guests who no longer need it. So conditional access is a tool that Microsoft Entra ID uses to allow access or deny to resources based on the identity signals. The signals include who the user is, where the user is and what device the user is requesting access from. So conditional access helps the IT administrators to empower users to be productive wherever and whenever, protect the organization's assets. So conditional access also provides a more granular multi-factor authentication experience for users. For example, a user might not be challenged for second authentication factor if they are at known location. So they might be challenged for second authentication factor if the sign-in signals are unusual and they are at unexpected location. During sign-in, conditional access collects signals from user, makes decision based on those signals, and then enforces that decision by allowing or denying the access request or challenging for a multi-factor authentication. The signal might be the user's location, the user's device, or the application that the user is trying to access. Based on these signals, the decision might be to allow full access if the user is signing in from their usual location. If the user is signing in from an unusual location or a location that's marked at high risk, then the access might be blocked entirely or possibly granted after the user provides a second form of authentication. Enforcement is the action that carries out the decision. For example, the allow action is to allow access or require the user to provide a second form of authentication. So in brief, based on the user's location, say example if they are in office location, that we can consider as a known location. So if we are accessing to the resources from the known location, then the conditional access will not be asking for multi-factor authentication like the second challenge. So it will just the users can log in and start using it. And when the user are accessing from a unknown location or new location or marked as high risk kind of locations, then based on the conditions we have applied, either it will be rejected or it will be challenging the user to have multi-factor authentication. So user have to do an additional authentication to make sure he's the user. This is not only just based on the location, also based on the device. Usually in our companies will not have a direct access to the internet, like open internet access will not be allowed for the security reasons, but due to some kind of application testing or some kind of scenarios, there might be exception cases. So it depends on companies organizations policies. So some organizations will have a separate notebook that will have open access to the internet, so that will not be used to access to the company resources. So those kind of devices, if users not using the right device to access to the resources, then that can be rejected. So all these kind of conditions can be applied through Azure conditional access tool, makes the organizations asset more protective, and also for IT administrators it's more easy to manage all this access. So when we will need the conditional access tool, so require multi-factor authentication to access an application depending on users request or role, location or network. So in this case, for having an additional challenge, we will use the conditional access. Then require access to services only through approved client applications. Example, you could limit which email applicants are able to connect to your email service. Require users to access your application only from managed devices, the one what I explained just now. So managed devices is a way that meets your standards of security and compliance. Block access from untrusted sources, such as access from unknown or unexpected locations. So based on location or based on the who the applications is, or based on the device or based on the locations, we can apply the conditional access. So next we will be seeing the RBAC. So it's a role based access control. So instead of giving each person's permissions, so we can assign a role to that person, and that role will have a predefined permissions. Also in Azure we can create our own customized role and give the permissions to that role. So whoever being added to that role will have those permissions. When you have a multiple IT and engineering team, how can you control what access they have to the resources in your cloud environment? The principle of least privilege says you should only grant access up to the level needed to complete a task. So if you only need read access to a storage blob, then you should only be granted read access to the storage blob. Write access to the blob shouldn't be granted, nor read access to the other blob storages. It's a good security practice to follow. However, managing the level of permission for entire team would become tedious. Instead of defining the detailed access requirements for each individual and then updating the access requirements when new resources are created or new people join the team, Azure enables you to control access through Azure role-based access control. So Azure provides built-in roles that describe common access rules for cloud resources. You can also define your own rules. So each role has an associated set of access permissions that relate to the role. When you assign individuals or groups to one or more roles, they receive all the associated access permissions. So if you hire a new engineer and add them to Azure RBAC group of engineers, they automatically get the same access as the other engineers in the same Azure RBAC group. Similarly, if you add additional resources and point Azure RBAC at them, everyone in the Azure RBAC group will now have those permission on the new resources as well as the existing resources. So just not only individual person we will be adding to the access group, so we can just have a group that contains many users. Say example, you have a desktop team like 10 members, so all 10 members are added to a group called desktop engineers. So if you want to give them access to blob storage, then you can just add the entire group to the accessing the blob storage, creating a read access to the blob storage. So the entire team under the group will be able to access to the blob storage. Just you want to remove them, you no need to do individual removing, just remove the group from that permission. So it's very easy to handle, and also it's very easy to revoke the permission when the user is out of the organization, or the user is changing the team so that you want to revoke his permission. No need to go individually remove or check on what kind of access he has. Just we can go to the user, we can see what is the group added. If it is, just do a review, and whatever group is not to be under him, so just we can remove the group, so the permission will be revoked. So here the following diagram shows you the relationship between roles and scope. So a management group, subscription and resource group might be given the role of owner. So they have the increased control and authority. An observer who isn't expected to make any updates might be given a role of reader of the same scope, enabling them to review or observe the management group, subscription or resource group. So this is the scope, like management group, subscription, resource group and resources. So all Azure virtual machines account, everything comes under the resources. So here you see whoever wants to just observe, meaning just need to have permission to look at but not write anything there, or don't have or shouldn't have permission to do any changes, then we give them observer, that's a reader permission. So resource specific, custom, and then contributor. So users managing resources. So contributor is usually will have the right permission. Then if you need any customizing permission, like he should be able to write only to this resources, or he should be able to write but not delete it, all those kind of customized permissions, or resource specifically only this resource he should be able to access, all these kinds we can will be able to assign. Then owner will be the admins will be the owner of the management group, subscription and also the resources. So for based on the resource group or the permissions whatever been given, so it is an automated resource for our permissions for the resources. So for RBAC access control applied to resources, role based control is applied to a scope, which is a resource or set of resources that is access applies to. So that's why here we have the process automated, because when you apply a set of rules to the resource or to a set of resources, then it applies to the access as well. So scope include management group, single subscription, a resource group, or single resources. So observers usually manage the resources. Admins and automated processes illustrate the kind of users or account that would typically be assigned each of the various roles. So Azure ABAC is hierarchical also, in that when you grant access at a particular parent scope, those permissions are inherited to the child scopes. So when you assign a owner role to a user at the management group, so we have a user having assigning a owner role to the management group, so that the user can manage everything in all subscriptions within that management group, because you're making him the owner of this management group. So the subscription comes under this management group, the resource group comes under this subscription, so they will be able to manage all the subscriptions under this management group. So it's a hierarchical, so top level, and this will be the bottom level. So when you assign a reader role to a group of all subscription scope, the members of that group can view every resource group within that subscription. So it will follow the hierarchical. So any permission or role assigned to parent group, its child scope will have the permission inherited. So that's one of the important thing to take note of, because the subscriptions, or say example, if you are giving a permission to a subscription and the resources group is under that, so what are the resource group under that also should be taken note of, because when you give permission to a subscription, then the resource group follows the same permission. So Azure ABAC is enforced. So Azure role-based access control is enforced on any action that's initiated against an Azure resource that passes through Azure Resource Manager. So Resource Manager is a management service that provides a way to organize and secure your cloud resources. So you typically access Resource Manager from the Azure portal or Cloud Shell or PowerShell and command line interface. So Azure role-based access control doesn't enforce access permission at application or data level. So application security must be handled by your application. So application role-based access control uses an allow model. So when you are assigned a role, Azure ABAC allows you to perform actions within the scope of that role. So if one assignment grants you read permission to a resource group, and a different role assigns a grant you write permission to the same group, you have both read and write permission on the resource group. So it will not be like clashing. So you have from one group you're been assigned a permission, and the another group gives another permission, it will just combine, club the permissions together, so you will have both the permissions assigned. Defense security system, zero trust model, and defense in depth. So both the models are working expected to have a good defense system, and we will see how the both works and how it's been designed. So the zero trust security model assumes the worst case scenario and protects resources with the expectation. So zero trust assumes breach at the outset and then verifies each request as though it is originated from an uncontrolled network. So from the name says zero trust model, so it is always expecting a worst case scenario, like if it's what if it's from an uncontrolled network, or what if it's from an unaccessed or an high risk zone. So it will considering this as a scenarios, and the zero trust model has been built over that. So today organization need a new security model that effectively adapts to the complexity of the modern environment, embraces the mobile workforce, and protects people, devices, applications, and data wherever they are located. So to address this new world of computing, Microsoft highly recommends the zero trust security model, which is based on these guiding principles. So verify explicitly, always authenticate, and authorize based on all the available data points. This is the first guideline. The second is use least privilege access. So if you are going to if a person needs a particular access to maybe to read a blob, so like if you are giving a owner permission to the blob, also he can read. If you are giving a write permission, also he can read. If you are going to give a contributor or admin permissions, also he can read. But we must give them a least privilege access, so that he will be having a least privilege access, plus he will be able to do the task. So limit user access with just in time and just enough access. So just in time access and also just enough access. So this is the term of use least privilege access. So next is assume breach. So minimize blast radius and segment access. So verify end-to-end encryption. Use analytics to get visibility, drive threat detection, and improve defenses. So we will be assuming there's a breach in the network. So have to do the analytics to have more visibility. So we should have run things to find there's a threat detections and improve the defenses based on the analytics and the threat defense detection reports. Then adjusting to zero trust. So traditionally corporate networks were restricted, protected, and generally assumed safe. So only managed computers could join the network, VPN access was tightly controlled, and also the personal devices were frequently restricted or blocked. So zero trust model flips the scenario. So instead of assuming that the device is safe because it's within the corporate network, it requires everyone to authenticate, then grants access based on authentication rather than the location. So just believing since it's a managed device, or since it's the device is connected to the office network, just imagining or just believing that this device is safer rather than doing that under the zero trust model. So even if it's located inside your network, even if it's a managed device, still it has to be authenticated, still it has to go through all the authentication processes, because that's how we can increase this security by this zero trust model. So here you can see, so the classic approach. So we just give a restriction to everything, like we have it. If it's like our office, then we have our database files and our computers, everything locked in it. So secure network, we are securing the network and believe that whatever inside our secure networks is all safer to use. But the other way, in the zero trust, protects access anywhere with the central policy. So it can be a computer in our network or outside the secure network, or data inside or outside, whatever the scenario is, still you will have to go all through security checks to make sure the individual devices or individual data center servers or access is protected. The second model will be the defense in depth, the other model. So the objective of defense in depth is to protect information and prevent it from being stolen by those who aren't authorized to access it. A defense in depth strategy uses a series of mechanisms to slow the advance of an attack that aims to acquiring unauthorized access of data. So layer of defense in depth. So defense in depth works in the model of layer of defenses. So you can visualize the defense in depth as set of layers with the data to be secured at the center, and all the other layers function to protect the central data layer. Each layer provides protection so that if one layer is breached, a subsequent layer is already in place to prevent the further exposure. So this approach removes reliance on any single layer of protection. It slows down an attack and provides alert information that the security team can act upon either automatically or manually. So you can see the picture here. So data is here. So if for a person, like for a hacker or the person who's breaching, you want access to data, he has to go through all these steps. He has to cross the physical layer, physical security, maybe a security person or agent, someone. Then he has to clear his identity and access, then he has to clear the perimeter, then he has to interfere into the network, then into the computing layer, then in access to the application. Only then he will be able to access the data. Once he is breaching any of this layer, then there will be an alarm already. So before he is able to breach all the other data, maybe the security team can take action on that. So the brief overview of the role in each layer. So physical layer is the first line of defense of protecting computing hardware in the data center. So the identity and access layer controls the access to the infrastructure and change control. So perimeter layer uses distributed denial of service, DDoS attack. So protection to filter large scale attacks before they can cause a denial of service for users. So the network layer limits communication between resources through segment and access control. Then the compute layer secures access to virtual machines, computing. An application layer helps ensure the applications are secure and free for security vulnerabilities. The data layer controls the access to business and customer data that you need to protect. These layers provide a guideline for you to help make security configurations decisions in all of your layers of the application. So in detail we'll be seeing about each layer here. So for the physical security layer, physical securing access to the building and controlling the access to the computing and the perimeter of the first line of defense. Then physical security, the intent is to provide physical safeguard against access to the assets. So these safeguards ensure that other layers can't be bypassed and loss or theft is handled appropriately. Microsoft uses various physical security mechanisms in their cloud centers. Then identity access layer is all about the ensuring that identities are secure, that access is granted only to what's needed, and the sign-in events and changes are logged. So at this layer, it's important to control access to infrastructure and change control, use single sign-on or multi-factor authentication, then audit events and changes. So even if a person who has access is accessing to some data, is making some changes, and everything should be logged and that has to be audited and checked. So perimeter, the network perimeter protects from network based attacks against your resources. So identifying these attacks, eliminating their impact and alerting you when they happen are important ways to keep your network secure. At this layer, the important to DDoS protection to filter large scale attacks, then perimeter firewall to identify and alert on malicious attacks against your network. Then network layer. At this layer, the focus is on limiting the network connectivity across all your resources to allow what's only required. By limiting the communication, you reduce the risk of an attack spreading to other systems in your network. So at this layer, the important is to limit communication between resources. Unwanted communication should be cut off. Deny by default. So by default, everything will be denied. Only you will create rules or permissions for required connections only. So that by that you will be very sure about what you have allowed. Then restrict inbound internet access and limit outbound access where appropriate. Only inbound connections, restrict the inbound connections from internet access. So anything from the internet to inside to our system should be restricted. And limit the outbound access where appropriate. Like we shouldn't open the outbound as well. It also has to be limited for only required connections. Then implement secure connectivity to on-premise network. The compute, malware, unpatched systems and improperly secured systems open your environment for attack. The focus in this layer is on making sure that your compute resources, say virtual machines, are secure and that you have the proper control in place to minimize security issues. At this layer, it's important to secure access to the virtual machine, implement endpoint protection on devices and keep the systems patched and current. Because if you're having a machine and you have control of all the other things, but the machine is unpatched, has a lot of malware or bugs in it, then it becomes vulnerable for the attack very easily. Then the application. So integrating security into the application development lifecycle helps reduce the number of vulnerabilities introduced in code. So every development team should ensure that its application are secure by default. At this layer, it's important to ensure all the application are secure and free for vulnerabilities. Store sensitive application secrets in a secure storage medium. Make security a design requirement for all application development. Then lastly, data. So those who store and control access to data are responsible for ensuring it's properly secured. Often regulatory requirements dictate the controls and processes that must be in place to ensure the confidentiality, integrity, availability of the data. So in almost all cases, the attackers are after data, obviously. So stored in the database, stored in disk inside the virtual machine, and SaaS applications or like M365 applications, then managed through cloud storage. So usually the attackers look for the data in all these locations. So it will be secured as in the difference in the different layer ways, the difference in depth model. The other model we see is zero trust. We assume there's a breach and work towards safeguarding the breach. So the factors that affects the cost in Azure. So Azure shifts development costs from capital expense of building out and maintaining infrastructure and facilities to an operational expense of renting infrastructure as you need it, whether it's compute, storage, networking, and so on. So earlier, when in our discussion in previous video, we have seen about this capex and opex. What is the advantage of going into Azure? So it has converted the capital expense to operational expense. So based on your operation, your expense is going to be we no need to be spend expense on capital like building, maintenance, infrastructure, and all those things. So that OPEX costs can be impacted by many factors. Some of the factors are like resource type, what type of resource we are using, consumption of that resources, maintenance, geography, subscription type, Azure marketplace. So these are the main factors that impacts our operation expense. So the resource type. So number of factors influence the cost of Azure resources. The type of resources, setting of the resources, and Azure region will all have the impact on how much a resource costs. So in my previous video, who have viewed, if not, like you can go check again, creating a resource. We have a lab session. So in that video, we have seen how to create a Azure resource. While creating, there's an option to choose Azure region. So when you're choosing Azure region, based on the region you choose, also there will be a change in cost, and also the settings for the resource. Like for example, the redundancy you choose, like you're using a GRS redundancy or LRS. So based on that, your cost also will vary. So that's what the second point is. Then when you provision an Azure resource, Azure creates metered instances for that resource. The meter tracks the resources usage and generate a usage record that is used to calculate your bill. Same like how we pay our electricity bill, and if it's being utilized, then you will be charged. Not utilized, then you will not be charged. That's the advantage of using Azure. So you see a small video on the cost effect.
How much does Azure cost? The answer to this common question depends on many factors, such as services used, workloads, networking needs, and storage requirements. Azure provides several tools to help you understand your costs and savings when moving to the cloud. First, the Total Cost of Ownership, or TCO, calculator helps you understand the cost savings of operating your solution on Azure compared to your on-premises data center. Define your workloads by specifying your current on-premises infrastructure based on servers, databases, storage, and networking. Then you can make adjustments to costs based on your location and organization. Finally, you can view a report that shows your costs and savings over time. The second useful tool is the pricing calculator, which can help you determine which Azure services best fit your budget. As you select your subscriptions, services, resources, and third-party solutions, you can add up your costs. You can make adjustments for regions, billing options, dev test pricing, and support options. This can give you a good estimate of the costs of your plans. To monitor your actual costs, you can use the Azure Advisor. It can make recommendations around unused resources and ways to optimize your services. You can also set spending limits on your costs to prevent accidental cost overruns. By using these tools, you can monitor your costs while tracking your overall long-term savings of moving to the cloud. How much?
Okay, so with a storage account, you specify a type such as blob, a performance tier, an access tier, redundancy settings, and a region. So this is what I have mentioned. Like when you're creating a resource, for example, here the example we have taken is the blob storage. So we are selecting the performance tier, then access tier, redundancy settings, and a region. So these are the factors that is going to decide the cost. So creating the same storage account in different region may show different costs, and changing any of the settings may also impact the price. Similarly for a virtual machine creation. So in the virtual machine creation also, so we have a region, then we have the security type, and also the redundancy availabilities. So when you choose that, then also your cost may vary based on your settings and based on the region you choose. Next is a consumption. So pay as you go has been consistent theme throughout, and that's the cloud payout model, where you pay for the resources that you use during a billing cycle. So if you use more compute this cycle, you pay more. If you use less in the current cycle, you pay less. It's a straightforward pricing mechanism that allows for maximum flexibility. However, Azure also offers the ability to commit to using a set of amount of cloud resources in advance and receiving discounts on those reserved resources. So many services, including database, compute, and storage, all provide the option to commit to a level of use and receive a discount, in some cases up to 72%. When you reserve capacity, you are committing to use and paying for a certain amount of Azure resources during a given period. So with a backup of pay as you go, if you see a sudden surge in demand that eclipses what you have preserved, you just pay for additional resources in excess of your reservation. This model allows you to recognize significant savings on reliable, consistent workloads, while also having the flexibility to rapidly increase your cloud footprint as the need arises. So for consumption, as we know, Azure is a pay as you go. So you use, you pay. But they also provide a plan kind of thing. So it can be for 1 year to 3 years. So they provide. So if you are able to calculate like this much of resources I will be using, then we can pay an upfront fees. Like we pay before we use the resources. So we given a discount based on the amount of resources we will be using, and the amount we pay, we will get a discount on that. If you are able to have a commitment like we will be using this much of resources only for next 2 years or next 3 years, then we will be able to get that discount, and still we will be able to reduce. So on the whole, when our 3 years or 2 years period is finishes, you have paid lesser than what you have used actually. So that's another option available in Azure. Then in the maintenance part, the flexibility of the cloud makes it possible to rapidly adjust resources based on demand. So using resources groups can help keep all your resources organized. In order to control cost, it's important to maintain your cloud environment. Say example, every time you provision a VM, additional resources such as storage and networking are also provisioned. So in the video of VM creation, I will be noting that you would have noticed also, when we create an VM, there will be also other resources created. So it needs those resources when we are creating the VM. Even when we are not creating it, it will auto create. If you have existing networking resources, then you can tap that resource when you are creating your VM. If you deprovision the VM, those additional resources may not deprovision at the same time, either intentionally or unintentionally. This is to avoid if that additional resources is tagged to another resources or another VM. So in order to not disturb it, so only the resource you are deprovisioning will be deprovisioned. By keeping an eye on your resources and making sure you are not keeping around resources that are no longer needed, you can help control cloud cost. Next is the geography, that's the region. When you provision most resources in Azure, you need to define a region where the resources deploys. Azure infrastructure is distributed globally, which enables you to deploy your resources centrally or closest to your customers or something in between. With this global deployment comes global pricing differences. The cost of power, labor, taxes and fees vary depending on the location. Due to these variations, Azure resources can differ in cost to deploy depending on the region we choose. Network traffic is also impacted based on the geography. Say example, it's less expensive to move information within Europe than to move the information from Europe to Asia or South America. The next is network traffic. Billing zones are a factor in determining the cost of some Azure services. Bandwidth refers to a data moving in and out of Azure data center. Same inbound data transfer are free. So when you move something into your data center, like say example from your on premises to your data center, that traffic is free. Then if you move it out of your data center, the data pricing is based on the zone it will be charged. A zone is a geographical grouping of Azure regions for billing. The bandwidth pricing page has additional information on pricing for data ingress, egress. Like data ingress means the data comes in inbound data, egress outbound data, and this is the transferring data. We transfer from one zone to the other zone. So all these factors plays a major role in deciding your operational expenses. Then subscription type. Some Azure types also include usage allowances which affects the cost. Say example, Azure free trial subscription, access to the number of Azure products that are free for 12 months. It also includes credit to spend within your first 30 days of sign up. You will get access to more than 25 products that are always free based on resources and region availability. So this also I have explained in my initial video of resource account creation. So in that you can see this free subscription, and you can use it for 12 months with limited access. Azure Marketplace. So Azure Marketplace is you purchase Azure based solutions and services from third-party vendors. This could be a server with software pre-installed and configured, or managed network firewall appliances, or connectors to third-party backup services. When you purchase products through Azure Marketplace, you may pay for not only Azure services that you are using, but also the services or expertise of the third-party vendor. Billing structures are set by the vendor. All solutions available in Azure Marketplace are certified and compliant with Azure policies and standards. The certification policies may vary based on the service or solution type and Azure services involved. Commercial Marketplace certification policies has additional information on Azure Marketplace certification. So if you are using some other third-party vendor solution or services that is available in the Azure Marketplace, you can utilize it, but that is also going to play a major role in varying your operational cost.
So the price calculator and TCO, the total cost of ownership calculator, are two different calculators that help you understand potential Azure expenses. So Azure, as we have mentioned in the previous videos, Azure helps you to have a approximate pricing of cost flow. So before you enter into using it, you will be able to estimate the cost. Both calculators are accessible from internet, and both calculators allow you to build out a configuration. However, the two calculators have different purpose. So first we'll see the pricing calculator. So the pricing calculator is designed to give you an estimated cost of provisioning resources in Azure. So you can get an estimate for individual resources, build out a solution, or use example scenario to see an estimate of Azure spent. So the price calculator's focus is on the cost of provisioned resources in Azure. With the pricing calculator, you can estimate the cost of any provisioned resources, including compute, storage, and network costs. You can even account for different storage options like storage type, access tier, and redundancy. If you're going to create and use a particular resources, so if you want to predict or know before what the pricing will be, so you can use the pricing calculator. So based on specific settings, as we mentioned in the previous video, you can find in details of the pricing will be like if the redundancy, if you choose the options of redundancy, or if you choose the storage type, what the price might vary. So even for creating a VM, if you're choosing what type of hard disk or type of redundancies, it will give you the more estimated pricing cost. Okay, so here next is our TCO calculator. So the TCO calculator is designed to help you compare the cost of running an on-premises infrastructure compared to a Azure cloud infrastructure. This helps you to calculate or compare the infrastructure cost between the on-prem and also your Azure. So with the TCO calculator, you enter your current infrastructure configuration, including server, database, storage, and outbound network traffic. The TCO calculator then compares the anticipated cost for your current environment with an Azure environment supporting the same infrastructure requirements. With the TCO calculator, you enter your configuration, add in assumptions like power and IT labor costs, and are presented with an estimation of the cost difference to run the same environment in your current data center or in the Azure. So here we have a screenshot of page to find the workloads and report. So you can see here the workload. So workload, the environment is physical server, so operating systems Linux, and number of servers, then procs per server, then core RAM details, optimized by CPU, then if you're having graphics processing unit, so if you're giving all this details, so based on this you will be able to generate a report what the cost will be. So you can compare that with the current on-prem cost. Okay, so here next we will be seeing an lab session, an exercise session to estimate the costing by pricing calculator. So what are the first requirements is before you run pricing calculator, you need to sense of what services you need. So like basic web application hosted in the data center, you might run a configuration similar to the following, like you will have a ASP.NET web application. Then web application provides information about product inventory and pricing. So there are two virtual machines that are connected through the central load balancer. So web application connects to a SQL server database and holds inventory and pricing information. So this is an example infrastructure which is in the on-prem. So to migrate this structure to Azure, so Azure, what the Azure we require is we need Azure virtual machine instances similar to virtual machines used in the data center. Then we need Azure application gateway for load balancing. So we have a central load balancer, so we replace in the Azure with the application gateway for load balancing. Then we have a SQL database to hold the inventory and pricing informations. So in practice, you will define your requirements in greater details, but here are some of the basic facts requirements to get you started. So The application is used internally, it's not accessible to customers. The application doesn't require a massive amount of computing power. The virtual machines and the database run all the time, like it will be running all the time. So the network process about 1 TB of data per month. The database doesn't need to be configured for high performance workloads and requires no more than 32 GB of storage. Okay, so we are currently in the pricing calculator page. So you can just search Azure pricing calculator, then you'll be able to get this link. Okay, so here we will add the resources. So first we will add a virtual machine, then we will look for SQL database. So we look for storage database, then here Azure SQL database, then we add under networking we add application gateway. So these are the three resources we need to calculate for the example we have taken. So here under the virtual machine, you can see the resources that we have added here. So under the virtual machine, so we choose it to be under West US, then the operating system we leave it as Windows and type is OS, then tier we keep it as standard, then for instance we leave it D2, we just leave it the same, then this also we leave it 730, meaning like it will be running forever. Then we go to our SQL database, then under the SQL database we will also move it to West US, then it's a single database, then service tier is general purpose, provision gen 5, and this one we make as 8 vCore. This one also we just leave it the same. Then the redundancy we just leave it same. Yeah, so we just leave it like this. Then the final one will be the application gateway. So application gateway we again change this to the location, we change to West US, then the rest, this one will be web application firewall, and the size we just leave it medium, and also the running hours is same. Then data process we change to 1 TB. So these are based on the current on-prem so outbound we just leave it as 5 GB. Yeah, so actually here we saw 2 virtual machines. Okay, so we have the virtual machine and we have set up the settings, and we have SQL database, we have the properties, and we have this application gateway, we have the properties set up as well. So now we just scroll all the way down. So this is the here you can see the estimated monthly cost. So you can see the estimated monthly cost is 1719. So you can change the currencies like US or your local currency, you can change. You can export into Excel, or if you have logged into the Azure, then you can save it, or you can share. If you log in, then you will save it. In future you can just log in back and you can check on the settings. So like this you can calculate your cost, what will be your cost when you're migrating your applications or migrating your resources to the Azure. So here we took an example of we yeah, here we taken an example to migrate this setting. Like we have a web application, so that has virtual machines connected to load balancer, and that has SQL database server. So that example, when we with the similar network process of 1 TB of data, we have this counts. So when we move it to Azure, so we have estimated it to be like around 1,700 USDs. Here we will be seeing an exercise lab session for comparing the workload cost using the TCO calculator, so the total cost of ownership. So assume like we are considering moving some of our on-premises workloads to cloud. So first we need to understand more about moving from the relatively fixed cost structure onto a monthly cost structure. So you need to investigate whether there are potential cost saving in moving the data center to the cloud over the next 3 years. So you need to take into account all of the potential hidden costs involved in the operating on premises and in the cloud. Instead of manually collecting everything you think might be included, you use the TCO calculator as a starting point. So you adjust the provided cost assumptions to match your on-premises environment. So we take this is our current infrastructure. So it runs two sets or banks of 50 virtual machines in each bank. The first bank of which VMs run Windows Server under Hyper-V virtualization. The second bank runs Linux under VMware virtualization, and also storage area SAN, storage area network, with 60 TB of disk storage. Then consume an estimate of 15 TB of outbound network bandwidth each month. There are also several databases involved, but for now you will omit these details. So this is the current infrastructure, so which we will have to calculate the estimate when moving into cloud. Okay, so we let us go to the okay, so this is our TCA calculator here. Yeah, this is our TCA calculator. So you can just search Azure TCO calculator, then you will be able to find this page. So now we will create the infrastructure which we have seen in the example. So we are adding server. Okay, here we see this is the thing. So okay, so here we have our server. Just we name it as server VMs, and the workload will be Windows Linux server. Then environment is virtual machine, virtual environment. Then operating system is Windows. It's a data center. So number of VMs in this bank, first bank is 50. Then that is Hyper-V, and core is 8, and RAM is 16 GB. Then optimized by CPU. Then we don't run this. Then again second bank, here we name this as servers Linux VMs. So it's still same. Then it's a virtual machine. Then operating system is Linux, and VMs is 50 VM, and this is running on a VMware, and core will be same 8, and RAM will be 16 and optimized by CPU. So the virtual machines, the server part is done. Next we go to the storage. So click on add storage, then this will be server, then it's a local disk SAN HDD. Then the capacity is 60 TB. Then the backup 120, and the archive just leave it to 0. So under networking, the outbound is 15 TB. Okay, so click on next. So here we just leave it to US dollars. We can choose your local currency, and the rest all we just leave it and click on next. So you should be able to view the report. So this time frame you can change to 3 years. So you can see here, and also the region you can change. Say example, I change to US Europe. I change to so you can change the locations so that to have more estimated, because we have seen in our previous costing details. So based on your region you choose, also your pricing will change. So each region will have a differences of pricing for the resource creation and the other maintenance and so on. So here you see for on-premises cost is this blue color, which is quite high. Here it crosses like more than 1.2 million for the time of 3 years, and we see here the Microsoft Azure cost is within 700, around 700 thousands. So this is the total cost of over Azure, and this is the on-premises cost. So you are almost the 50%, like 50% of the cost is half the price you are saving it. So this way you can able to get a total cost for the infrastructure using the TCO calculator, and you can have very specific details of what hardware costing each will be and what is the thing it's been built for Azure. Samely for electricity, you will have a very detailed costing when you use this calculator. Same as the pricing calculator, you still can save this to your reports by signing into your account, and you can view it in the future as well. Microsoft Azure is a global cloud provider, meaning you can provision resources anywhere in the world. So you can provision resources rapidly to meet a sudden demand or to test out a new feature or an accident. So you accidentally provision new resources, you may not be aware of them until it's time for your invoice. So cost management is a service that helps avoid those situations. So what is cost management? So the cost management provides ability to quickly check Azure resources costs, create alerts based on resources spent, and create budget that can be used to automate management of resources. Cost analysis is a subset of cost management that provides a quick visual of your Azure cost. So using cost analysis, you can quickly view the total cost in a variety of different ways, including billing cycle, region, resource, and so on. So use cost analysis to explore and analyze your organizational cost. You can view aggregated costs by organizations to understand where the costs are accrued and to identify spending trends. And you can see accumulated costs over time to estimate monthly, quarterly, and even yearly cost trends against the budget. So cost alerts provide a single location to quickly check on all the different alert types that may show up in the cost management service. The 3 types of alerts that may show up are budget alert, credit alert, department spending quota alert. So we see what is budget alert. So budget alert notify you when spending based on usage or cost reaches or exceeds the amount defined in the alert condition of the budget. Cost management budgets are created by using Azure Portal or Azure Consumption API. The Azure Portal budgets are defined by cost. Budgets are defined by cost or by consumption usage when using the Azure Consumption API. Budget alerts support both cost-based and usage-based budgets. So you can set the limit either cost-based, like say example after $500 you need to create an alert, or the usage-based, like when the resource is used to a certain limit, then it creates an alert. Budget alerts are generated automatically whenever the budget alert conditions are met. You can view all the cost alerts in the Azure portal. Whenever an alert is generated, it appears in cost alerts. An alert email is also sent to the people in the alert recipients list of the budget. Next will be the credit alert. So credit alert notify you when your Azure credit monetary commitments are consumed. So monetary commitments are for organizations with enterprise agreements. Credit alerts are generated automatically at 90% and 100% of your Azure credit balance. Whenever an alert is generated, it reflects in cost alert and in the email sent to the account owners. So spending quota alerts. Department spending quota alerts notify when the department spending reaches a fixed threshold of the quota. Spending quotas are configured in the EA portal. Whenever threshold is met, it generates an email to the department owners and appears in cost alerts. For example, 50% to or 75% of the quota is of the quota. So budgets. A budget is where you set a spending limit for Azure. So you can set budgets based on subscription or resource group or service type or other criteria. When you set a budget, you will also set a budget alert. When the budget hits the budget alert level, it triggers a budget alert that shows up in the cost alerts area. If configured, budget alerts will also send an email notification that a budget alert threshold has been triggered. A more advanced use of budgets enables budget conditions to trigger automation that suspends or otherwise modifies the resource once the trigger condition has occurred. As your cloud usage grows, it's increasingly important to stay organized. A good organization strategy helps you understand your cloud usage and can help you manage cost. So one way to organize related resources is to place them in their own subscription. You can also use resource groups to manage related resources. Resource tags are another way to organize resources. Tags provide extra information or metadata about your resources. This metadata is useful for resource management, then cost management, operation management, security, governance and regulation compliance, workload optimization and automations. So you'll see one by one. Tags enable you to locate and act on resources that are associated with specific workloads, environments, business units and owners. So you can tag the resources, and by that you can group them into business unit or owners or environments. So say if we have a department, sales department, you can tag all the resources that's related to the sales department the same tag, so that you know any resources with this tag, this is the resources for the sales department. So cost management and optimization. Tags enable you to group resources so that you can report on costs, allocate internal cost centers, track budget and forecast estimated cost. So you can know what are the resources, how much does that cost, and based on the tag you know which department is going to incur the cost. So you'll be able to easily estimate or forecast the cost for that department by the resources they are using. Operation management. To enable you to group resources according to how critical their availability is to your business. This grouping helps you to formulate SLAs, and SLA is an uptime for performance guarantee between you and your users. Next, the security. Tag enables you to classify data by its security level, such as public or confidential. Governance and regulatory compliance. Tags enable you to identify resources that align with the governance of regulatory compliance requirements such as ISO 27001. Tags can also be part of your standards enforcement efforts. For example, you might require all resources to be tagged with the owner or department name. So workload optimization and automation. So tags can help you visualize all of the resources that participate in complex deployments. For example, you might tag a resource with its associated workload or application name and use software such as Azure DevOps or to perform automated tasks on those resources. So how to manage the resource tags? So you can add, modify or delete resource tags through Windows PowerShell, Azure CLI and Azure Resource Manager template and REST API or also the Azure portal. So you can use Azure policy to enforce tagging rules and conventions. So for example, you can require that certain tags be added to new resources as they are provisioned. So you can create a policy so that any new resource is been created, then the certain tag has to be applied to that resource. You can also define rules that reapply tags that have been removed. Like if you tag has been deleted or removed from resources, we can have a policy that every resources must have this tag, so that if once removed it will be reapplied also. So resources don't inherit tags from subscriptions and resource group. This is one of the important thing you will have when you're doing certifications, right? You will have questions like this particular resource, this particular subscription has a tag, say example tag 1. Then there is a resource group created under the subscription, and the resource group has these resources, say the VM1 VM2. Then the question will be like, what are the tags that will be VM1 and VM2 will have? So you will have to follow the logic, the how the tags functions, then you should be able to get the answer of that. So resource don't inherit from subscription and resource groups, meaning okay, if a resource group or if a subscription having a tag, so it's not being inherited, and not have those tags automatically show up at the different level, allowing you to create custom tagging schemes that change depending on the level. So if you have a tag on the resource group or on the subscription, it's not being inherited. So the next level of resources, the tags has to be unique. So only you create the tag or tag that resources particularly, it will not inherit. So a resource tag consists of a name and a value. So you can assign one or more tags to each Azure resource. Keep in mind that you don't need to enforce that a specific tag is present on all of your resources. For example, you might decide that only mission critical resources have a impact tag, and all non-tagged resources would then not be considered as mission critical. So it's not necessary that all the resources in a resource group or a subscription must have a tag. So only for required resources you can tag it. The if you don't want to tag a resources, then you can just leave it. So here you can see a screenshot of that, like app name, the name of the application, resource is part of, like then cost center, then owner, the value will be name of the business owner's responsibility, like environment, that value will be production, development or testing or UAT. Impact, how important the resource is to business operations, such as mission critical, high impact and low impact. So if you have the tags with these names, then the value can be as of detailing that name. We will be beginning our next topic, feature and tools in Azure for governance and compliance. So we will be seeing in this series about the purpose of Microsoft Purview, then Azure policy, Azure resource log, and we will see a lab session on how to create a resource log. Then we will see the purpose of service trust portal. First we will start with the Microsoft Purview in this particular video, then followed by Azure policy as well. So here the Microsoft Purview. So what's this? So okay, the Microsoft Purview is actually a family of data governance, risk and compliance solutions that helps you get a single unified view into your data. So Microsoft Purview brings insights about your on-premises, multi-cloud, and software as a service SaaS data together. So with Microsoft Purview, you can stay up to date on data landscape using the automated data discovery, sensitive data classification, end-to-end data lineage. So two main solution areas comprise Microsoft Purview. So that is risk and compliance, then unified data governance. So this risk and compliance for risk, compliance, and legal teams. Then unified data governance is for data consumers, data engineers, and data officers. So is these two solutions combined together to give us Microsoft Purview. Microsoft Purview risk and compliance solution. So Microsoft 365 feature as a core component of Microsoft Purview risk and compliance solution. Microsoft Teams, OneDrive, Exchange are some of the Microsoft 365 services that Microsoft Purview uses to help manage and monitor your data. So Microsoft Purview, by managing and monitoring your data, is able to help your organizations with protect sensitivity data across cloud apps and devices, identify data risk, and manage regulatory compliance requirements. Get started with regulatory compliance, unified data governance. Data Purview has robust unified data governance solution that help manage your on-premises, multi-cloud, and software as a service data. So Microsoft Purview robust data governance capabilities enable you to manage your data stored in Azure SQL, Hive database, locally, and even in other clouds like Amazon cloud. So that's one of the important thing, because it just doesn't help you to manage and monitor the data in your Azure. It also helps to do the same for your other multi-cloud data, also for the SQL databases, also for on-premises databases as well. So Microsoft Purview's unified data governance, the second solution. So create an up-to-date map of your entire data estate that includes data classification and end-to-end lineage. Identify where sensitive data is stored in your estate. Create a secure environment for data consumers to find valuable data. Generate insights about how your data is stored and used. Manage access to the data in your estate securely and at scale. So this is about what so far what we have seen is about the Purview. So next we will discuss about Azure policy. So how do you ensure that your resources stay compliant? Can you be alerted if a resource compliance has changed? So this is a normal question we have when we are having when we speak about on the security point of view. So Azure policy is a service in Azure that enables you to create, assign, and manage policies that control or audit your resources. These policies enforce different rules across your resource configurations so that those configurations stay compliant with corporate standards. How does Azure policy define policies? Azure policy enables you to define both individual policies and groups of related policies known as initiatives. Azure policy evaluates your resources and highlights resources that aren't compliant with the policies you have created. Azure policy can also prevent non-compliant resources from being created. So we can use the Azure policy to prevent the creation of non-compliant resources itself. If a resources is created in a non-compliant way, it can prevent the creation, and also if there is an existence of resources that becomes non-compliant, it can evaluate and highlight the resources that this is non-compliant. We can use it in the both the ways. So Azure policy can be set at each level, enabling you to set policies on a specific resource group, subscription, and so on. So you can set up the policy at resource level, at resource group level, and also for the entire subscription. So additionally, Azure policies are inherited. So this is one of the important thing to take note. So policy Azure policy will be inherited. So if you set up policy at high level, say resource group or subscription, it will automatically be applied to all the groupings that fall within the parent. So we need to take note of this. For example, if you set up Azure policy on resource group, all resources created within the resource group will automatically receive the same policy. Azure policy comes with built-in policy and initiative definitions for storage, networking, compute, security center, and monitoring. So for example, if you define a policy that allows only certain size of virtual machines to be used in your environment, that policy is invoked when you create a new VM and whenever you resize the existing VMs. So Azure policy also evaluates and monitors all current VMs in your environment, including VMs that were created before the policy was created. So here we can see the differences, like using Azure policy we can prevent the creation of a VM that is non compliant with our policy, and after the creation of the VM, if the VM is going to get non compliant, then it will also help to highlight and it will help to prevent the same. So in some cases, the Azure policy can automatically remediate non-compliant resources and configurations to ensure the integrity of the state of the resources. So example, if all resources in a certain resource group should be tagged with app name tag and a value of special orders, the Azure policy will automatically apply that tag if it is missing. However, you still retain full control of the environment. If you have a specific resource that you don't want Azure policy to automatically fix, you can flag that resource as an exception and the policy won't automatically fix that resource. Azure policy also integrates with Azure DevOps by applying any continuous integration and delivery pipeline policies that pertain to the pre-deployment and post-deployment phases of your applications. As we have mentioned in my previous video about the Azure policy, so if you are creating a policy that it should apply a tag with the value of special orders, then even if the tag has been removed manually by any of the user admin, then it will be still reapplied because we have created a policy to have all resources with the tag and the value. So what are the Azure policy initiatives? An Azure policy initiative is a way of grouping related policies together. The initiative definition contains all the policy definitions to help track your compliance state for a larger goal. So for example, Azure policy includes an initiative named Enable Monitoring in Azure Security Center. So its goal is to monitor all available security recommendations for all Azure resources types in Azure Security Center. Under this initiative, the following policy definitions are included. Monitor unencrypted SQL database in Security Center. So this policy monitors for unencrypted SQL databases and servers. Then monitor OS vulnerabilities in Security Center. This policy monitors servers that don't satisfy the configured OS vulnerability baseline. Monitor missing endpoint protection in Security Center. So this policy monitors for servers that don't have an installed endpoint protection agent, say like an antivirus or some kind of protection application is not installed, then this policy will monitor it. In fact, the Enable Monitoring in Azure Security Center initiative contains over 100 separate policy definitions. Azure resource lock prevents resources from being accidentally deleted or changed. So even the Azure role-based rollback policies in place, there's still a risk that people with the right level of access could delete critical cloud resources. Resources locks prevents resources from being deleted or updated depending on the type of lock. Resource locks can be applied to individual resources, resource groups, or even an entire subscription. Resource locks are inherited, meaning that if you place a resource lock on a resource group, all of the resources within the resource group will also have the resource lock applied. So usually at the beginning of our videos we have seen, like it's a good practice to give the users to have a minimum access level. So if a person wants to just write, just we give a role based control that he is able to write only. So we no need to give him an admin access. Similarly, with the people who having access for writing or maybe for deleting a resource, but we don't want them accidentally delete a resource. So in those cases, we can use this resource locks to prevent any accidental delete or accidental update of the resource. So types of resource locks. There are two types of resource locks. One that prevents the users from deleting, and the one prevents users from changing or deleting the resource. So delete means authorized users can still read and modify the resource, but they can't delete the resource. This is the resource lock, delete resource lock. Read only means authorized users can read the resource, but they can't delete or update the resource. Applying this lock is similar to restricting all authorized users to the permission granted by the reader role. So the delete resource lock will not let the user to delete the resource, but they still can read and modify the resource. But when we apply a read only resource lock, they cannot modify, they cannot delete, only they can read the resource. It's like a reader role. How do I manage resource locks? So you can manage resource locks from the Azure portal, PowerShell and CLI, or from an Azure resource manager template. So to view, add or delete logs in the Azure portal, go to the settings section of any resources settings pane in the Azure portal. So you can see here, so this is a storage account, a resource. So you can go to the settings pane here, so down you can find the lock. So from here you can manage the resource locks. So to how do I delete or change the resource locked resources? So we saw if you apply the resource lock, then it will prevent from deleting. So how do we change that? So although the locking helps prevent accidental changes, you can still make changes by following these two steps. So to modify a locked resource, you must first remove the lock. After you remove, you can apply any action you have permissions to perform. Then you reapply the lock. Resource locks apply regardless of role based access control permissions. So even if you are an owner of the resource, you must still remove the lock before you can perform the blocked activity. So we have also seen that resource locks are inherited. So example, if there is a resource group and you have some resources under it, and when you're trying to delete the resource group, in the case of having one of the resource with deletion locked resource, like resource lock, so if that is the case, still it will prevent, because the thing is the when you trying to delete the resource group, it is going to be affected by the lock applied to your resources. That's the VM or whatever resources, that's a resource there you have applied the lock resource, then it will still going to affect it. We will continue with the lab session now. So we go to the Azure portal, then we create a resource. So we create here storage account. So we leave the subscription and resource group default, because I have created the just one resource group. So the storage name, we make it storage and 9924. So we leave the location default, then the performance as standard, and this one we change to LRS to reduce the charges actually. Then we review and create. so it is doing validation. Just in case if the storage account name is already taken, then you will get an error here. So our storage account name seems to be available, so it's deploying the storage account. So once the storage account is created, then we go to the resources. So still deployment is in progress. You can see the status here as well. So you can see under notification, you will see it. It's running and deployment is in progress. Once it's created, then you will have the update here as well. Okay, so deployment is succeeded. So we go to the resource. So once we are in the resource, under settings pane, we can see lock. So here we are going to apply the lock to the resource. So we go select, then we add here, then we lock name, we can give lock 01. Then this lock type we can choose from read only or delete. So we just leave it read only here, then we click OK, then the lock will be created. So we have to add a container to verify the things. So we go to the container, we see so data storage, then here we have containers. Click on container, then we create a container here. So we name the container with storage 9924 container 01. So we have named the container. Now we will be clicking on create. We should receive an error here. The error message, what the error message is, we click it. Failed to create the scope. Storage cannot be performed. Write operation because the following scope are locked. So we have locked the storage account as read only. So I don't have any permission to modify. I mean, like, I don't have any writing permission on it, so I cannot create any containers to that. So now we go back to the, so in this case what I should be doing is we have to go back to the lock, then okay, we should go to the storage account first, then go to the resource settings, we go to the lock. Okay, so here we have our lock we created. So now we have to change this lock type to delete. So I have write access, but I cannot delete the resource. So now we go back to the container. So I try to create a container, take away with other storage for container 01. So click on, So we are able to successfully create the container. So this is the container. So this is the container we have created. So as per the new lock settings we have changed, I don't have delete permission for this lock. So but I will be able to write anything. Now we go back to the storage account under the overview. Now I'm trying to delete. So we select. So these are the resources under that. I'm trying to delete. It's already grayed off because this storage can't be deleted because this resource or its parent has delete lock. Locks must be removed before this resource can be deleted. So as I mentioned, either this resource or the parent. So the locks are inherits the locks from the parent resources. So if you need to delete it, what we will have to do is we have to again go back to our lock section. Then we need to delete the lock first. So once the lock is deleted, then we should be able to. So here's the lock. So I am deleting the lock here first. So there is no more lock. Now go back to the overview. Now here I click on delete. So the storage account name, storage 9924. So it's already able to we don't see the notification here. So previously when there was a lock, we had a notification here. So now we don't see the notification anymore here. So I click on delete. It's asking for confirmation. Confirm delete. Now it's deleting the storage account. So the storage account has been deleted. So this is how we can manage using the lock. So you can create a lock with read only, then we can have delete locks. So if you create read only, then you're not able to write anything. You should be able to read. If you add a delete lock, then you will not be able to delete resources, but you should be able to write on the resources. We'll be discussing the Service Trust Portal here. Okay, the Microsoft Service Trust Portal is a portal that provides access to various content, tools, and other resources about Microsoft security, privacy, and compliance practices. The Service Trust Portal contains details about Microsoft implementation of controls and processes that protect our cloud services and the customer data therein. To access some of the resources on the Service Trust Portal, you must sign in as authenticated user with your Microsoft Cloud Services account. You will need to review and accept the Microsoft non-disclosure agreement for compliance materials. Accessing the Service Trust Portal, so you can access the Service Trust Portal through this link. The Service Trust Portal features and content are accessible from the main menu. The categories on the main menu are Service Trust Portal provides a quick access hyperlink to return to the Service Trust Portal homepage. So my library lets you save or pin documents, quickly access them on your My Library page. You can also set up to receive notifications when documents in your My Library are updated. All documents is a single landing page for documents on the Service Trust Portal. From all documents, you can pin documents to have them shown up in your my library. So these are the main menu in your Service Trust Portal. So once you go to the Service Trust Portal, you can see all these menus. Once you if you want to check any details under the main menu, then you can just click it and go inside the main menu. So let us first go to the link Service Trust Portal. So this is the Service Trust Portal. So you can see the certification, regulation, standard, the main menus here. Then also you can see reports, white paper, and artifacts. on each of the security things. Then industrial and regional resources for your organization. So here also you can redirect it to compliance program feature page. So example, if you want to go check on Singapore MTCS, so this is multi-tier cloud security Singapore standard certification scheme encourages adoption of sound risk management and security practices by cloud services providers. So it says if there is a CSP in Singapore, then they will have to follow this multi-tier cloud security Singapore standard certificate. So they will have to follow all these things. So if say example, if you are going to establish or running a CSP in Singapore, then we can pin this to our library, and if there is any update in the document of this, then we can set up to get a receiver notification on that, so that we will be kept updated about the policies and standards, so we can follow that strictly. So just click on, so you can see, you can go through the details here. Same as this, you can go through on all the other standards and regulations also. So anything you want to go through, like Australia IRP, then ISO, then SOC, systems and organization control, then GDPR, general data protection regulation. So you can go through any of this to find out, and you can add them or pin them to your My Library also. Under the tools, to get the most out of Azure, you need a way to interact with the Azure environment, the management group, subscription, resources, and so on. Azure provides multiple tools for managing your environment, including Azure Portal, Azure PowerShell, Azure Command Line Interface. So we know, like, we have in Azure environment, we have like management group, subscription, resource groups, and everything. So if once you are able to interact with all those environment very easily, only then you can get the most output from that. So far in our video, we have seen the exercise lab, and also in the initial part of accessing to the Azure, we have discussed more about this Azure Portal, Azure PowerShell, and command line interface. So here we will be discussing in detail about those tools. First will be Azure Portal. So this Azure Portal is a web-based unified console that provides an alternative to command line tools. With the Azure Portal, you can manage your Azure subscription by using a graphical user interface. So using this, you can build, manage, and monitor everything from simple web apps to complex cloud deployments. Create custom dashboards for an organized view of resources. Configure accessibility options for an optimal experience. The Azure Portal is designed for resiliency and continuous availability. It maintains a presence in every Azure data center. This configuration makes the Azure Portal resilient to individual data center failures and avoids network slowdowns by being close to the users. The Azure Portal updates continuously and requires no downtime for maintenance activities. So important thing about Azure Portal is usually it's since it's a web based, so we might have a question like, if will that be having any downtime, or will that have any difference in accessing, like speed of accessing, since I'm located in a different location, or I'm located not in a prime location, so there might be it might take a longer time in accessing to the website. So to answer all these questions is no, like there will be no downtime, and from wherever you are accessing to it, you will be accessing it with good network speed, as you will be accessing to the nearest users, nearest center. Even if there is a data center failure or any kind of down maintenance happening, still the users who are accessing to the portal will access it as normally. They will not feel any difference of it. So that's one of the biggest advantage of using the Azure Portal. So let us see some details about in a video.
The Azure Portal is your one-stop graphical management solution for creating, configuring, and controlling all your Azure services and subscriptions. The portal makes it easy to create resources through a wizard-like environment, from something as simple as a website to a geographically redundant database to a full Kubernetes cluster. Once you have resources created, the portal lets you adjust the various parameters and settings for your resources, add users to your cloud-based Active Directory, implement security policies, and plan backup schedules. You can personalize your portal experience through custom dashboards that you create to see the data that is most important to you. Within the portal, you can start and stop services as needed. You can scale your services by adding or removing resources from your subscription according to your business needs. You can also monitor the health of your applications, track your costs and billing status, analyze the performance of your applications in real time, or create reports for in-depth analysis. The Azure portal is your gateway to managing everything in your Azure subscription, whether you are creating new resources, configuring existing resources, or controlling Azure services. The Azure portal is your place to manage your company's business on Azure.
Okay, next we will be seeing about Azure Cloud Shell. So Azure Cloud Shell is a browser-based shell tool that allows you to create, configure and manage Azure resources using a shell. Azure Cloud Shell support both Azure PowerShell and Azure command line interface, which is a bash shell. You can access Azure Cloud Shell via Azure portal by selecting the Cloud Shell icon. So this icon. Azure Cloud Shell has several features that make it a unique offering to support you in managing Azure. Some of the features are: it is a browser-based shell experience with no local installation or configuration required. It is authenticated to your Azure credentials, so when you log in, it inherently knows you are and what permission you have. You choose the shell you are most familiar with. Azure Cloud Shell supports both Azure PowerShell and Azure CLI. So actually, when in the Azure Fundamentals playlist, in the earlier videos when we did exercise, so I have shown you in that video you can watch. I have shown the access to Azure Cloud Shell. So once we are into Azure portal, and there will be option to go into Azure Cloud Shell. So just clicking on the option, it will open the another screen which will be a command line interface kind. So that will not have a separate authentication, because already I am into Azure PowerShell, Azure portal, which is logged in with my Azure account. So once I am moving to Azure Cloud Shell, it auto authenticates based on my the portal login. So straight away log into the Cloud Shell. Then from there I can use the command line to manage the resources, like create, configure, or whatever managing you need to do with the resources you can do using the Cloud Shell there. Next will be Azure PowerShell. So Azure PowerShell is a shell which developers, DevOps and IT professionals can run commands called commandlets. These commands call the Azure REST API to perform management tasks in Azure. Commandlets can be run independently to handle one-off changes, or they may be combined to have orchestrate complex actions such as routine setup, tear down and maintenance of a single resource or multiple connected resource, deployment of an entire infrastructure which might contain dozens or hundreds of resources from imperative code. Capturing the commands in a script makes the process repeatable and automatable. In addition to available via Azure Cloud Shell, you can install and configure Azure PowerShell on Windows, Linux and Mac platforms as well. So this Azure PowerShell is mostly used by developers, DevOps and IT professionals. So using this, they can easily run these kind of complex actions, like you can deploy an entire infrastructure which might contain dozens of hundreds of resources with imperative code. So once you set up everything, then you can just create a entire infrastructure. Even you can use DevOps to set up. For example, you can do a setup coding in the background already. So once you have to create a server, for example, so it will just, you can input the details, like I want it in this what network and what under what OAS and details, some the details it requires. Once you are given, it will just up your server, and it will connect the connections whatever you have given, and it will straight away set up the infrastructure for you. So we can do this complex actions with just coding once. So it's going to be a one-time effort. So once you have prepared it, then anytime you need to prepare up your server or create a new server, just you can use the same process. So such kind of things can be easily achieved by using Azure PowerShell. Then Azure CLI. The Azure CLI is a functionality equivalent to Azure PowerShell, with the primary difference being the syntax of the commands. While Azure PowerShell uses PowerShell commands, CLI uses Bash commands. The Azure CLI provides the same benefits of handling discrete tasks or orchestrating complex operations through code. It's also installable on Windows, Linux, and Mac platforms, as well as through Azure Cloud Shell. Due to similarities in capabilities and access between Azure PowerShell and Bash-based Azure CLI, it mainly comes down which language you are most familiar with. Also, we have shown the difference of this in my previous video, like we can switch actually in the Azure Cloud Shell. You will be, once you are into Azure Cloud Shell, then you can able to switch between the Azure PowerShell and CLI. So we will be discussing about the resources, logs, and the purposes. Also, we will see a lab exercise on resource logs. Describe features and tools for managing and deploying Azure resources. This will be our next section, and we will describe the tools for interacting with Azure, then the purpose of Azure Arc, then Azure Resource Manager, and Azure ARM templates under this section. Managing hybrid and multi-cloud environments can rapidly get complicated. So Azure provides a host of tools to provision, configure, and monitor Azure resources. What about the on-premises resources in a hybrid configuration, or the cloud resources in a multi-cloud configuration? So in utilizing Azure Resource Manager, so ARM in short, Arc lets you extend your Azure compliance and monitoring to your hybrid and multi-cloud configuration. So the utilizing the ARM and Arc will let you make the monitoring and Azure compliance easy when using the hybrid or multi-cloud configurations. Azure Arc simplifies governance and management by delivering a consistent multi-cloud and on-premises management platform. Azure Arc provides a centralized, unified way to manage your entire environment together by projecting your existing non-Azure resources into ARM. Manage multi-cloud and hybrid virtual machines, Kubernetes clusters, and databases as if they are running in Azure. Use familiar Azure services and management capabilities regardless of where they live. Continue using traditional IT ops while introducing DevOps practices to support new cloud and native patterns in your environment. Configure custom locations as an abstraction layer on top of Azure Arc enabled Kubernetes clusters and cluster extensions. What can Azure Arc do outside of Azure? So currently Azure Arc allows you to manage the following resource types hosted outside the Azure, like servers, Kubernetes clusters, Azure data services, SQL server, and virtual machines. So virtual machines we can have preview. So this is all about the Arc. So using Arc provides the centralized, unified way to manage multi-cloud, hybrid virtual machines, and also projecting your existing non-Azure resources into ARM. is very familiar Azure services and management capabilities regardless where they live. So these are the advantages of using the Azure Arc, and it can also support with outside the Azure hosting with managing these resources. So next will be Azure ARM templates, resource manager and ARM templates. So Azure Resource Manager is the deployment and management service of Azure. It provides a management layer that enables you to create, update, and delete resources in your Azure account. Anytime you do anything with your Azure resources, ARM is involved. When a user sends a request from any of the Azure tools like API or SDK, ARM receives the request. The ARM authenticates and authorizes the request. Then ARM sends the request to the Azure service, which takes the requested action. You see consistent results and capabilities in all different tools because all the requests are handled through the same API. This is one of the important thing you will have to take note what is the importance of using the ARM. So Azure ARM resource benefits. So you can manage your infrastructure through declarative templates rather than scripts. A resource manager template is a JSON file that defines what you want to deploy to Azure. So deploy, manage, and monitor all the resources for your solution as a group rather than handling these resources individually. Redeploy your solution throughout the development lifecycle and have confidence your resources are deployed in a consistent state. Define the dependencies between resources so they are deployed in the correct order. Apply access control to all services because RBAC, that is natively integrated into management platform. Apply tags to resources to logically organize all the resources in your subscription. Clarify your organization's billing by weaving cost for a group of resources that share the same tag. So these are the benefits of using Azure Resource Manager. So we'll now see a video on
Azure Resource Manager is at the center of managing resources in Azure. It provides a management layer that enables you to create, update, and delete resources in your Azure account. Every time you send a request to manage resources in Azure, Azure Resource Manager handles that request. Whether you are using the portal, command line, Azure SDKs, or Azure REST APIs, your request goes through Azure Resource Manager. Azure organizes things this way so that you can be sure you'll always get consistent results regardless of which tool you use to create your resources. It also gives each tool the same power and capabilities. Suppose you are an IT engineer and you need to create a virtual machine. Azure Resource Manager authenticates your request and checks whether you are authorized to create the compute, storage, and networking components. If everything validates, Azure Resource Manager forwards your request to the Azure services where they create the actual resources. Azure Resource Manager provides resource groups that let you organize related resources. By allocating them to a resource group, you can more easily manage them, such as moving all related resources to a new subscription or deleting them with one action. When you're ready to automate your Azure deployments, you can use infrastructure as code. ARM templates, Bicep, and Terraform are infrastructure as code options. These tools enable you to reliably deploy your infrastructure to any environment, such as development, staging, or production. Azure Resource Manager also leverages existing Azure role-based access control for subscriptions, resource groups, and resources, so access rules are used, regardless of the client you're using. Azure Resource Manager works in the background to manage and organize resources in an Azure subscription. By understanding these fundamental concepts of Azure Resource Manager, you can efficiently deploy and manage your resources on Azure.
Okay. So next will be infrastructure as code. So infrastructure as code is a concept where you manage your infrastructure as lines of code. At the introductory level, it's things like using Azure Cloud Shell, Azure PowerShell, or Azure CLI to manage and configure your resources. As you get more comfortable in cloud, you can use the infrastructure as code concept to manage entire deployments using repeatable templates and configurations. ARM templates and Bicep are two examples of using infrastructure as code with the Azure Resource Manager to maintain your environment. ARM templates. By using ARM templates, you can describe the resources you want to use in a declarative JSON format. With an Azure template, the deployment code is verified before any code is run. This ensures that the resources will be created and connected correctly. The template then orchestrates the creation of those resources in parallel. That if you need 50 instances of same resources, all 50 instances are created at the same time. So it will be working concurrently, like all 50 will be upping at the same time, like it's not like one after the other. Ultimately, the developer, DevOps professional or IT professional needs only to define the desired state and configuration of each resource in the ARM template, and the template does the rest. Templates can even execute PowerShell and Bash scripts before or after the resource has been set up. Say you are creating some virtual machine, so for a particular department, so for example for the sales department. So when you create for a sales department, all sales department needs a common application to be installed. So you will have your ARM template created for sales department virtual machine creation. So in that you can also link that to another PowerShell or Bash script that is going to install, or that's going to do some setup in the virtual machine after the virtual machine has been created. So you just run the template. So the template is going to create the virtual machine, do all the connections, and once that's done, at the end we will have a code to run the PowerShell. So that PowerShell will be running, which is going to indeed install the application or do the settings based on the PowerShell script. So everything can be done at one, just running a ARM template. Benefits of using ARM templates. So ARM templates provide you many benefits when planning for Azure deploying Azure resources. Some of the benefits are like declarative syntax. So ARM templates allow you to create and deploy an entire infrastructure declaratively. Declarative syntax means that you declare what you want to deploy, but no need to write the actual programming commands and sequence to deploy the resources. Repeatable results. Repeatedly deploy your infrastructure throughout the deployment lifecycle and have confidence your resources are deployed in a consistent manner. You can use the ARM template to deploy multiple development or test environments, knowing that all the environments are the same. Orchestration. So you don't have to worry about the complexities of ordering operations. Azure Resource Manager orchestrates the deployment of interdependent resources so they are created in the correct order. When possible, ARM deploys resources in parallel so your deployments finish faster than serial deployments. You deploy the template through one command rather than through multiple imperative commands. So this orchestration, in short, we can understand with an example. So usually whoever has worked with the PowerShell commands, we will have we will be using a pipeline to run multiple commands in the single line of PowerShell. So when we do that, we will be running one command after other. So as an example, if you're going to first run get some data from a Excel, the second we are trying to filter out a particular column. Just in case we have put that command wrongly, like we have put the first command as get the detail from the particular column and the second as get the details from the Excel, so it's not going to work. So in this with this orchestration, the ARM resource manager, right, it will be able to deploy the interdependent resources so they are created in correct order. So it will create in the correct order if there is any interdependency, like one resource is dependent on its deployment based on the other resources. Like say example, resource A is dependent on the resource B's creation. So this orchestration will help to create the resource B first, then with that dependency the resource A can be created. So all these things will be helpful, and wherever possible it still will work by creating the resources parallelly, so that you will no need to wait for a longer time for all your resources to be created. Modular files, you can break your templates into smaller reusable components and link them together at deployment time. You can also nest one template inside another template. For example, you could create a template for a VM stack and then nest the template inside the templates of deploy entire environment, and that VM stack will consistently be deployed in each of the environment templates. So that's just we are nesting two templates. So whenever the parent template runs, the nested templates also will be deployed each time. With deployment scripts, you can add PowerShell or Bash scripts to your templates. The deployment script extend your ability to set up resources during deployment. A script can be included in the template or stored in an external source and referenced in the template. Deployment scripts give you the ability to complete your end-to-end environment setup in a single ARM template. Next is Bicep. So Bicep is the language that uses declarative syntax to deploy Azure resources. A Bicep file defines the infrastructure and configuration. Then ARM deploys that environment based on the Bicep file. While like an ARM template which is written in JSON, Bicep files tend to use a simpler, more concise style. So benefits of Biceps are support for all resource types and API versions. So Bicep immediately supports all preview and GA versions of Azure services. As soon as a resource provider introduces new resource type and API versions, you can use them in your Bicep file. You don't have to wait for the tools to be updated before using the new services. Simple syntax. When compared to the equivalent JSON template, Bicep files are more concise and easier to read. Bicep requires no previous knowledge of programming languages. Bicep syntax is a declarative and specifies which resources and which properties you want to deploy. Repeatable results. Repeatedly deploy your infrastructure throughout the deployment lifecycle and have confidence your resources are deployed in the consistent manner. Bicep files are idempotent, which means you can deploy the same file many times and get same resource types in the same state. You can develop one file and represent the desired state rather than developing lots of separate files to represent updates. Again, the orchestration, the same what we have seen in the Azure Resource Manager. Then modularity, you can break the Bicep code into manageable parts by using modules. The modules deploys a set of related resources. Module enable you to reuse code and simplify development. Add the module to a Bicep file anytime you need to deploy those resources. So these are the benefits of Bicep. Monitoring tools in Azure. Under this session, we will be seeing the purpose of Azure Advisor and Azure Service Health. Okay, regarding the Azure Advisor, so Azure Advisor evaluates your Azure resources and makes recommendations to help improve reliability, security, and performance, achieve operational excellence, and reduce cost. Azure Advisor is designed to help you save time on cloud optimization. The recommendation service includes suggested actions you can take right away, postpone, and dismiss. The recommendations are available via Azure portal and the API, and you can set up notification to alert you to new recommendations. When you are in Azure portal, Advisor dashboard displays personalized recommendations for all subscriptions. You can use filters to select recommendations for specific subscriptions, resource groups, or services. The recommendations are divided into 5 categories: reliability, security, performance, operational excellence, and cost. So, reliability is used to ensure and improve the continuity of your business critical applications. Security is used to detect threats and vulnerabilities that might lead to security breaches. Performance is used to improve the speed of your appliances. Operational excellence is used to help you achieve process and workflow efficiency, resource manageability, and deployment best practices. Cost is used to optimize and reduce your overall Azure spending. So, under all from these 5 categories, your Azure advisor will evaluate your resources and it will give you recommendations to improve the security or performance or cost or operational excellence on these categories. So you can follow that Azure advisor, you can check on that, then you will be able to optimize your cloud. Also, this you can set up for specific resource groups or specific subscriptions on or specific services as well. So if you have a resource group just for your testing or which you no need to give much attention to, you can ignore that from your getting Azure advisor alerts. So this is an example screenshot of Microsoft advisor dashboard. So you can see under reliability there's 4 recommendations which will give you medium impact. Then for security there's 20 high impact, 7 medium impact, and 4 low impact. For performance there is no recommendation. For operational excellence there is 1 low impact recommendation, and for cost wise there is 1 high impact and 2 medium impact. So you can see here it's 7,473 USD of savings per year. When you apply this recommendation you will be able to save this much. So you can check on these recommendations. You can have the filtrations here, the subscription types, and you can have the filtration. You can check on the recommendations. If it's applicable for you, then you can just apply the recommendations to achieve that. So next will be the service health. So Microsoft Azure provides a global cloud solution to help you manage your infrastructure needs, reach your customers, innovate, and adapt rapidly. Knowing the status of the global Azure infrastructure and your individual resources may seem like a daunting task. Azure Service Health helps you keep track of Azure resource, both your specifically deployed resources and the overall status of Azure. Azure Service Health does this by combining 3 different Azure services: Azure Status, Service Health, and Resource Health. Azure Status is a broad picture of the status of Azure globally. Azure Status informs you the service outages in Azure on the Azure Status page. The page is a global view of health of all Azure services across all Azure regions. It's a good reference for incidents with widespread impact. Next is Azure Service Health. Provides a narrower view of Azure services and regions. It focuses on Azure services and regions you are using. This is the best place to look for service impacting communications about outages, planned maintenance activities, and other health advisories, because the authenticated service health experience knows which service and resources you currently use. You can even set up service health alerts to notify you when service issues, planned maintenance, or other changes may affect the Azure services and regions you use. Resource Health is a tailored view of your actual Azure resources. It provides information about health of your individual cloud resources, such as a specific virtual machine instance using Azure Monitor. You can also configure alerts to notify you of availability changes of your
cloud resources. So Azure Service Health combine these three different Azure services. One, the Azure Status, which gives you the status of the Azure outages globally. The next is the Azure Health. This provides the view of Azure services and the region which our data center is. And next is the Resource Health. This is for our actual Azure resources. So globally outage status and Azure services and of the regions which our data center is, and finally the resource health of our Azure resource. This is altogether combined and can be seen in Azure Service Health. By using Azure Status, Service Health and Resource Health, Azure Service Health gives you a complete view of your Azure environment, all the way from the global status of Azure services and the regions down to the specific resources. Additionally, historical alerts are stored and accessible for later review. Something you initially thought was a simple anomaly that turned into a trend can readily be reviewed and investigated thanks to the historical alerts. Finally, if a workload you are running is impacted by an event, Azure Service Health provides links to the support. Azure monitors a platform for collecting data on your resources, analyzing that data, visualizing the information, and even acting on the results. Azure Monitor can monitor Azure resources, your on-premises resources, and even multi-cloud resources like virtual machines hosted in a different cloud provider. So it's like a one-point check for everything. On the left is a list of sources of logging and metric data that can be collected at every layer in your application architecture, from application to operating system and network. This on the center is the data platform. So this logging and metric data are stored in the central repositories here as logs, as metrics, and as traces. Then in the right side is the how your registered data is being utilized. So view, like you can have experience in the application, the container, VM. Then you can visualize in the workbook as dashboards using the Power BI report and also Grafana. Then can analyze the data for log. You can use it for log analytics, then metric explorer, and for responding like creating alerts and actions, then auto scaling the VMs, then for integrate like event hubs, logic apps, and import and export APIs. So you can utilize that the metrics, logs, and traces on these different levels. So the data is displayed at different levels for different audiences. You can view high-level reports on the Azure Monitor dashboard or create a custom view by using the Power BI and Costo queries. Additionally, you can use the data to help you react to critical events in the real time through alerts delivered to teams via SMS, email, and so on. Or you can use the threshold to trigger auto-scaling functionality to meet the demand. So Azure Log Analytics. So Azure Log Analytics is a tool in the Azure portal where you will write and run log queries on the data gathered by Azure Monitor. Log Analytics is a robust tool that supports both simple complex queries and data analysis. You can write a simple query that returns a set of records and then use features of Log Analytics to sort, filter, and analyze the records. You can write an advanced query to perform statistical analysis and visualize the results in a chart to identify a particular trend. Whether you work with the results of your queries interactively or use them with other Azure Monitor features such as log query, alerts, or workbooks or log analytics, is the tool that you are going to use to write and test those queries. So in general, like the Azure Log Analytics is used to write or run the log queries on the gathered data from the Azure Monitor.
Next is Azure Monitor Alerts. So Azure Monitor Alerts are an automated way to stay informed when Azure Monitor detects a threshold being crossed. You set an alert condition, the notification actions, and then Azure Monitor Alert notifies when an alert is triggered. Depending on your configuration, Azure Monitor Alerts can also attempt corrective action. So you will set up a threshold. Once that threshold is met in the Azure Monitor, then it will trigger that alert, and that alert can also be a corrective action. As we seen in the previous slide, can be like auto scaling, also can be a response action for a Azure Monitor's alert triggering, or it can be just a alert actions, like it just notify the IT team or the respective owner or the ops team, or whoever we have assigned for. For example, you could set a metric based alert up to notify you when the CPU usage on a virtual machine exceeded 80%. Alert rules based on the metrics provided near real-time alerts based on numeric values. Rules based on logs allow for complex logic across data from multiple sources. Azure Monitor Alerts use action groups to configure who to notify and what action to take. An action group is simply a collection of notification and action preferences that you associate with one or multiple alerts. Azure Monitor, Service Health, and Azure Advisor all use actions groups to notify you when an alert has been triggered.